Let's discuss Unit 1 Discrete Structures and Optimization questions. In a group of 120 people, 65 eat rice, 45 eat bread, 42 eat curd, 20 eat both rice and bread, 25 eat both rice and curd, 15 eat both bread and curd, and 8 eat all the three items. Which of the following is the number of people who eat at least one of the three items? Let's take capital R as the group of people who eat rice. So R is equal to 65 from the given data. B denotes bread eating people, so it is 45. C denotes curd eating people, it is a count of 42. We have the data for both rice and bread. So we denote it using intersection operation here. R intersection B for rice and bread will be 20. R intersection C for rice and curd will be 25. B intersection C for bread and curd will be equal to 15. And we have 8 eat all three items, which is denoted by R intersection B intersection C. We have the total count of people to be 120 here. So out of these 120 people, we have to find how many people eat at least one item. We are going to apply the concept of principle of inclusion exclusion. R union B union C means it's the number of people who eat at least one of the three items. So why have we used this notation is to take only the count. This is given by the count of R, the count of B, the count of C minus the count of R intersection B minus the count of R intersection C minus the count of B intersection C plus the count of R intersection B intersection C. We are going to directly apply the value. R is 65, B is 45, C is 42. We are just taking this minus outside and then adding all these three together. So what is R intersection B? It is 20. What is R intersection C? It is 25. What is B intersection C? It is 15. Then we are adding the intersection of all these three items, which is 8. 65 plus 45 plus 42 will give you 152 minus 20 plus 25 plus 15 will give a count of 60, then this plus 8. 152 plus 8 will give you 160. 160 minus 60 will give you 100. So altogether 100 people eat at least one of the three items. So they have given a count of 120 people. If 100 people are going to eat one of the three items, from this you can also take another count. 20 people will eat none of the three items. So out of these 120, if 100 are going to take at least one item, then definitely 20 people are going to eat none of them. In case if the question is going to be about the number of people who eat none of the three items, then using the same formula you have to find it as 100 and then subtract it from the total group of people. Let's see this particular food preference in the form of Venn diagram. They have given the value for rice, bread and curd separately. It means this rice value 65 includes this 20 and this 25 also. Say for example, if you take 28 plus 12, it will give a count of 40. 40 plus 17 will give 57. 57 plus 8 will give 65. So totally there are 65 people who eat rice. 65 includes people who eat only rice, people who eat rice and bread, people who eat rice and curd, people who eat rice, bread and curd. 65 is the total count of people who eat rice here. So in order to find only rice, you have to exclude bread, curd and curd combination totally. That's how we have brought it to 28 here. Now, how do we get 100 from this particular diagram? 28 plus 12 will give you 40. 40 plus 25 will give you 65. 65 plus 10 will give you 75. 75 plus another 25 will give you 100. Overall, when you add all the numbers in the Venn diagram, you will get 100, which will tell that 100 number of people eat at least one of the three items. So from this we can mark option number 2, 100 as the right answer. Next question. In a pack of 42 cards, 3 cards are chosen one after the other. Find the number of ways this can be done without replacement. It means when you pick the first card out of the 42, you cannot replace it. So for the second picking, you will have only 41 cards. For the third card picking, you will have only 40 cards. This is the idea behind saying without replacement. Now let's see how to solve them. To find the number of ways to choose 3 cards, one after the other, without replacement from a pack of 42 cards, we have to use the concept of permutation since the order of selection matters here. So for without replacement, for the first card we will have 42 cards totally. So it is 42 choices. For the second card, one card is already selected. We have only 41 totally and we are not going to replace it. So out of 41 cards, you are going to choose the second card. For the third card, 2 cards are already taken. So you will have only 40 cards remaining. Out of that, we have to pick the third card. How will we find the total number of ways? You have to just multiply the choices of first card, second card and third card. For first card I have 42 choices. For the second card I have 41 choices. And for the third card I have 40 choices. 42 into 41 into 40 will give a count of 68,880. Option number 3 will be the right answer. This is the case for without replacement. What if the question is being asked as with replacement? We will see that also for learning purpose. If it is with replacement, when you are picking the first card, you will have 42 cards in total. So there are 42 choices. Here choices means it is the number of cards only. You need not confuse them. For the second card, since you are allowed to replace, you still have all the cards in the choice list. So again 42 choices are available. They say the first card is getting replaced. So you have 42 choices again. What about the third card? You are allowed to replace. So still you have 42 cards from which you can choose the third card. So the total number of ways here it will be 42 into 42 into 42, which will give a count of 74,088 ways totally. So if it is with replacement, you have to go in this way. When it is without replacement, you have to stick to this way. So the answer for this question is option 3. But I am just giving you, if the question is going to be with replacement, this will be the answer. Next question. A positive integer selected at random from the set of positive integers not exceeding 200. So you have to consider positive integers. This means you have to start from 1. And they say it is not exceeding 200, so the limit is going to be 200. Which of the following is the probability that the selected number is divisible by either 2 or 5? Already this question has been asked in one of the previous year question paper, but it was not exceeding 100 limit. Let's take A to be the numbers that are divisible by 2. How will we find numbers that are divisible by 2 mathematically? You have to take the floor value of the total positive integers. 200 numbers are there. Divide by the divisibility of the integer that is being asked. So the total value is given and the divisible number has to be given in the denominator and the floor value has to be taken for this numbers divisible by a particular integer. So there are totally 200 integers 1 to 200 and they are asking divisible by 2, so we are giving divided by 2. What is the floor value of 100? It is 100. There is no decimal point, so we are sticking to 100. What about numbers divisible by 5? Floor value of 200 divided by this particular number 5. 5 fours are 20. So it is floor of 40, which is equal to 40. So there are 100 numbers that are divisible by 2. Actually in a count of 200, 100 will be odd and 100 will be even. All the even number will be divisible by 2. So this 100 count is right. Regarding the numbers divisible by 5, you have 40 count of numbers. If you don't go by this method, write in a piece of paper from 1 to 200 and start counting how many are divisible by 2 and how many are divisible by 5. and how many are going to be divisible by both 2 and 5, you will exactly get this count. A intersection B is given by the numbers divisible by both 2 and 5. So this is floor of, you have to take 200 and you have to multiply 2 into 5 here. It means it is divisible by both 2 and 5. So this will be 200 divided by 10 and this will give a value of 20. So 20 numbers are divisible by both 2 and 5 here. We are applying inclusion exclusion principle here again. A union B will give either 2 or 5 divisibility. So you are going to find A union B, which will say either or. This is count of A, this is count of B, and this is count of A intersection B. It means this is numbers divisible by 2, numbers divisible by 5, and numbers divisible by both 2 and 5. So A count will be 100, B count will be 40, and intersection will be 20. 100 plus 40 is 140. 140 minus 20 will give you 120. You have to take this probability of 2 or 5 is given by what is the total number here? 120 divided by what is the total count of integers? It is 200. Whenever you want to take probability of a particular event, it is the number of occurrences of that particular event divided by the sample space count. So here we consider the sample space to be 200 and the event occurrence will be 120. 4 3s are 12 and 4 5s are 20. So 3 divided by 5. Option number 2, 3 divided by 5 will be the right answer. If you are not fine with this particular way, if you think that a probability question has to be addressed with probability alone, we will go with this way. What is probability of A? We know there are 100 numbers that are divisible by 2. So 100 divided by 200, this will give a probability of 1 by 2. What about probability of B? 40 divided by 200. That is, for every value you are going to find probability and then apply it in the formula. This will give a value of 1 divided by 5. What about probability of A intersection B? This will be 20 divided by 200 and you will have 1 by 10 altogether. Now you have to apply this in probability of A union B, which is 2 or 5. So this is for 2, this is for 5, and this is for 2 and 5. 1 by 2 plus 1 by 5 minus 1 by 10. When you take LCM, it is 5 plus 2 minus 1 divided by 10. 5 plus 2 is 7, 7 minus 1 is 6. This will give a value of 6 divided by 10. 2 3s are 6 and 2 5s are 10. You are getting 3 by 5 in this way also. When I discuss one way in the video, some of the aspirants, they are giving the other way to solve in the comments. If you still have some other ways for any other questions, you are always free to mention them in the comments so that every one of us can learn an alternate way of solving the same question. Next question. Consider the Boolean expression A of x comma y comma z is equal to x into y dash z, and only this particular y dash and z are put under dash once again. Which of the following is complete sum of products form of the given Boolean expression? What is complete sum of products? The complete sum of products form means expressing the function as a sum of min terms. What are min terms? The terms where each variable appear in either complemented or in uncomplemented form. So basically this is given in an expression of A of x comma y comma z is equal to x into y dash z and then the whole dash. We have to bring it to a normal form so that we can express it in the form of min terms. So how are we going to solve this? First, let's take only this particular part, y dash z, the whole complement. When you apply De Morgan's law, you have to apply the complement inside and this product will be changing to sum here. and this will become y double dash plus z dash. This will give y plus z dash. Now you have to apply it in A. A of x comma y comma z is equal to x into y plus z dash. So apply the multiplication here. It will be x into y plus x into z dash. Now we have to express this particular expression in the form of complete sum of products. How are we going to solve this? We have to list all combinations of x, y, z where the particular expression is going to have true value. We have to make this particular expression true and this particular expression true. In order to make x and y alone true, what values should you have? We need not worry about the value of z. You should have x as 1 and y as 1 to make them true. In order to have the value of 1 for x into y, what should be the value of x and what should be the value of y? It should be 1 for x and 1 for y. Only then you can have 1 here. That is what they say the expression is true. 1 means true, 0 means false. So what are the min terms possible? We will have xy here. They say regardless the value of z, which means z can be in uncomplemented form or z can be in complemented form. So here the min terms will be xyz and xyz dash. Now we will take the second part, xz dash. When you want to have x to be true, you will take the value of x to be 1. When you want to have z dash to be true, it means the value of z should be false. Only when z is false, z complement will become true here. So we apply x is equal to 1 and z is equal to 0 regardless of y. So we have to take the min terms now. X is equal to 1. So we are presenting x as it is. When you take z is equal to 0, you have to mention it in complement form. So it is z complement and z complement. So you have the expression x z complement here. What about y? They say regardless of y, which means y can be in the form of complement and uncomplemented form. Altogether, how many min terms are there? We have xyz. xyz dash is repeating here. Then we have xy dash z dash. So there are 3 min terms totally. This first 2 is taken for xy and last 2 is taken for xz dash. So what will be the complete sum of products? You have to just give sum of all these min terms, xyz plus xyz dash plus xy dash z dash. Which option is having this particular expression? Option number 4. Option number 4 will be the right answer. Next question, choose the correct statement for a group G. So this question is from group theory. If for all x, y that belongs to group G, xy the whole square is equal to x square into y square, then G is commutative. In group theory, a group G is said to have the commutative property if for all the elements a comma b that belongs to G, the operation satisfies a into b is equal to b into a, and such groups we name them as abelian groups. So commutative property is when left hand side is equal to the right side expression as given here. Now we will just work it out for x, y the whole square. How can you represent xy the whole square? We can represent it as xy into xy. So this is one expression. How will you express x square, y square? This is LHS and this is RHS. Now x square can be written as x into x and y square can be written as y into y. Remove the brackets and write it in this way. How can you say that this particular LHS is equal to RHS? When can this be true? When xy is equal to yx, as we see here in commutative property, we will be able to say LHS is equal to RHS. Say for example, instead of this particular yx, if I am going to place xy, this LHS will become RHS. In case if I am going to place XY by YX, this will become LHS and this will be the RHS. So this particular XY the whole square is equal to X square Y square is definitely commutative only. This condition forces commutativity and so we mark this statement to be true. Without looking the other three options, we can just mark option number 1 to be the right answer because they are asking for the correct statement with regard to this particular group. Now we will go for fourth statement and find what is wrong. If G is commutative, the subgroup of G need not be commutative. We have a statement here. If G is commutative, it means when it is an abelian group, then every subgroup of G is also commutative. If you know this particular property, you can mark option 4 as wrong answer here. That's a fundamental property of abelian groups. Now regarding 2 and 3, x cube is equal to 1, x power 5 is equal to 1. They say 1 is the identity element of G and they have given G is commutative. We have to check whether G is commutative and we have to see whether 1 is the identity element of G. Only when both are going to be true, this particular option can turn to be true. But we know that 2 and 3 are already false. Now we will see what is wrong with 2 and 3. In group theory, the order of an element means the number of times you need to combine the element with itself to get back to the identity element. X cube means you are multiplying x into x into x. This is how we did here. Xy the whole square we multiplied 2 times. X square we multiplied x 2 times and y we are multiplying it 2 times. If x is an element in a group, x cube is equal to 1 means x has an order of 3. The power is what they call as order. X power 5 is equal to 1 means x has order of 5. Here 1 is the identity element. So this statement is fine. This particular property is only wrong. How is this particular property wrong? Saying x cube is equal to 1 means every element in the group when multiplied by itself 3 times gives the identity. So they say when x gets multiplied for 3 times, it results in identity element and when it is multiplied for 5 times, it results in identity element for statement 3 and this is for statement 2. But this does not guarantee that the group is commutative. Even though some elements satisfy x cube is equal to 1, this group by default it is non-abelian. When it is abelian, it is commutative. Only when the property of commutativity comes inside, we call it as abelian group. When they say it is not commutative, automatically we say it is non-abelian group. When the group itself is non-abelian, we can confirmly say that it does not belong to commutative aspect. So from this we can say option 2 is wrong. There exist non-abelian groups, that is non-commutative groups where every element has order 3. Similarly, there are non-abelian groups where every element has order 5. It does not guarantee commutativity is what they say and so this particular option is also wrong. Next question. Let P denote she is intelligent and let Q denote she is happy. Given below are the statements. They have given 4 statements. They are asking which one of the following is correct propositional expression for the above statements. So we have to find the propositional expression of all the 4 statements and then check which of the option is having the right one. In this channel we have a series called CS Connect series. Under this we have mathematical logic playlist and you have propositional logic, propositional equivalences. 2 videos are available. If you go through them when you have time, you will definitely be able to answer this question without any doubt. If she is intelligent, then she is unhappy. Q denotes happy. When it is unhappy, this is negation of Q. P denotes she is intelligent. When they say not intelligent, then we have to go with negation of P. You have to remember this. Regarding propositional logic, we know conditional statement means P implies Q, which says that if P, then Q. Now this is in the form of if P, then Q. But instead of Q here it is unhappy, so it is negation of Q. So this can be expressed as P implies negation of Q. If she is intelligent, then she is unhappy. Happy is capital Q. Unhappy is negation of capital Q. We'll go for the next statement. She is neither intelligent nor happy. What is neither nor denotion? Neither nor means not intelligent and not happy. When both the nots are combined by and operator, at that time we will use neither nor. This explanation is also given in that CS Connect series video. Not intelligent is negation of P, not happy is negation of Q, unhappy or not happy both are negation of Q, and we have and operator here, so we use conjunction operation. So the second expression is negation of P, conjunction, negation of Q. So this is the first one, this is the second one. What about C? It is necessary to be not intelligent in order to be happy. Actually, there are various ways of expressing conditional statements and biconditional statements in English. So in that CS Connect series video, there I have listed all the possibilities of English statements. Right now, to solve this question, I will give you the correct form of this particular statement. If she is happy, they say she is not intelligent. This is the statement that is given in this particular format. It is necessary to be not intelligent in order to be happy. They say if someone wants to be happy, they say that person should not be intelligent. So if you take it in the form of conditional, it is if she is happy, then she is not intelligent. Now you can translate this as if she is happy is Q, not intelligent is negation of P. Since we have if and then, we go with conditional. So the expression is Q implies negation of P. Let's go to D. To be not intelligent is to be unhappy. Here both are giving negation, but the statement is in this form. If she is not intelligent, then she is not happy. This is the other way of writing in English. So you have to know the other forms of English statements, of conditional statements. Only then you will be able to translate both C and D. Otherwise it will be quite difficult for you to understand. Now you can translate this particular statement. She is not intelligent, which is negation of P. She is not happy is negation of Q. When you have if and then, this becomes conditional operation here. Now we have all the four expressions. With A and B, first we will check whether we are able to find the answer. P implies negation of Q is found in 3 of the options. So from this we can rule out option 2. What about B? Negation of P and negation of Q. It is available in 2 of the options. So from this we can rule out option 1 and option 4 also. So just based on A and B, you will be able to mark the answer as option number 3. Now we will just check for Q implies negation of P. It is given here correctly. What about negation of P implies negation of Q? It is given correctly. Next question. Let M and N are positive integers. It means it is greater than 0. There are no negative integers here. Then they have given A, B, C statements and they are asking which of them are correct here. So let's start with A. If N is not equal to 1, then M is less than M into N. We know M is going to be 1 or any other number that is greater than 0. N is also going to be the same way. If they say N is not equal to 1, N can take any value from 2. M is less than M into N. When you have 1, 1 is less than 1 into 2. 1 is less than 2. when you have m is equal to 2, n value is also equal to 2 because it is not equal to 1. So m into n will be 4. In all cases you have m is less than m into n. So this statement is perfectly true. If n is not equal to 1, then m is less than m into n. Since n is having the value greater than 1, multiplying m by n always increase its value. So m into n is greater than m is always true when n is not equal to 1. They have said m and n are positive integers, which means m is greater than 0 and n is greater than 0, and they say n is also not equal to 1, which says that n is greater than 1. N cannot be equated to 1. When the case is m greater than 0 and n greater than 1, definitely m into n is greater than m, or you can specify this as given in the question statement as m less than m into n. When you say 4 greater than 2 or 2 less than 4, both are same only. We have k is composite in B and D statements, so we will just check with C and then get back to B and D. What about C? If m into n is equal to 1, then m is equal to 1 and n is equal to 1. When the product of two numbers is equal to 1, what are the two possible values here? When you have m is equal to 1, n is equal to 1, you will have m into n is equal to 1. What is the other possibility? When you have m is equal to minus 1 and n is equal to minus 1, in that case also you will have mn is equal to 1. But here they have mentioned m and n as positive integers, which will eradicate this particular possibility. So the only way to get m into n as 1 will be m is equal to 1 and n is equal to 1, which is perfectly true. Since m and n are positive integers, the only way their product is 1 is to have both the values as 1. So this is true and this is true. A and C is included here, A and C is included here. So from this we can rule out 2 and 3. Now we have to understand one thing. Only one of B or D can be true. If k is composite, then k is equal to m into n, where 1 less than m, n greater than k. When you take D, if k is composite, then k is equal to m into n, where 1 is less than m, n is less than k. So this particular criteria is alone changed in both the statements, and we have to find the right one, and only one can be right. A composite number k is defined as the number that can be written as a product of two positive integers, both strictly greater than 1 and less than k. We have prime number and composite number. Prime number is when the number is divisible by 1 and itself. Composite number is when you are able to express it in the product of any other two numbers other than 1 and itself. So when you take 6, it's a composite number. How can you express this? 2 into 3. You are expressing it in the form of product of two positive integers. So when you take 10, it is 2 and 5. When you take 2 and 3, are they greater than this particular k or less than k? Both are actually less than k. This k is the composite number here, and these values are m and n. When you take m and n, both are actually less than k is what they say. If k is equal to m into n, the product of two positive integers, then 1 is less than m is less than k. It means m can have a value from 2 to k minus 1, 1 less than n less than k. N can be expressed from 2 to k minus 1. In both the cases, 1 is excluded and k is excluded. When a number is divisible by itself and 1, that becomes prime number. Except then, everything is composite number, means those two numbers are taken out. So 1 and k are taken out. Anything between them can be the range. This means that neither m nor n can be greater than k. In that case, this particular expression fails, and so we know B is definitely false. So the option that includes B can be ruled out. The expression is actually 1 less than m, that is m is greater than 1, and m is less than k. This can be written as 1 less than m less than k. What about 1 less than n less than k? This can be expressed as 1 less than n less than k. So this condition is expressed here and this condition is expressed from here. So this is right, n less than k is also right, but this one is wrong. So D is also right, so we are marking it to be true. So option number 1, ACD will be the right answer, and I have told you why B is false. If D is true, then B is definitely false. Next question, match list 1 with list 2. We will first understand what is inverse, converse, contrapositive. Conditional statement means P implies Q. So it is if P then Q. What about contrapositive? Negation of Q implies negation of P. This can be expressed as if not Q then not P. What about converse? Q implies P. If Q then P. What about inverse? Negation of P implies negation of Q. If not P then not Q. Converse is actually swapping the original conditional statement, and contrapositive is logically equivalent to the original statement. So let's take P is equal to true and Q is equal to true. They say if P is true, Q is true. What is negation of Q? It is false. What is negation of P? It is false. So I am just swapping the places and giving conditional. They say if Q is false, then P is false. So the same statement is written in negated terms, that is contrapositive. So both these statements are actually logically equivalent is what they are trying to tell. There is a big challenge here. We don't know what is P and what is Q. They have given two statements here. Indian team wins, and the next one is it is raining. One should be P and one should be Q. Indian team wins can be taken as P and raining can be taken as Q. We will start with this. We will check whether any of the option is actually matching. If not, we have to take Indian team to be Q and raining to be P. So first we will start with Indian team wins to be P. So when it is not winning, this will become negation of P. When it is not raining, this will become negation of Q. If Indian team wins, it is P, then it is raining, it is Q. So P implies Q. What is P implies Q? It is conditional statement which is mapping to option 4 in list 2. Is A4 available here? No. Which states that our choice of selection of clauses is wrong. Indian team wins becomes Q and it is raining becomes P. So negation of Q will be not winning and negation of P will be not raining. In one of the earlier question they have mentioned this is P and this is Q clause. So we were able to find the expression in a quick way. But here we don't know what is P and what is Q. Just based on these 4 options only, we will be able to find which is Q and which is P. If the Indian team wins, if Q, then it is raining means then P. What is if Q then P? It is Q implies P. What is Q implies P? It is converse. A will be mapping to 2. Is A2 available here? Yes, it is available. So definitely Indian team will be Q clause and raining will be P clause. Since we don't have the combination of A4, we are ruling out P as Indian team winning and Q as raining. We are not selecting it because we are not given A4 as the option in any of the listed options 1, 2, 3, 4 here. That's why we are taking Q is equal to Indian team wins and P is equal to raining. Now let's get into B. If Indian team does not win, it means if negation of Q, then it is not raining, then it is negation of P. So it is negation of Q implies negation of P, which is contrapositive. B is mapping to 3. B3 is available here. We can rule out 2 and 4 from A itself. And now we are even ruling out option 1. What about C? If it is raining, if P, then the Indian team wins. It is then Q. This is the perfect conditional statement. P implies Q. C is mapping to 4. What about D? If it is not raining, if negation of P, then the Indian team does not win is negation of Q. So negation of P implies negation of Q is inverse. D will be mapping to 1. Option number 3, A2, B3, C4, D1 will be the right answer. With this we are completing Unit 1 questions. Let's solve Unit 2 Computer System Architecture questions. Binary equivalent to A0F to the base 16 is, whenever we see the base 16, we should understand that it is in the form of hexadecimal number. This is the decimal, binary and hexadecimal equivalent. When it is octal to binary, 3 bits will be involved. When it is hexadecimal to binary, 4 bits will be involved. Because to represent the final hexadecimal digit, that is 15, you need 4 bits of ones. That's why we need 4 bits to represent hexadecimal number. Now we will write this as A0F. What is A? A is 10, F is 15. So what is the binary equivalent of decimal number 10? It is 1010. So we will have 1010 here. For 0 we will have 4 number of zeros, and for F, which is 15, we will have 1 bits in all the 4 places. These 3 all together will give you the binary equivalent of the hexadecimal number A0F. This particular option is having the exact answer. Option 3 will be the right answer. 1010 for A, 0000 for 0 and 1111 for F. How did we get this binary values? You have to take 2 power 0, 2 power 1, 2 power 2 and 2 power 3. This is 1, 2, 4 and 8. When it is 8 plus 2, we get 10. So we will place 1 in front of 8 and 2 and ultimately we will get 1010 for A. And for F, it is 8 plus 4, 12, 12 plus 2, 14, 14 plus 1 is 15. So we will have 1 in all the 4 places. This is how we are getting the binary equivalent. All the 4 base conversions will be dealt in number system playlist in CS Connect series. Next question. The right operation in IO operation does the following. What is generally right operation with respect to memory? We are just writing some value onto the memory. Here the right operation is asked in the context of IO operation. Let's take the options one by one. Transfer data from IO device to memory. So from the input output device, you are transferring the data to the memory. What is this operation in IO? This is a read operation where data is transferred from an IO device to the computer's memory. So this is a read operation in the context of IO. So one is ruled out. What about second one? Transfer data from memory to IO device. This is the right operation that has been asked in the question. Data stored in the computer's memory is transferred out to a peripheral device like a printer, hard drive or monitor, any IO device. So when it is write operation in memory, you are writing it to the memory. When it is write operation in IO, you are writing it to the IO device. So in this way, you have to compare both the right operations. So option number 2 will be the right answer for this question. What about option 3 and 4? Option 3 says transfer data from CPU register to memory. While data frequently moves between CPU register and memory, this is not considered a specific IO operation. This is actually an internal data transfer within the CPU is what they say. What about the final option? Transfer data from CPU register to IO device. Although the CPU might temporarily hold data before transferring it to the IO device, the actual write operation occurs directly from memory to the device. So they say the actual write occurs from memory to the device, which is provided in statement 2. The transfer from CPU register to memory is a step in the process, but it is not the defining characteristic of a write operation with respect to IO. So we are ruling out both 3 and 4 also. So whenever you learn from previous year question paper, it is always good that Apart from knowing the right answer, you should know why the other options are not the right answer. Through this only you can take some kind of additional learning. Next question. The transformation of data from main memory to cache memory is referred as. Seeing all the four options, you can understand only one term will be related to what we are discussing in computer system architecture content. Regarding data exchange, data transformation and matching, they are normal terms. But when you see the term mapping, you should have a doubt in that word only. The transformation of data from main memory to cache memory is referred to as a mapping process. And three types of mapping procedures are considered: associative mapping, direct mapping and set associative mapping. We will go with option number 3 as the right answer. Next question. Gray code equivalent to decimal number 8. So this is again another kind of binary code which is called as gray code. In CS Connect series, we have data representation playlist, and in that playlist we have detailedly discussed about gray codes. So for this question, let's see what is a gray code. Gray code is otherwise called as reflected binary code. This is a binary numeral system where successive values differ by only one bit. So I'll just give you the list of gray code for the decimal equivalent here. When you take the binary code, it follows this pattern 8, 4, 2, 1. So when we say 8, it becomes 1,000,000. When we say 4, it is 0100. This is 4, and for 5 we have 101. Here for 6 we have 110. There are 2 bits actually changing between 5 and 6 here. When you take 7, it is 0111. Between 7 and 8, you can see 4 bits are getting changed. This is how we find binary equivalent with respect to 2 power 0, 2 power 1, 2 power 2 and 2 power 3. This is the case of binary. But when you take gray code, the successive numbers will have only 1 bit changing. Say for example, let's start with gray code for decimal value 0. We will consider only these two columns as of now. So this is 0. For 1, we are just flipping this bit to 1. For 2, we are having this bit in the same place, but we are flipping the last but second bit. Only 1 bit is getting changed. When you go for 3, we are keeping this particular bit as it is and we are changing the final bit. The successive values between 0 and 1, between 1 and 2, between 2 and 3, between 3 and 4, the values will be differing only by 1 bit is what they say. Now they are asking for decimal number 8. So we have to check this particular row. The value is 1100. This is available in option number 2. Option 2 will be the right answer. So if you want to know gray code, you have to understand how the bits are getting flipped one by one, how they are differing. Only then you will be arriving in the same pattern as it is given in these books. 0001 is actually changing to 0011. Between 1 and 2 there is 1 bit change. You can also shift it in another way like this, but this is not the gray code that is given in the book. So in order to not go in this way, you have to understand how these bits are getting flipped. First they are flipping the most significant bit, that is the final bit. Then they are flipping the second but final bit. Then they will keep second bit constant and then flip the last bit again. So this will follow the pattern of 00011110. Even if you take Boolean algebra simplification process, when you take 3 variable, you will have A here and BC here. The values will be in this form: 0001, 11 and 10. The successive value will be differing only by 1 bit. That is the concept we apply in gray code. Next question. The computer needs to process each instruction with the following sequence of steps: calculate effective address, fetch instruction from memory, decode instruction, fetch the operands from memory, execute the instruction. This has been quite a repeated question in few of the previous year question papers. So even if you have gone through them, you could have answered this question for this particular session. In the basic computer, each instruction cycle consists of the following phases. The first process will be fetch an instruction from memory. Here it is available in B. Then we go with decode the instruction, which is C. We have read the effective address from memory if the instruction has an indirect address. So reading the effective address is nothing but we are calculating the effective address. After calculating the effective address, what are we actually fetching? We are going to fetch the operand. So fetch the operand from the memory is D. Only when you have the address in step A, you can get the operand in step D is what I am trying to tell you. Execute the instruction is E. We have the order of B, C, A, D, E, which is available in option number 3. Option 3 will be the right answer. Next question. The right sequence of sub-operations that are performed in arithmetic pipeline is. We will go with floating point representation of a number. Usually this representation will have two parts. The first part represents a signed fixed point number called the mantissa. The fixed point mantissa may be a fraction or an integer. It can be like 1, 2, 3 or it can be 0.1, 0.2 something in that form. The second part designates the position of the decimal point and it's called the exponent. So we have two parts. One is the mantissa and the other one is exponent. Adding or subtracting two numbers requires first an alignment of the radix point, since the exponent parts must be made equal before adding or subtracting the mantissas. Say for example, we have something like 2 into 10 to the power minus 2 and 3 into 10 to the power minus 3. Only when you equate these two powers, the exponent part, we can actually apply addition or subtraction process to the mantissa part is what they say. The alignment is done by shifting one mantissa while its exponent is adjusted until it's equivalent to the other exponent. Instead of writing as 2 into 10 to the power minus 2, we can write it as 20 into 10 to the power minus 3 in order to equate it to this particular value. This is one way. Otherwise, you can keep this particular value as it is, and this 3 can be written as 0.3 into 10 to the power minus 2. So whether it is 3 into 10 to the power minus 3 or 0.3 into 10 to the power minus 2, the value will be 0.003 only. But when you are going to apply addition or subtraction, they say the exponent part must be equal in order to add or subtract the mantissa part. It is necessary that two exponents be equal before the mantissas can be added. The algorithm can be divided into 4 consecutive parts. We have to check for zeros, align the mantissas, add or subtract the mantissas, normalize the result. A floating point number that is 0 cannot be normalized. Now we will see the steps given in the options. So align the mantissa is A, add or subtract is B, normalize is C. They say compare the exponents. What is this step actually? They are saying the two exponents must be equal. When will you know they are equal? Only when you compare it, you will know they are equal. So comparison occurs first, which is D. The order will be D, A, B, C, which is available in option 1. Option 1 will be the right answer. I will give you a small example that was available in the reference book. Here we have 0.5 into 10 to the power 2. And here we have 0.15 into 10 to the power minus 1. We are keeping this particular floating point number as it is. We are actually changing this particular number. They are just converting this to the same exponent value 10 to the power 2. And then they are working with the mantissa part. In order to add two mantissa part, we have to have the exponent as equal. So now they are performing addition directly. This is an example that is taken from the textbook just to tell you how they are equating exponent part and then doing arithmetic in mantissa part. Next question. The right sequence of CPU program to input data will be. There is a flowchart given in the reference book actually. But when you take the explanation part, it will start in a different point because they would have explained you totally and then given 3 instructions. So I have taken the flowchart for easy reference. This is the flowchart for CPU program to input data that is being asked in the question. Read data register is the first step, which is C. Then we have to check flag bit, which is B. If the flag is set, we have to read the status register, which is A. After that, we go with transfer data to memory, which is D. In case if the flag bit is not set, that means if it is 0, you have to again go and read the data register. C, B, A, D will be the right order. It is available in option 3. Option number 3 will be the right answer. What happens after data transfer to memory? It will check whether the operation is complete. If the operation is complete, then it will continue with the program. If the operation is not complete, then again it will go back to read the data register. Once you prepare for a question from a previous year question paper, any kind of question relating to that particular statement or that particular topic, you should be able to answer in any other question paper. So your preparation should be in that way. Next question, which of the following statements are true? They have given about write through policy, write back policy, cache coherence problem and the solution for the problem. So let's see about one by one. When the CPU finds a word in cache during a read operation, the main memory is not involved in the transfer. However, if the operation is a write, there are two ways that the system can proceed. The simplest and most commonly used procedure is to update main memory with every memory write operation, with cache memory being updated in parallel if it contains the word at the specified address. This is called the write through method, which is given as write through policy in the first A statement. They are saying along with the main memory, the cache memory will also be updated in parallel. So the update will be occurring in parallel to both main as well as cache memory. This method has the advantage that main memory always contains the same data as the cache. What is the second way? The second procedure is called write back method or the write back policy as mentioned in B statement. In this method, only the cache location is updated during a write operation. So if it is only cache, then it is write back. So let's check A and B now. In the write through policy, only the cache is updated. It is wrong because both main and cache memory are updated in parallel. In the write back policy, both cache and main memory are updated is again wrong. Only the cache is updated. The statements are exchanged. So both A and B are wrong. Once you know both A and B are wrong, you can rule out 1, 2 and 4 options. So we know the answer C and D are right. Cache coherence problems exist in multiprocessors with private cache. This is perfectly true. And what about D? Cache coherence problem can be solved by means of hardware only scheme. Actually, the cache coherence problem can be solved by means of a combination of software and hardware. This is one way, or by means of hardware only schemes. So there are two possibilities and this statement is listing one possibility. So we can mark it as true. So both C and D are true. We will go with option number 3 as the right answer. Next question. Which of the following gates do not give output 1 when both the inputs are 0? When you take X, Y and the particular gate's output, they say when X is equal to 0 and Y is equal to 0, it should not give you 1 means it should give you 0. They are asking for do not give output 1. Only when you have the truth table of all these gates or at least the logic operation of all these gates in mind, you will be able to answer the question. Here I have given you the logic gate representation as well as the truth table. So here the inputs are taken in the form of A and B. So let's check for 0, 0 in NAND, which is in option A. Then 0, 0 in NOR, which is option B. XOR is option C. We will take 0, 0 and exclusive NOR in option D 0, 0. We have 1 here in NAND. So this is not the right answer. We have 1 here again. So this is not the right answer. We have 0 here. they say it should not give 1. Not 1 is actually 0. So XOR is right. What about exclusive NOR? We have 1 again. They say it should not give output 1. So this is also not there. Option number 4, C only will be the right answer. Actually, XOR gate is the only gate out of these 4 gates which does not give output 1 when both the inputs are 0. But in the context of examination, what you will do is you will go and mark option 3 directly, because here we know C is alone right. But you have to check the question. Choose the correct answer from the option. They have given A, B, B, C, C, D, C only. So we know A, B, D are not there. When A, B, D are not there, you have to rule out the first 3 options and then stick to the 4th option which says only C is right. Next question. Match list 1 with list 2. Address space, memory space, cache memory, segmented program in list 1. List 2 has associative mapping, logical address, physical address and virtual address. An address space is the set of all logical addresses available to a process, which are known as virtual addresses. The operating system provides this virtual address space to a program. What about memory space? This refers to the actual physical addresses in the RAM. The operating system maps the virtual addresses generated by a process to their corresponding physical addresses in main memory. So memory space is about the physical address. You may get confusion between logical address and virtual address for address space, but memory space is surely mapping to physical address. B maps to 3. B3 is available only in one option. Just based on B, you can say that option number 1 will be the right answer. Next, we will go for associative mapping in list 2. Associative mapping is a method used in cache memory where a main memory block can be placed into any available line in the cache. So, if you have idea that C will be mapping to 1, it is available in 3 options which will confuse you further. So memory space to physical address will actually clear all the confusions even if you map C to 1 in the starting itself. What about segmented program? A segmented program creates a logical address space that is divided into logical units called segments. This logical address is what the CPU uses to access data. So segmented program is associated with logical address. D is mapping to 2. And address space will be mapping to 4 virtual address. A is mapping to 4. A4. Option number 1 will be the right answer. With this, we are completing Unit 2 questions. Let's discuss Unit 3 Programming Languages and Computer Graphics questions. Consider the following piece of C programming code. Int x is equal to 128, y is equal to 110. Inside the do while we have if conditional along with else part. Then we have a printf statement. This printf is actually printing the value of x. Actually, whenever you have a do while statement, irrespective of any condition that appears in the while, it will execute for one time, and after execution it will check the condition at the end of the loop. So once the condition is true, it will again go and execute. If the condition is false, then it will exit out of the loop. Let's see what is inside the loop. If x greater than y, x is equal to x minus y. If x is not greater than y, then the else part will be working. Y is equal to y minus x. And see the condition in the while here, it is x not equal to y. Whenever we have different values for x and y, till then the loop will be executing. But when x value and y value becomes equal, you have to exit out of the loop. So the exit condition here, it will be x is equal to y. Now we will start the execution with the first value x is equal to 128 and y is equal to 110. So initially it will go to the if condition. If 128 is greater than 110, yes, it is true. If it is going to be true, which part will be executing? This part. So x is equal to 128, which is x value, minus 110, which is y value. 128 minus 110 will give you 18. Now the new x value will be 18 and y value will be retained as it is. X is not equal to y. So it will once again check for if x greater than y. Here 18 is not greater than 110. So this condition is false. Then automatically else part will be executing here. Y is equal to y minus x. Y is equal to 110 minus 18, which is equal to 92. Again we have x is equal to 18 and y is equal to 92. So the loop will again be executing. 18 is not equal to 92. That's why we are entering into the loop once again. Still 18 is less than 92. So based on the false condition, y is equal to y minus x will be getting executed. 92 minus 18 will give you 74. Again we have x is equal to 18 and now y will be equal to 74. 74 is still greater, so the false part will be executing. Else y is equal to y minus x will this time give 56 and x is equal to 18, y is equal to 56. This will end up with executing the else part once again. 56 minus 18 will give you 38. Now x is equal to 18 and y is equal to 38. 18 greater than 38, it is false. So the else part will be executing. Y is equal to 38 minus 18, which is equal to 20. Now we have x is equal to 18 and y is equal to 20. Still 18 is less than 20. So this false part will be executing. Y is equal to y minus x. Now y is equal to 2. So we have x is equal to 18 and y is equal to 2. Still they are not equal. So now we are entering this if part. 18 greater than 2. Yes, it is true. So 18 minus 2 will give you 16. Now x is equal to 16 and y is equal to 2. So again 16 greater than 2? Yes. So 16 minus 2 is equal to 14. So wherever you have x, there x minus y will be there. Wherever you have y, y minus x will be applied there. So this evaluation has to be taken whenever x is greater. This evaluation has to be taken whenever y is greater. So now we have x is equal to 14, y is equal to 2. So 14 is greater than 2, which is true. 14 minus 2 will give you 12. X is equal to 12, y is equal to 2. 12 is greater than 2. So 12 minus 2 is equal to 10. X is equal to 10, y is equal to 2. 10 is greater than 2. 10 minus 2 is equal to 8. 8 and 2 now. 8 is greater than 2. So 8 minus 2 is 6. 6 is greater than 2. 6 minus 2 is 4. 4 is greater than 2. 4 minus 2 will give you 2. Now what is the value of x? X is equal to 2. And what was the value of y? Y is equal to 2. Now it will enter here and the condition here will get failed. So it will exit out of the loop. So 2 is equal to 2, which means x is equal to y. This condition becomes false. So now printf will get executed. So we are printing an integer, that is why we are using %d, and it is printing the value of x. What is x value here? It is 2. So option number 2, x is equal to 2 will be the right answer. You need not go through all these stages also. Once you know it starts decrementing by 2, ultimately 16 minus 2, 14 minus 2, 12 minus 2, 10 minus 2, 8 minus 2, 6 minus 2, 4 minus 2 will bring x to 2. Here itself you can guess the answer of x to be 2 just by thinking it in your mind itself. So once you get an idea about x value in these two stages, you can stop it and then mark the answer, because you have crossed 92, you have crossed 74 and you have crossed 18 also. X was 128 initially, that is not there in the option. X never became 92 and 74. Y values were 92 and 74, so you could have ruled out 3 and 4 already. After 128, x is directly getting the value of 18, but after 18, when you are coming to this stage, it is changing to 16, which says 18 is also not the answer. From here, when you rule out 1, 3 and 4, you can mark 2 to be the right answer. So why am I telling you to process based on this particular statement or based on these particular values is, in the point of examination, you cannot keep executing every evaluation part and then checking due to time constraint. So this question can save some time when you stop here, and that time could be put for another question. That's what I'm saying. You can allocate the time for some complicated questions rather than spending it for such simple questions. Next question. Which of the following technique is used for clipping? This is from computer graphics. Based on the name, I think you can mark option 3 to be the right answer because you could have come across this name in some previous year question papers. Any procedure that eliminates those portions of a picture that are either inside or outside a specified region of space is referred to as clipping algorithm or simply clipping. When you take a particular image that is going here and there, when you say I want to view only this particular part in my device, for that purpose only computer graphics will use the term clipping. You are clipping the view of the particular scene to a particular area. So they say eliminating the portions of some picture that is inside or outside a specified region of space. So what are the different techniques of clipping that is available? Point clipping, then we have line clipping. In line clipping, we have 3 algorithms in the reference book: Cohen-Sutherland, Liang-Barsky, Nicole algorithms. What is Cohen-Sutherland or Sutherland-Cohen? Both are actually same. Divides space into regions and uses binary codes to classify endpoints. Liang-Barsky uses parametric equations for faster computation. Nicole is optimized for lines that are mostly visible. So from this we can mark option number 3, Sutherland-Cohen, as the right answer because it's a line clipping technique. So you have to know which clipping has this particular algorithm. That's why I am listing it under the clipping technique. Then we have fill area clipping, that is polygon clipping we will say. Sutherland-Hodgman algorithm, and we will have Wheeler-Atherton algorithm. Sutherland-Hodgman will clip polygon edges one at a time against each boundary, and Wheeler-Atherton algorithm is better for concave polygons and complex clipping windows. Actually, in unit outline series, I would have discussed few of these algorithms, at least for telling you what these algorithms will do. Then the final 2 clipping techniques will be curve clipping and text clipping. Now we know this is the right option, Sutherland-Cohen. But what are these wrong options are for? Stack-based seed fill algorithm is a region filling technique used to fill enclosed areas in raster graphics. So clipping is actually eliminating, but here seed fill is actually region filling technique. That's why they have stopped with seed itself. So if they know it's a fill algorithm, from the name itself you can say it is not for clipping. So in order to give confusion only, they have stopped the name. Then we have scanline seed fill algorithm. This is another area filling method, but here this works line by line is what they say. Scanline means row by row it will go. So 1 and 2 are not there. What about inverse scaling? This is a transformation technique used to reverse the effect of scaling. Scaling means you are just magnifying the image by 2x or 3x. Inverse scaling is just reversing the scaling effect. So it has nothing to do with clipping or filling here. So inverse scaling can also be ruled out. Whenever you work with such questions, try to have more information about the wrong options so that you will have some additional learning, and that will definitely help you in some other question paper. Next question. What will be the output of the following C programming code? We have int I comma j. We have 2 loops here. It's nested for loop. For I is equal to 1, I less than 5, I is equal to I plus 2. For j is equal to 1, j less than I, j is equal to j plus 2, and we are printing j. So let's take I value, j value. We will check j less than I, the inner for loop first, and based on that we will see whether the statement is printing j or not. Then we are incrementing the inner loop here. So this is completely the for loop of j. And here this is the outer loop that will increment I. Now we will start with I is equal to 1. So once I is equal to 1, you have to start from j is equal to 1. So it is 1 here. 1 is less than 1 is false. So when it is false, it will exit out of the loop and nothing will be printed and nothing will be incremented to. Now we have to increment the value of I. I is equal to I plus 2. I plus 2 is 1 plus 2, which is equal to 3. So now the new value of I is 3. Once again we have to start from j is equal to 1. Now check the condition. J less than I. 1 is less than 3. Yes, it is true. When it is true, what value are you printing here? You are printing j. So j is 1. Now after printing you have to increment j, which is j is equal to j plus 2. J plus 2 means 1 plus 2, which is equal to 3. Now you have the value of 3. This is the inner for loop is getting executed. So you have to increment j and go with the same I. Now the new j value will be 3. Now check the condition again. J less than I. 3 is less than 3 is false. So we are not printing anything new. I am not copying this value for this particular condition. I am checking whether it is printing j or not. It is not printing. So you are exiting out of the loop. So here we are exiting and here also we are exiting. Now we are incrementing the value of I by 2. So 3 plus 2 will give you 5. Now we have I is equal to 5. What is the for loop stating here? I is less than 5. So here it will exit out of the outer loop because 5 is less than 5 is actually false. We have only 1 that is printed. So we will go with option number 1 as the right answer. Next question. What would be the equivalent pointer expression for referring the array element? Array of M, N, O. This question has already been asked in one of the previous year question paper. Let's take an array with dimensions x, y and z. It's a 3-dimensional array. AR of M gives a pointer to the 2D array, which is AR of M, Y, Z. It means this is a pointer to this particular array. In what way we can represent it? AR plus M moves M blocks of this particular 2D array. When you have the pointer symbol here, this gives the 2D array at index M. So I am just interpreting how AR plus M will work and pointer of AR plus M will work. Next we will get into the second dimension, AR of M and then N. This gives a pointer to the 1D array here. So M index is here, N index is here. We have the Z dimension array here. AR plus M is actually the index M. So we are taking this as it is. This part is taken plus N, like plus M. Plus N will move N blocks of Z array. But here when you use pointer again with this particular reference, this will give the 1-dimensional array at Mn. Then we have AR of M, N, O. 3 indices are here. Gives the actual integer value at that location. So how will we refer this one? So in order to get the exact integer value, what you have to do? We have to have plus O. Along with it you are adding the pointer symbol here. Only when star of pointer is used, the value will be taken. When you use only the pointer, that location will alone be taken. So this will give the value. Which of the option is actually matching to this one? Star of AR plus M is available here. Then star of the M index with N is available here. Then star of Mn with O is available here. Option number 4 will be the right answer. Now we will see why 1, 2 and 3 are wrong. This is actually adding M and N together before indexing, which is not correct for separate dimensions. What they have done here is they have taken this particular part separately and they are adding M plus N. This plus M is a reference to the 2D array Y is it here as we saw. But giving M plus N, is not correct when you are using m dimension and n dimension separately. So that's why 1 is wrong. What about 2? This particular part is equivalent to AR of 0m, that is row m of first 2D array. This is first 2D array and this is row m, and when you have another index, that will be column. So here this is the first 2D array. Every array will have index 0, 1. So when you have 0 of a 2D array, this is the first 2D array. This is the meaning of star AR plus M. Star AR plus M with the braces together is AR of M, where entire 2D array at index M is referenced here. So this is the meaning that is given here. When the parenthesis is used along with plus M, that will give this meaning. When the indirection operator is used with the array and you are then adding plus M, that is equivalent to this particular row of first 2D array, they say. The meaning is different. So second option will also not be equivalent. What about third option? This one is right and this one is right. They have just added plus O. What will this actually do without this particular pointer symbol? It's a pointer to this particular location, not the actual value. Take a particular array, M, N, O is referring to a number called 9. This particular third option will point to the particular value, but it is not the actual value. Only when you have the star symbol along with the pointer, it will give you the value which is present here, that is equal to 9 that we have taken for an example. So since it's a pointer and not the actual value, we are ruling out even option 3. So understand, they are asking equivalent pointer expression for referring the array element. So they are saying the element has to be accessed. It means they want the value at that location. If the location is getting pointed, then we are using option 3. Next question. What will be the output of the following C programming code? They have declared a pointer star I here. A is equal to 12, B is equal to 2, and then they have declared C. C is equal to, inside the parenthesis, they have given 4 kinds of expressions separated by comma. Then I is equal to ampersand of C, which is actually referring to the location of C, the address of C. Star I will give you the C value. Decrement part will actually decrement the value by 1. The comma operator evaluates each expression from left to right, but only the result of the last expression is assigned to C. It means all the 4 expressions will be evaluated and only this expression's value will be stored in C. So let's take the first expression, A is equal to A plus B. It means A is 12, B is 2. 12 plus 2 will give you 14. Now the value of A is 14 and B is 2. Now we will go for the second expression, B is equal to A by B. What is A now? It is 14. What is B? It is 2. 14 divided by 2 is 7. So now A is equal to 14 and B is equal to 7. Now we will go for the third expression, A is equal to A into B. Now A is 14 and B is 7. 14 into 7 will give you 98. This is A. So A is 98 and B is still 7. Now the final expression, B is equal to A minus B. So here A is 98 and minus B value is 7. 98 minus 7 is 91. The B value is updated to 91 while the A value is same as 98. Now this is the last expression. Whatever value becomes the result of the last expression, that is assigned to C. The result of the last expression is 91 and this value will be assigned to C. You can ask me, we can actually compute B is equal to A minus B and put it in C. Just compute A minus B. 12 minus 2 will give you 10 and you are going to put it in C. That is not the case here. They want you to evaluate these 3 expressions update the value of A and B internally, and then use the updated value in this particular expression, and then finally store the result in C. Now what is I is equal to ampersand C? I is pointing to C now, which is 91. So this is holding 91. Decrement operator will decrement C before printing. So here if I say minus of minus I is equal to I minus 1. When it is minus of minus C, it is C is equal to C minus 1. So in the same way, minus of minus star I, this star I is having the value of 91. Since we use decrement operator here, it is reducing 1 from 91 and the final value here will be 90. That will be printed in the printf statement. Option number 2, 90 will be the right answer. Star I will have the value of 91. Decrement operator will decrement it by 1 and then bring to 90 for the whole expression. This 90 is an integer because star I is an integer here. So we are using percentage %t to print it. I hope it is clear for you. Next question. Consider the operators used in C programming. We have been given 5 operators. Choose among the following the correct order of precedence of the operators given above. We have to start from the higher precedence and go to the lower precedence. So let's take the precedence of operator along with the associativity here. So now we will just see the symbol. Double ampersand is for logical AND. This is A. Then we have plus equal to, this is actually assignment, it is present here. So this is B. We have 2 greater than symbol, which is actually shift operation. So this will be shift, which is C. Then we have greater than or equal to, this is relational operator. So we have D. Then we have the conditional, the ternary operator, question mark and colon. This is available here. So this will be E. This is arranged from higher precedence to lower precedence. So the order will be C, D, A, E, B. Option number 3 will be the right answer. Next question. Consider the following statements for XML, Extensible Markup Language. The number of tags decreases and users can define their own tags. Actually, this part is definitely true. We can define our own tags. It's not like HTML. HTML has a specific set of tags. We have to use that only. But XML is not so. It is used for presentation. It is case sensitive. It is dynamic. So let's see. XML is strictly case sensitive. The tag capital N in name and small n in name are treated as completely different tags. In HTML, when you write it as bold or bold, both are actually same. When you say IMG or IMG, both are same. But in XML, they say even a single letter that is given in caps will give difference. So it is strictly case sensitive. C is definitely true. The option that does not include C will be removed. What about dynamic? XML is considered dynamic because it's used for transporting and storing data, which can then be used to generate dynamic content in web application. Generally, XML is not used for showing something. Displaying purpose is actually done by HTML. Using HTML, you can display any kind of information. XML is not for that purpose. When you take this particular point, you can easily say that B is false and D is definitely true. Coming to A, users can define their own tags. This is fine. But actually, there is no rule that XML will reduce the number of tags. Based on particular application, the tags might get increased or decreased. Due to this particular part, this statement is not completely true. But since we are ruling out options that involve B, we have only option 3 left out with ACD. XML is primarily designed to transport and store data, and for presentation we are using HTML. They are including A in the official answer key because of this particular statement. This is perfectly fine. But this depends on the project, or this depends on the application. Since they say it is for transporting and storing data, when we reduce the number of tags, the number of information that is being transported or stored will be less. Based on that aspect, some articles might support this statement, but in general doesn't by default reduce the number of tags, because you are actually creating the tags. So just keeping this particular point in mind, we can mark A to be true. I am marking option number 3, ACD only, as the right answer. Next question, only legal pointer operations. Pointer along with a number, when it undergoes addition, it will end up giving a pointer. A is actually adding an offset. Offset means a number to the pointer. This will result in a pointer. This is perfectly true. Subtracting an offset from a pointer will result in a pointer again and not a number. So this particular part is false. It will again result in a pointer only. So from this we can rule out B. Once you know B is wrong, you have the answer. Next, pointer plus pointer will end up with pointer. Adding two pointers is not allowed. C is also not there. Pointer minus pointer ends up in a pointer. Subtracting two pointers gives a number, not a pointer. We have a pointer here and a pointer here. Subtracting them will say how many locations or places are in between them. It is not about a pointer again. So this is also wrong. So now we have pointer minus pointer, that gives a number. This gives the number of elements between two pointers. If I have 4 numbers between these two pointers, then the difference will be 4 here. So subtraction is allowed, but that will give the result as number of elements between those two pointers and not a pointer. So based on D and E, we can say E is right and D is wrong. So from this we can mark option number 4, A, E only, as the right answer. You should get a list of valid or legal pointer operations that are allowed, and you have to get invalid pointer operations. Have a learning, have a comparison, so that it will be helpful for you in some other question paper. Next question, match list 1 with list 2. Now we will go with overloading and overriding. Both are terms of polymorphism. When we say overload, it means this will occur at compile time. When we say it is override, that will occur during run time. Since we know overloading is directly denoting polymorphism, we can mark A, 2, 3. Overloading supports compile time polymorphism and overriding supports runtime polymorphism. C is mapping to 4. So we have A3, C4. What about early binding and late binding? This will also carry the same idea. When something happens during compile time, the execution will be faster. When something happens at runtime, only during the runtime you are going to substitute a value or do a function call. The execution will take some more time. It will be slower. So now we will see, since function call is resolved during runtime, the execution is slow. So the slower execution happens because of resolving in runtime. And since the function call is resolved during compilation time, the execution is much faster. Early binding is when it happens during compile time. So we can say B is mapping to 2. And late binding is related to runtime because it's about slow execution, and D will be mapping to 1. Why am I writing this here separately? Because B2 D1 is available here and A3 C4 is available here, which means this question is dropped in the official answer key because no option is actually having A3, C4, B2, D1 together. All the options are wrong. Next question, match list 1 with list 2. This is from computer graphics. oblique projection, cavalier projection, cabinet projection, orthographic projection. First we will see about oblique and orthographic projection. And regarding B and C, they are actually types of oblique projection. So first we will cover A and D. This is orthogonal or orthographic projection and this is oblique projection. Here we have a term called foreshortened, no foreshortening. In projection, generally we don't have this foreshortening and all. Foreshortening means getting shorter than the usual one. So we don't have that term. So we will see about 3 and 4 now. When the direction of projection is perpendicular to the plane of projection. Perpendicular means it will be in this form. Parallel means it will be in this form. So perpendicular means at 90 degree angle you can take. So which projection is in perpendicular form? Orthogonal. That is orthographic projection is in perpendicular form. So D will be mapping to 3. D3 is available only in one option. What about oblique projection? When the angle between projectors and the plane of projection is not equal to 90 degree. When it is 90 degree, it is perpendicular. If it is not 90 degree, then that is oblique projection. So that's what you can see in the diagram here. I am not getting into the discussion of the diagram, but just to show you how it looks. So A will be mapping to 4. A4 is available here. Actually it is available in both the places, but here D is wrong. So we can rule out 4 and from D we can rule out 1 and 3 also. From D itself we can rule out 1, 3 and 4 options. We can say option number 2 will be the right answer. Now we have to see how B is 2 and C is 1. This is general oblique projection. They say it is just scaled. It is not full or half. When it is full scale, you can see this particular image. When it is half scale, you can see this particular image. When it is half scale, it is cabinet. When it is full scale, it is cavalier. So just take this to be scale. The original one. When it is full scale, it is just stretched. When it is half scale, it is just shortened. So this foreshortened term is actually denoting this shortening part. Now let's see the first statement in list 2. When the direction of projection is so chosen that the lines perpendicular to the plane of projection are foreshortened. Foreshortened means they are not stretched or elongated, they are made small. So this foreshortening is the term that is used for half scale. So which projection it is talking about? It is talking about cabinet projection. C will be mapping to 1. C1 is available here. Then what about full scale? When the direction of projection is so chosen that there is no foreshortening of lines perpendicular to the plane of projection, it is taken as full scale. You are not shortening it. See, this is the complete scale you can take and this is half scale. This is the general oblique projection. You don't consider this as of now. Only compare these two diagrams. I am just telling you how it differs from oblique projection. This is just to give an overall idea. This no foreshortening is the clue for full scale here. So B will be mapping to 2. B2 is also here. Orthogonal is talking about the direction of projection is perpendicular to the plane of projection. You will know that if the plane of projection is not equal to 90 degree, that will fall under oblique. Under oblique, you have two types, cavalier and cabinet. When it is a full scale view, you go for cavalier projection. When it is half scale, that is when the lines are foreshortened, that comes under cabinet projection. So have an idea about all the projections so that it can help you in some other question paper. With this, we are completing Unit 3 questions. Let's solve Unit 4 Database Management System questions. Consider R with attributes A, B, C, D, E be relation with following dependencies. C derives F, E derives A, EC derives D, A derives B. Which of the following is a key for R? So they are asking about the candidate key, we can say. So what is actually the key? It's a set of minimal attributes with which you can distinguish a particular record. Now in order to find which particular option is going to be the key, we have to find closure with all the options. But before we start with the options, just look at the dependencies. The first dependency is C derives F. Attribute F is not a part of the relation. So we have to ignore this particular dependency for key determination. So we will ignore this. Now we have only 3 dependencies with which we have to find. Now we will start with the first option. We will take CD closure. From CD I can get C attribute, D attribute. Based on C or D individually, will I be able to derive A, B or E? No, it stops with this one. So option 1 cannot be the key. Let's take second option, EC. When you find closure, you automatically have E and C here. From E you will be able to derive A. From A you will be able to derive B. From E and C you will be able to derive D. Are we getting all the attributes A, B, C, D, E? Yes. So EC can be the key for R. Let's take the third option, AE. On finding closure. So let me once again remind you, finding closure means using the dependencies and using the attributes that is given in the option. If you are able to derive all the attributes, then that is actually finding closure. If you are able to get all the attributes, then that becomes the key for this particular relation. So now we will find for AE. From A I will be able to find B. So E is already here, but just with E I won't be able to get D or C. So this is again not a key. What about AC? So from A I will be able to get B and we will have C also, but there is no way to get D and E. Only when I get E I will be able to get D. We can say that option 4 is also wrong. So from this we will rule out 3 and 4 also. Option number 2, EC will be the right answer. That is the key for R. Next question. Consider the relation T1 with dependencies and T2 with dependencies. Which of the following is true? T1 is in 3NF, T2 is in 3NF. So they are asking whether it is in 3NF and this one is in 3NF. T1 is not in 3NF, T1 is in 2NF. So let's first understand what is 2NF and 3NF. A relation is in second normal form if every non-prime attribute is fully functionally dependent on the entire candidate key and not just part of it. A relation is in third normal form if for every non-trivial functional dependency X derives Y, either X is a super key or Y is a prime attribute. So here we have something called prime and here we have non-prime. What are prime and non-prime? Prime attribute is any attribute that is part of a candidate key. In the previous question, if we say EC is a candidate key, E is a prime attribute, C is a prime attribute. Anything other than E and C will be non-prime attribute. A non-prime attribute is an attribute that is not part of any candidate key. When you have 2 or more attributes combined in candidate key, the individual attributes of that candidate key is prime attributes. Whatever attributes are not present in the candidate key will become non-prime attribute. So here in 3NF they say either X should be a super key or Y should be a prime attribute. What about 2NF? They say every non-prime attribute should be fully functionally dependent on the entire candidate key, not just a part. If they say EC is a candidate key, it should be fully dependent on EC and not just E or just C. Okay. Now we will just start working out. Let's take the first relation T1 with attributes A, B, C, D, E, and we have the dependencies EB derives C, D derives E, EA derives B. So 3 dependencies are given. The first work is we have to find the candidate key. So from this you can individually work out and check. Since this is a long problem, I have found the candidate key and I am directly presenting it here. So we can check A, B, C, D, E individually as candidate key. It will not work out. Then we will take combo of two attributes. So in that AB together will not give you. Then BC together will not give you. EC together will not give you. BE together will not give you all set of attributes. Then what about AD? Just take AD closure. From AD you will be able to find A and D. From D you will be able to find E. With E and A you will be able to find B. Then E and B can help you derive C. So all the 5 attributes can be taken if AD is the candidate key. So we are concluding AD is a candidate key. Based on this candidate key, now we are finding what are the prime attributes and non-prime attributes. So what are the prime attributes here? Any attribute that is a part of candidate key. So A is a prime attribute and D is a prime attribute. Anything other than A and D, that is B, C, E will be non-prime attributes. Let's just start with 3 and F. Let's take the first dependency. EB derives C. EB is not a super key. Just with E and B, will you be able to derive all the attributes? From E and B, you can take only C. So, only 3 attributes can be taken. A and D cannot be taken. So, EB is not a super key. So, LHS has already failed. What about C? C is a non-prime attribute. They said either LHS should be a super key or RHS should be a prime attribute. Here LHS is not a super key and RHS is not a prime attribute, which says that this particular dependency is violating 3NF and therefore we can say T1 is not in 3NF. So this particular part is true and this one is false. Now we will check for 2NF. For 2NF they say non-prime attribute should be fully functionally dependent on the entire candidate key. What is the candidate key here? AD is the candidate key. The non-prime attributes are E, B, C. Are they fully dependent on AD? No. E is dependent on D alone and not A, which says that they are partially dependent on the subsets of the candidate key. So if you take B, it's only A here. If you take C, no. EB derives C is actually violating both 2NF as well as 3NF. Even if you take this particular dependency here, it is violating 2NF. Based on this particular statement, they are not fully functionally dependent. We can conclude that T1 is not in 2NF, which says that option 4 is also out of the race. I hope you are clear till T1. Now we will get into T2. T2 relation has attributes A, B, C, D and the dependencies are C derives A derives B and A derives D. So what is the candidate key? Just we will work it out. From A closure. From A you will be able to find B. What about B? From B you can take only B. What about C? From C you will be able to derive A. From A you will be able to derive B as well as D. So here you can derive 3 attributes in the A closure part, but C cannot be taken. But C closure you can take all the 4 attributes. What about D closure? Only D can be taken. So from this, C is the candidate key of T2. So from this we can say prime attribute is C because it's a single attribute there. And non-prime attributes will be A, B and D. First we have to check for 3NF condition because the statement in second option says that T2 is in 3NF. C derives A and A derives B. What is this actually? X derives Y, Y derives Z, which means that X derives Z. This part is called as transitive dependency. C derives A and A derives B combine to form a transitive dependency C derives B. Similarly, C derives A and A derives D form another transitive dependency C derives D. What is actually third normal form? The normal form that is actually in 2NF as well as which does not have any transitive dependency will be in third normal form. But here we have transitive dependencies which states that T2 is not in 3NF, ruling out even option 2. This is also false because the non-prime attributes B and D are transitively dependent on the candidate key. C, T2 is not in 3NF. So let's check for 2NF. Additionally, it is not related to this question. Since the candidate key is a single attribute, there can be no partial dependency, and so T2 is in 2NF. There is no statement regarding this one. So just for learning purpose, I have given you this particular part. As for this question, we are marking option number 3. T1 is not in 3NF as the right answer. Next question, in a relational database, which one of the following is correct? So we will see statement by statement. A relation with only 2 attributes is always in Boyce-Codd normal form. In a relation with 2 attributes, say R of x comma y, any non-trivial functional dependency, when there are only 2 attributes, the dependency can either be x derives y or y derives x. This implies that the left hand side is a super key. In a 2 attribute relation, a single attribute that determines the other is always a candidate key, which makes it a super key. When we know that only 2 attributes are present and one attribute becomes the super key, automatically that relation is in BCNF. So option 1 is right. Here they are asking which one is correct, and we know the first one is correct. Now we will see what is wrong with 2, 3 and 4. If all attributes of a relation are prime attributes, then the relation is in BCNF. If all attributes are prime, it means they are all part of some candidate key. Whatever attributes are present in the candidate key are called prime attributes. This property only guarantees that the relation is in third normal form but not necessarily in Boyce-Codd normal form. So when you have such a statement here, it is true for 3NF and not for BCNF. So 2 is wrong. What about third one? Every relation has at least one non-prime attribute. A relation can have only prime attributes where there are no non-prime attribute. If you take the second statement as the case, then that relation will have no non-prime attribute. Say for example, when A, B, C are all prime attribute in a relation, if that is true, then this condition is definitely false. There can be a relation with no non-prime attribute and every attribute can be prime attribute. So 3 is also wrong. What about 4? BCNF decomposition preserves functional dependencies. Actually, this decomposition does not always preserve all functional dependencies. It will guarantee lossless join, but dependency preservation may be lost. It preserves is wrong. So 4 is wrong. Next question. Consider the following 3 relations. Employee, company, owning relation. Employee has 2 attributes. Employee ID, employee name. Company has company ID, company name. Own table has employee ID and company ID. Which of the following relational algebra expression return the set of employee IDs who own all the brands? It means when the company table is going to have 4 or 5 entries, say for example when they are going to have 4 entries, that becomes 4 brands. We have to find the employee who have entry with all the 4 brands in the own relation. This is what they are asking. What is this symbol actually? This is relational algebra symbol for project. What is projection? The projection operator is used to select specific columns or specific attributes from a relation. So selection is about selecting the rows and projection is about selecting specific columns. Just go through the options. We have 2 symbols here. One is division given in 1 and 4. Then we have Cartesian product symbol in 3 options. What is Cartesian product? This will return all possible combinations of tuples where each tuple from the first relation is paired with every tuple from the second relation. What about division? This is used to find tuples. Tuples means records in one relation that match all tuples in a specific set of second relation. You can compare it with the question. This is used to answer for all or every type of queries. For example, find the students who have taken every course, or you can just find the employee IDs who own all brands. Such kind of queries will be answered by division operation. So this is the symbol that is being given here. For relational algebra, we will take it as cross product. Now we will analyze every option. For the first statement, let's get into the expression that is inside the parenthesis. We have project EID CID from own relation, division project CID from comp relation. So what does project CID comp relation do? This will project the full set of brands. So we have something like division of brands. Project EID CID own projects the pairs of employees and brands they own. This is employees and the brand IDs that they own. What does this division do? This returns employees who own all the brands. There are going to be 4 number of brands. It will choose the employee whoever has entry for all the 4 brands. They say find tuples in one relation that match all tuples in the second relation. So whichever employee is associated with all the brands that is present in the brands table, that employee details will alone be taken. Now what about project EID of the complete class? This will give you the clean list of employee IDs who satisfy the condition. Which condition? Owning all brands. Is this query or is this expression giving you what is being asked in the question? Yes. So from this we can say option number 1 will be the right answer. Now let's see about second one. The Cartesian product or the cross product combines every employee ID in the own relation regardless of whether that employee actually owns that brand or not. So in own relation we have EID and CID. This will give you all the brands together irrespective of whether the employee is having the entry for the specific brand or not. It will just combine all the tuples from this particular relation and then this particular relation and produce a pair. I mean all possible combinations will be taken is what they say, and that is not needed by this question. So option 2 is wrong. What about option 3? Here also we are using the same query along with EID and CID. It creates a cross product between existing ownership and all brands. The resulting relation will have 3 attributes: EID, CID from own relation and CID from comp relation. Here if you have only EID and CID combo, the same result will happen with EID, CID from own table and then CID from comp table. So with 3 attributes it will create cross product. So this is also wrong. Now let's go for the fourth one. Just get into the inner query here. We have project CID CNAME from own. Actually CID CNAME belongs to comp relation and not own relation. So from this itself we can say the query is wrong here, or the expression is wrong here. The relation own contains only 2 attributes. An attribute that doesn't exist cannot be projected. So from this we can say option 4 is wrong. Next question. Consider the following statements and choose the correct answer from the options given below. Data transformation is involved in data mining process. Data transformation is a crucial step in data mining where raw data is cleaned, normalized and formatted to be suitable for analysis, which states that A is true. What about B? Online database is used in data warehouse. A data warehouse typically uses offline or batch processing and not online transactional database. Or you can take it in this way. While a data warehouse often stores data from online sources. Yes, it takes data from online sources. It is not necessarily limited to them. A data warehouse can also include data from offline sources. Online database is used in data warehouse, but it is not the only source. Only online database is used, they have not given. They have told that online database is used. Taking that into consideration, we can also say B is true. What about C? Classification is a measure of accuracy. Classification is a data mining technique used to predict categorical labels like spam, not spam, based on given input data. Accuracy is a metric or measure that is used to evaluate how well a classification model performs. So classification is not a measure of accuracy, it's a data mining technique, which means C is wrong. So any option that includes C can be ruled out. From this we have answer as B, D and E. Let's check with D and E. What is D? K-means clustering algorithm is based on the concept of minimizing the within cluster variance. K-means clustering aims to group data points into clusters by minimizing the total squared distances between each data point and its assigned cluster center. So when you take a group of data points, what happens in K-means clustering is it will group data like this. So how the data points will be grouped is based on the center of the cluster. Based on that only the data points will be grouped. So they say this particular clustering algorithm is based on the concept of minimizing the within cluster variance. So this is actually true. So this within cluster variance is what they say as total squared distances between each data point and its assigned cluster center. So D is true. What about E? Pattern evaluation is a process to identify knowledge based on interestingness measure. Pattern evaluation involves assessing the discovered patterns in data mining to determine their significance and usefulness based on criteria like support and confidence. Support and confidence are a part of interestingness measures. Definitely E is also true. Support and confidence are interestingness measures. So what are the options here? We have A, B, D, E to be true. A is definitely true. I don't know why it is not included in the official answer key. The official answer key states that option number 2, B, D, E only will be the right answer. But regarding A, there is nothing wrong. In my opinion, A is also right statement. So the answer can include A, B, D, E. C is the only statement that is wrong. Next question. Consider the following statements. A schedule of n transaction is serializable if it is equivalent to some serial schedule of the same n transactions. Two schedules are said to be conflict equivalent if the order of any two conflicting operations is the same in both schedule. Now we will get into the statements. A non-serial schedule is said to be conflict serializable if it is conflict equivalent to some serial schedule. This is actually right statement only. This is just given in the DBMS reference book. But in the book they would have told a schedule S is said to be conflict serializable if it is conflict equivalent to S dash. So I have mentioned along with the notation. Now we will go for B statement. A non-serial schedule is said to be view serializable if it is view equivalent to some serial schedule. This is also true only. This any schedule refers to non-serial schedule or any schedule. Now let's go for C statement. A schedule is said to be serial if instructions of participating transactions are chronologically interleaved with each other. A serial schedule is a specific type of schedule where transactions are executed one after another. So here they say the schedule is said to be serial. Serial means it will be executed one after the other. A serial schedule means no interleaving where each transaction runs completely before the next one starts. Interleaving happens in non-serial schedules. So here they have talked about serial schedule, and they say if instructions of transactions are chronologically interleaved, this will not happen in serial schedule. So C is definitely wrong. Any option that includes C can be taken out. From this we know what is the right answer now. Now let's see the D statement also. A conflict serializable schedule will be view serializable also, but vice versa may not be true. If a schedule is conflict serializable, it guarantees that it can be transformed into a serial schedule based on how transactions access and modify data items where the conflicts occur. View serializability focuses on the final visible results of the transactions to the user regardless of the order of non-conflicting operations. So, view serializability is about the final visible results. It's not about the order of the non-conflicting operation. A schedule might be view serializable even if it is not conflict serializable. A conflict serializable will definitely be view serializable, but a view serializable need not be conflict serializable. That is what they say. Vice versa may not be true. This statement is also right. Option number 3, A, B, D only will be the right answer. So once it is conflict serializable, definitely the view will also be serializable. But since the view is serializable, you cannot guarantee that it is conflict serializable. They say even if it is not conflict serializable, the schedule can still be view serializable. With this, we are completing Unit 4 questions. Let's solve Unit 5 System Software and Operating System questions. Consider the following table about processes, their burst time and arrival time. P1, P2, P3, P4, P5 along with their burst time and arrival time are given in the tabulated form. Now, which of the process shall finish second last as per the respective Gantt charts for the non-preemptive SJF and round robin? When you take round robin algorithm, they have given the time quantum as 10 and we have to find the second last as per non-preemptive SJF and round robin scheduling methods. So let's start with non-preemptive SJF. This is a CPU scheduling algorithm in which the process with the shortest burst time is selected for execution next. And since they have told it's non-preemptive, once a process starts running, it continues until completion without being interrupted by any newly arriving processes. So let's take the Gantt chart here for non-preemptive SJF. Let's take this to be time 0. At arrival time 0, what are the processes available? P1 with 9 burst time, P2 with 30 burst time, P3 with 4 burst time. So here you have to select the shortest job. It is P3. So P3 will start executing. Since they say it is non-preemptive, at the time of completion it will check for the next shortest job to be picked up. Till then it will not be preempted, means this process will not be disturbed. What is the burst time? It is 4. So at 4 P3 will be completed. Now we have arrival time 2 here. At 4, what are the processes available here? P1 is there, P2 is still there. Then we have a new process P4 with 8 burst time. Now non-preemptive SJF will pick up the shortest job from this list. So P4 is the shortest job here. So the next executing job will be P4. So for how long? For 8 burst time. 4 plus 8 will give you 12. Now we have to see at 6 arrival time we have P5 process, but at that time P4 was executing. It is not interrupted by any newly arrived process because they have mentioned it as non-preemptive. So here at 12 what we can do? P1 is 9, P2 is 30 and now we have P5 with 11. Now which is the shortest job next? It is P1. So we will go with P1 and it will be executed for 9 burst time. 12 plus 9 will give 21. At 21, what are the processes remaining? P2 with 30 burst time and P5 with 11 burst time. Which is the shortest job here? P5. So P5 will be executed for 11 burst time and it will end up at 32. At 32, the only process that is available will be P2 with 30 burst time. So P2 will be executed in the last with 30 burst time, means it will get completed at 62. The first question is for non-preemptive SJF. Which is the second last to be completed? It is P5. Now I have taken non-preemptive SJF with P5 as the answer. There are two options matching, so we can rule out 1 and 3. Now we will go with the next algorithm, that is round robin. Round robin is a CPU scheduling algorithm in which each process is assigned a fixed time slice called time quantum, and the CPU cycles through all ready processes in a circular order, giving each one a fair and equal share of processing time. This ensures no process is starved. So here the time quantum is 10. Here t is equal to 10, here t is equal to 10, and here t is equal to 10. So this is round 1, round 2 and round 3. We will start from 0 here. At 0 we have 3 processes, P1, P2 and P3. So initially it will start with P1. So let's take P1 here, and in round 1 we have P1. P1 will be executing for 9 burst time, but the total time quantum that is available is 10. So it will take 9 burst time, and so it completes at 9. At 9, all processes will go for first round of the quantum. So the second process that will enter the CPU will be P2. This is at time 9. We have P2 and P3. At that time, even arrival time to P4 process and arrival time 6 P5 process will be available. So we have 4 processes remaining. Now P2 will take the CPU. P2 will run for 10 burst time. So now just calculate 10 from 9, it is 19. P2 will run. So for how long it has run? It has run for 10. P2 has a burst time of 30, and in that 10 burst time is done in round 1. So what is the remaining time for P2? It is 20. At 19, P2 has finished execution, so it will move to the last in the circular order. P3 will be standing first, P4, P5, and then P2 will be joining here with 20 burst time. Now what is the burst time of P3? It is 4. P4 is 8 and P5 is 11. Now let's go for the next process, that is P3. P3 has 10 time quantum, but what is the total burst time? It is 4. Since it is having only 4, 19 plus 4 will give 23 and P3 will complete execution. So at 23, now we have P4 with 8 burst time, P5 with 11 burst time and P2 with 20 burst time. Now we have P4 here. This will run for 8 burst time. 23 plus 8 will give 31 and it is P4's turn. Now at 31, we have P5 with 11 burst time, P2 with 20 burst time. Now P5 will run for 10 burst time. This will end up with 41. This is P5 process. At 41, P5 has run for 10 burst time and remaining 1 is there. P2 has remaining 20. But once P5 has finished execution, it will move in the circular order next to P2. So the order will be P2 will be having 20 and P5 will have remaining 1 execution time. All the 5 processes have completed round 1 of execution. In that P1, P3 and P4 have completed execution totally. What are the remaining processes here? P2 and P5. In round 2, P2 will take 10 burst time again. It has 20 burst time altogether. It will take 10 burst time now. So now we will have 10 remaining here. So P2 will be executing till 51. So at 51, what happens? P2 will enter after P5 in the next circular order. P5 will have remaining 1 burst time and P2 will have 10 burst time. So now P5 will execute for 1 burst time in the second round, and so we'll go with 52. This is P5 and now P5 is getting completed. So at 52, the only process that is remaining will be P2 with 10 burst time. When it enters round 3, P2 will also get completed with the final 10 burst time. So P2 is the final process here. The process completion time is 62. Just read the question. Which of the process shall finish second last? So when you take the completion order, P2 is completing last. Which is second last? P5 is again second last even in round robin, similar to non-preemptive SJF. So RR will have P5 as the answer. Option 2 will also be ruled out and we will go with option number 4. P5 is the second last in SJF and P5 is the second last in round robin algorithm. I hope you understood the round robin execution. For the first round, all the processes will be allowed inside in order based on the arrival time, and for the second round, whichever process is incomplete, with the remaining burst time, they will be entering in the same order. Say for example, when P2 is getting executed here at 9, once it finishes its time, it will go and sit next to P5. That's what they say. It will cycle through all processes in circular order. Again, when P5 completes, you will be given a chance in round 2. Once it completes round 2, the second time quantum, again it moves next to P5 and waits for its third round. So in the third round only P2 is getting completed. Now just check the burst time. 10 plus 10 plus 10. The 30 burst time is split into 3 rounds. Just take P5 10 plus 1. It is split into 2 rounds. So this is how we will be working with round robin and non-preemptive SJF. Next question. Which of the following statement is correct for P threads? The correct POSIX standard for P threads is IEEE 1003.1c and not 1002.1c, which is wrong. So 1 is not the answer. This standard defines API for thread creation only, states the second statement. The P threads API defines functions for thread creation, termination, synchronization. Mutex's condition variables are involved and other thread management operations. It is not defined only for thread creation. So 2 is also ruled out. Let's take the third statement. This is a specification only for thread behavior and not its implementation. P-threads defines a standard API for thread related operations outlining how threads should behave and be managed. It does not dictate the specific internal implementation details of how an operating system achieves this behavior. Different operating systems can implement the P-threads API in their own ways while adhering to the specified behavior. So, the third statement is perfectly correct. This is a specification only for thread behavior and not its implementation. They say it does not dictate the specific internal implementation details. What about the fourth statement? Operating systems like Solaris, Linux, Mac OS X except True64 Unix implement P-threads. True64 Unix also implements P-threads. It supports a two-level threading model which allows user-level threads to be bound to kernel-level threads. So this is also false. Actually, Solaris, Linux, Mac OS implement P-threads. They have told this particular True64 Unix as exception, but there is no proof that they have not implemented P-threads. So it will also implement P-thread is the statement that we can infer from that. Option number 3 will be the right answer. Next question, what shall be the average waiting time per process if we know that 10 processes on average arrive every second and there are normally 20 processes in the queue? This question will need a new information that was not used in any of the previous year question paper. To calculate the average waiting time per process, we use Little's law, a fundamental principle in queuing theory. L is equal to lambda into W. L will be the average number of items in the system, that is the queue length. Lambda will be the arrival rate, items per unit time, and W will be the average waiting time in the system. So we have to find W. So W is equal to L divided by lambda. L is equal to average number of items. So average number of processes in the queue. Average number of processes in the queue is given as 20 processes. That will be capital L. Lambda will be arrival rate. 10 processes arrive every second. So 10 processes per second will be the lambda value. Now we have to calculate W. So W is equal to L divided by lambda. L will be 20 processes divided by 10 processes per second. This per second will move to the numerator. Processes will go. 20 divided by 10 will give you 2. So the answer will be 2 seconds. 2 seconds will be the average waiting time in the system. Option number 2 will be the right answer. This is a typo here. Next question, what is the total swap time? Swap in and swap out together will give you total swap time. In a system for a 15 MB process, megabyte process with a transfer rate of 30 megabytes per second. See the unit carefully, it is megabyte and megabyte. Given that there is an average latency of 12 milliseconds, however, no headseeks involved. They are asking for the total swap time. Now we will just see what is the swap in time formula. Process size divided by transfer rate plus latency. So this has to be calculated first and then you have to add latency. What about swap out time? It is the same formula. Then how will we take total swap time? It is swap in time plus swap out time, or you can take it in other way as twice the swap in time or twice the swap out time, because both are going to give you the same formula. From the question we will take two details. Process size is equal to 15 MB and the transfer rate is given as 30 megabytes per second and the latency value is given as average latency of 12 milliseconds. So latency will be 12 milliseconds. Since it is in MB and MB, we need not touch it, but here it is per second and here it is milliseconds. So in order to convert this into seconds, latency can be taken as 12 into 10 to the power minus 3 seconds. This will be the latency value to keep it in the same unit. Now let's take the total swap time. The process size will be 15 megabytes. The transfer rate will be 30 megabytes per second along with the latency 12 into 10 to the power minus 3 seconds. So this is 1 by 2. Megabyte will get cancelled and this seconds will move to the numerator plus 12 into 10 to the power minus 3 seconds. Both are having same units, seconds. 1 by 2 can be written as 0.5 seconds plus 12 into 10 to the power minus 3 can be written as 0.012 seconds. 2 into what is 0.5 plus 0.012? It is 0.512. So this is 0.512 seconds and when you multiply it by 2 you will get 1.024 seconds. This will be the total swap time. So the swap in time will be 0.512 seconds. The swap out time will be 0.512 seconds. And the total swap time will be these two time taken together. So option number 1.024 seconds will be the right answer. Next question, consider the following interrupt protection levels in Linux and arrange them in the increasing order of their priorities. This question has been previously asked in one of the previous year question paper. Interrupt protection levels in increasing priority are given here. User mode programs that are preemptible, kernel system service routines that are preemptible, bottom of interrupt handlers and top of interrupt handlers. This will be A from the question, kernel system will be D, bottom of will be B and top of will be C. They are asking in increasing order of priority where the order should go from bottom to top as per the question and as per the diagram also it is the same. So the order will be A, D, B, C. Option number 4 will be the right answer. Linux implements architecture by separating interrupt service routines into two sections, top half and bottom half. Top half will be the standard interrupt service routine that runs with recursive interrupts disabled. Interrupts of the same number are disabled but other interrupts may run. The bottom half is run with all interrupts enabled by a miniature scheduler that ensures that the bottom halves never interrupt themselves. The bottom half scheduler is invoked automatically whenever an interrupt service routine exists. So top half will be running with all recursive interrupts disabled while the bottom half will have all interrupts enabled. This is one extra point that you can learn here. Each level may be interrupted by code running at a higher level but will never be interrupted by code running at the same or lower level. So when you take increasing priority, this will be the most prioritized part. Here they say every level will be interrupted by code running at a higher level. It means when C has to do something, it can interrupt B. But it can never be interrupted by code running at the same or lower level means B cannot disturb C. So they say whether it's same or lower level, it can never be interrupted. But for user mode code alone, they are saying user processes can be preempted by another process when a time sharing scheduling interrupt occurs. So the exception is given to this part. Next question, which of the following shows the correct hierarchy of a layered file system in an operating system? So let's see the hierarchy. Application programs, logical file system, file organization module, basic file system, I/O control and devices. So A, logical file system, B, file organization module, C, basic file system, D, I/O control. Application programs is E. So this is the hierarchy top to bottom. So the order will be E, A, B, C, D. This is available in option number 3. Option 3 will be the right answer. File system provide efficient and convenient access to the disk by allowing data to be stored, located and retrieved easily. Now we'll see about the layered file system terms. I/O control level consists of device drivers and interrupt handlers to transfer information between the main memory and the disk system. So devices are here. And what about the basic file system? It needs only to issue generic commands to the appropriate device driver to read and write physical blocks on the disk. What about file organization module? The file organization module knows about files and their logical blocks as well as their physical blocks. Finally, the logical file system manages metadata information. If you get into the reference book, you will have lots of detail, but this is just like an introduction to all the terms that are present here. Next question, once the process is allocated CPU and executing, which of the following events could not occur? Let's see the A statement. The process could issue an I/O request and then be placed in the ready queue. B states that the process could create new subprocesses and wait for the termination of the subprocesses. C states the time slice of the process expires and it may join the waiting queue. When you take scheduling, they are saying the time quantum when it is over, it will join the waiting queue. What about D? The process is forcibly removed from the CPU and is put in the waiting queue due to the arrival of an interrupt. So these are the key terms that you have to take from the statements. Now we will see every statement. When a process issues an IO request, it cannot continue execution until the IO completes. It is moved to the waiting queue and not the ready queue. This queue is wrong. It will be moving to the waiting queue. They say it is blocked here because it is waiting for an IO to be completed. Once that request gets completed, it will continue execution. Ready queue is for processes that are ready to run but waiting for the CPU time. Only when the CPU is not available, only when it needs time from the CPU, it will be pushed to the ready queue. So this statement is giving clue for another statement here. So from this we can say that A is definitely wrong. And here they are asking which cannot occur. So A cannot occur. Any option that does not include A can be ruled out. Always see what they are asking. Next, B. Parent process can spawn. Spawn means it can create child processes and wait until they finish. This is common in multitasking system. So B is definitely true. In this question, B cannot be taken as the answer. So I am just marking right and wrong and then we will go with the options later. What about C? When a process time slice expires in preemptive scheduling, it is not waiting on any resource. When it is waiting for any resource like IO or something, it will move to the waiting queue. If it is not waiting for any resource, it is moved to the ready queue and not the waiting queue. So here it is wrong. It has to move to the ready queue. So this is also wrong. The waiting queue is only for processes that are blocked due to IO or other events. C is also wrong. What about D? An interrupt may cause the process to be preempted, but it is typically moved to the ready queue, not the waiting queue. Here also it is moving to the ready queue and not to the waiting queue. The waiting queue is reserved for processes that are blocked, not simply interrupted. It is blocked for IO or other events they have mentioned. Only if the interrupt triggers a blocking operation like IO, the process would go to the waiting queue. So D is also wrong. So just for clarity I am writing B will occur. A, C, D will not occur. So the question is about which will not occur. So we can even rule out option 3 because A, C, D are involved here. Option number 4 will be the right answer. So understand, when there is IO request, it will enter the waiting queue. When the time slice expires or when there is an interrupt, both will be taken to the ready queue and not the waiting queue. Next question. Identify the correct statement from the following with respect to spin lock semaphores. Let's see the statements now. The name refers to busy waiting semaphores. So here they are asking for correct statements. B states they are not useful when the locks are to be held for a short duration of time. C states it may require multiple context switches when a process waits on a lock. D states they are often employed on uniprocessor systems. Now we have to check which are right. Let's start with A. A spin lock is a synchronization mechanism where a thread spins in a loop, continuously checking if the lock is available without giving up CPU control. This is known as busy waiting and it's the defining characteristic of spin locks. The name refers to busy waiting semaphores is perfectly true. What about B? Spin locks are most efficient when the lock is held for a very short time. They are actually useful, so the statement is wrong. The overhead of a context switch is avoided, making spin locks ideal for quick operations. If the lock is held for a long time, spin locks waste CPU cycles and are inefficient. So it is perfectly useful for short time and not for long time. They say when it is held for a long time, spin locks are wasting the CPU cycles and so it becomes inefficient. What about C? Spin locks do not involve context switches because the thread keeps running and polling the lock. In contrast, semaphores do cause context switches when a thread blocks and the scheduler switches to another thread. So here they say spin locks do not involve context switches. So this is also wrong. What about D? Spin locks are not ideal for uniprocessor systems. They say they are often employed on, which is totally wrong again. Since only one thread can run at a time, a spinning thread wastes CPU cycles while the lock holder cannot proceed. Spin locks are better suited for multiprocessor systems where one thread can spin while another releases the lock. So what is thread spinning here? Thread spinning in a loop is continuously checking if the lock is available without giving up CPU control. If there is only one processor and that processor is going to concentrate on this particular part, then which thread will release the lock? So in that case, it is suited for multiprocessor system and it is not ideal for uniprocessor system. Only A is correct here. So option number 1, A only will be the right answer. So we will rule out 2, 3 and 4 here. Next question, we have matching list, clustered page table, hierarchical page table, segmentation, inverted page table. Clustered page tables group multiple pages into a single entry, reducing overhead. This is especially helpful when large portions of the virtual address space are unused. When large paths are unused and only certain paths are used, this will create a sparse look. You could have come across the term sparse matrices. Many entries will be 0, only few entries will be non-zero. Similarly, non-zero entries can be taken where you have entries. The large portions that are unused can be taken for 0 entries in that matrix. So here clustered page table is useful for sparse address spaces. A will be mapping to 3. A3 is available in 2 of the options. What about hierarchical page table? 64-bit systems have massive address spaces. Hierarchical means multi-level page tables grow too large and complex. Managing multiple levels of page tables becomes inefficient and memory intensive. So we will go with generally considered inappropriate for 64-bit architectures because they say managing multiple levels becomes inefficient and memory intensive. So this is equivalent to saying it is inappropriate. B will be mapping to 1. B1 is available in option 2. We can even rule out option 1. The next one is segmentation. Segmentation divides memory into logical units like code, data and stack. This aligns with how users and programmers think about memory, offering protection and modularity. So segmentation will be supports a user view of the system. They say this aligns with how users and programmers think. So C will be mapping to 4. What about inverted page table? Unlike traditional page tables which map virtual pages, inverted page tables map physical frames. There is one entry per physical frame, making it memory efficient for large systems. Has only one entry for each real page or frame of memory. D will be mapping to 2. Option number 2, A3, B1, C4, D2 will be the right answer. Next question, this is about RAID levels and this has been quite a very repeated question in the previous year question papers. So let's get into the diagram. RAID level 2 is memory style error correcting code. A will be mapping to 4. A4 is available only in one option. RAID level 3 is bit interleaved parity. B is mapping to 3. RAID level 5 is block interleaved distributed parity. C is mapping to 1. RAID level 6 is P plus Q redundancy. So D will be mapping to 2. We have C1 and D2 also. Option number 1, A4, B3, C1, D2 will be the right answer. So it's better you have an idea from RAID 0 to RAID 6 levels and also have an idea about what is happening in every level so that it will be helpful for you in some other question paper. Now we are entering into the comprehension type of question where 5 questions depend on this particular part. Consider the following disk queue with request for I/O to block on cylinders 45, 81, 185, 33, 175, 99, 150, 77. Consider that the head starts from location 58. Let's see the first question. What shall be the total head movement of cylinders if the FCFS disk scheduling method is used? So let's take the cylinder arrangement here. They say it starts from location 58. I have placed the request 33, 45, 77, 81, 99, 150, 175 and 185. What is FCFS? First come first serve. Processes disk request in the order they arrive. So from 58 the first request will be 45. From 45 it will move to 81. From 81 it will go to 185. From 185 it will go to 33. From 33 it will move to 175. From 175 it will move to 99. From 99 it will move to 150. From 150 to 77. So we are just using the same order that is given in the question. That is the purpose of FCFS. In whichever order they arrive, it will be processed in that way. Now let's take the difference between 58 and 45 to be 13. Then 45 and 81 will be 36. 81 and 185 will be 104. Then we have 185 and 33 to be 152. The difference between 33 and 175 will be 142. Then 175 to 99 will be 76. 99 to 150 will be 51. 150 to 77 will be 73. When you add up all these, you will get a value of 647. This will be the total head movements of cylinders when we use FCFS disk scheduling method. Option number 3, 647 will be the right answer. Next question. What will be the total head movement of cylinders for the SSTF disk scheduling technique? The head starts from location 58. What is SSTF? Shortest seek time first. This selects the request which requires the least disk arm movement from its current position regardless of the direction. So from 58 we have two possibilities. 77 minus 58 will need 19 movements and 58 minus 45 will need 13 movements. Which is short here? 13 is short. So from 58 we will process 45 next. Again from 45 you have two options, 33 and then 77. 45 and 33 will need only 12 movements while 45 and 77 will need 32 movements. So we are going with 33. From 33 the next request that has to be processed will be 77 only. After 77 it is 81, after 81 it is 99, after 99 it is 150, after 150 it is 175, after 175 it is 185. So now let's calculate the total head movement. Total head movement is equal to 58 and 45 will have 13 movements, 45 and 33 will have 12 movements, 33 and 77 will have 44 movements, 77 and 81 will have 4 movements, 81 to 99 will be 18, 99 to 150 will be 51, 150 to 175 will be 25, 175 to 185 will be 10. Altogether, we will have 177 head movements. This is available in option 3. Option number 3 will be the right answer. Next question. What shall be the second request being processed by scan left disk scheduling technique for the already given request queue? Actually, when you take scan algorithm, scan moves in one direction. It can be either left or right, servicing all requests along the way. Once it reaches the end of the disk, it reverses direction and continues servicing request in the opposite direction. This is scan algorithm. Since they have mentioned scan left, we can take it like when the direction is set to left, the disk head moves from its current position towards the lower numbered cylinders, servicing request along the way. So let's take the cylinders here. The current position is 58. This is left and this is right. So when they say it moves to the left, that is scan left. When it is set to left, it is moving towards the lower numbered. Compared to 58, 45 and 33 are lower numbered. 77 and all are higher number. So it is moving towards the lower numbered cylinders is what they say. So from 58, the first request will be for 45 and the second request will be for 33. What is the question here? Second request being processed by scan left. If this is going to be the first request, what is the second request? 33 will be the second request. Option number 3, 33 will be the right answer. So after finishing 33, once it reaches the end of the disk, means it will come to this particular end, it reverses direction and continues servicing request in the opposite direction. So we are not getting into detailed scan algorithm now. There are already previous year question papers that explains scan algorithm better. So for this question alone, I am just giving you the answer. Next question, what shall be the total head movement of cylinders for the C-scan disk scheduling technique if the head starts moving in the right direction from the initial position? What is C-scan? The disk head moves in one direction only. As per this question, it is given right side. So we are taking right. It services all requests along the way until it reaches the end of the disk. Once it hits the end, it jumps back to the beginning of the disk without servicing any request on the return trip. So take this to be one end and the other end. After it hits this particular end, it will come back to the beginning without servicing anything on the return trip is what they say. No service will occur during the return trip. Now let's get back to the arrangement. The head position is in 58 and we have to move to the right side. Here they are talking about end of the disk. Any disk cylinder will start from 0. Since it has gone till 185, so we can take 199 to be the end here. There are totally 200 cylinders. We are taking 0 to 199 as the range. Now from 58 we have to move towards right. 58 to 77. So let's calculate the total here. The difference is 19. From 77 it is 81. It is 4. 81 to 99 is the next request. It has 18 movements. From 99 we move to 150. There are 51 movements. From 150 we are moving to 175. 25 movements. From 175 to 185 it is 10 movements. From 185 it has to reach the end of the disk, which is 199. The difference is 14 here. From 199 it has to jump back to the beginning of the disk, which is 0. What is the total number of movement? 199 movements are involved. Just returning back to the beginning of the disk without servicing any request. After it comes to 0, it will service the request again in the right direction. So from 0, the first request will be 33. So the movements will be 33. From 33 it will process 45 next and the movements will be 12. When you add all the movements together, you will end up with 385 as the total head movements. Option number 4 will be the right answer. So it will start from the right, it will go till 185. From 185 it will reach the end of the disk, that is 199. From 199, once it hits the end, it jumps back to the beginning is it will move to 0 without servicing any request. That's why the whole movement, now 199 minus 0 will give you 199 movements are counted for the total head movement. It will again start servicing the request once it reaches the beginning. So it is servicing 33 and 45. Next question. What shall be the second request being processed by CLOOK write disk scheduling technique for the already given request queue? In CLOOK, the diskette moves in one direction only. For this question, we are taking write. It services all requests in that direction until it reaches the last request. Instead of going to the end of the disk, instead of going to 199, it jumps directly to the lowest number pending request and continuous servicing in the same direction. Now the question is, what shall be the second request? So the current head position is 58 and it has to move in the right direction. The first request that is being processed will be 77 and the second request will be 81. Option number 1, 81 will be the right answer. You just need to find whatever is asked in the question and then move out of the question to save time. Don't keep working for total head movements in CLOOK as well as in scan question and waste your time. Just answer whatever is being asked and then move. I already explained CLOOK and scan algorithm in previous year question paper. That's why I am not working on it in this particular video. If you want to know how that particular algorithm works for calculating total head movements, I would suggest you to go and watch the previous year question paper solutions video in order to understand how that process is happening. With this, we are completing Unit 5 questions. Let's solve Unit 6 Software Engineering questions. Which of the following is not a requirement elicitation technique? Let's see the options one by one. If you take interviews, it is a direct elicitation technique that is used to gather requirements by speaking with stakeholders. It helps uncover user needs, expectations and system constraints through structured or unstructured conversations. So, interviews are requirement elicitation technique. What about the use case approach? It's a technique to identify functional requirements. Here also you are identifying requirements by modeling interactions between users and system. You could have seen use case diagrams in the UML part. It captures scenarios and workflows, making it a powerful tool for requirement elicitation. So use case is also a requirement elicitation technique. What about the third one? Facilitated application specification technique, which is called as FAST. This is a collaborative workshop based method where stakeholders and developers jointly define system requirements. Stakeholders, you can take somebody like the clients or the one who uses the system, and developers are the ones who are going to develop the system. So they together define the system requirements. This encourages consensus and clarity, making it a formal elicitation technique. The one who is going to use it and the one who is going to develop it, when they come together to tell you about the requirements, you will get a complete idea about what you have to develop. So definitely facilitated application specification technique is also an elicitation technique to elicit requirements. What about DFDs? That is data flow diagram. Data flow diagram is actually a modeling tool. It is used to represent how data moves through a system. They will help you visualize processes and data interactions. When you take elicitation techniques, it is about gathering the requirements. But data flow diagrams actually represent what the system is going to do, how the workflow is going to happen. So DFDs cannot be requirement elicitation technique. So the question is about not a requirement elicitation technique. So we are going with option number 4, data flow diagram, as the right answer. Next question, estimation of software development effort for organic software in basic COCOMO is. Usually we refer to Roger Pressman books, but there are also other reference books for software engineering written by Rajiv Mal and Somerville. So when you go for other reference books, you can find all these details definitely. The basic COCOMO, which is the constructive cost model, it's a software estimation model developed by Barry Boehm. It provides a way to estimate the effort required to develop software based on the size of the project measured in KLOC. K stands for kilo. So what is kilo? It's 1000. Based on 1000 lines of code measure, they are estimating the effort required to develop the software. Basic COCOMO effort estimation formula is given by effort is expressed in person months units, which is equal to A into KLOC to the power of B. What is KLOC? Thousands of delivered source instruction, that is the lines of code. What about A and B? They are constants that vary depending on the project type. Now if you take all the four options, they are in the form of A into KLOC to the power of B only. Now we will see the project type and the related constants so that we can map it with organic software that is asked in the question. Let's take the project categories. If it is an organic project, the value of A will be 2.4 and the value of B will be 1.05. So this will be the right answer for organic software as asked in the question. This particular option is perfectly matching in option number 1. Option number 1 will be the right answer, which has the same A value and B value. What about fourth option? You have A value as 2.4 but B value is different here. So we will rule out the other three options. What is this organic project type? They are small, simple software projects with experienced teams and flexible requirements. What about the other project types? We have semi-detached project type with A value as 3.0 and B value as 1.12. This is about the medium-sized projects with mixed experience and more complex requirements. So when it is organic software, it is flexible requirements. When it is semi-detached, it is with some more complex requirements. What about the other type? Embedded project. It has the value of 3.6 for A and 1.20 for B. These represent large complex projects with tight constraints and rigorous standards. So the project itself is described as complex project. Here it is small, here it is medium and here it is large. So based on the project type, the value of the constants are differing here. Since the question is about organic software, we are picking A and B values from the first project type, that is given as organic. So these details you cannot find in Roger Pressman book, which is usually taken as the reference book for software engineering. You have to go for the other books. To get the list of books that you need as reference for this particular unit, you can always find it in my blog. The blog link is available in my channel description itself. So these questions will give you an idea about what kind of questions can be developed from this particular topic, basic COCOMO model. Next question. The process followed in order to find difficult, unknown and hidden information about a software system. So there are three keywords here: difficult, unknown and hidden information about a software system. What is the process called? They have asked whether it's engineering, re-engineering, reverse engineering or inverse engineering. Let's see about one by one. What is actually software engineering? It is focused on designing, developing, testing and maintaining software systems. It is not about uncovering hidden or undocumented aspects of existing system. It is about developing something new. Engineering means to develop something or to make something. When you are making something, you are not going to dig and take unknown information or hidden information. So definitely one is not the answer. What about re-engineering? This is the process of modifying and improving existing software systems, often by restructuring or rewriting code. It assumes you already have access to the source code and documentation. So it's all about enhancement and not discovery of unknowns. You are making some kind of modification and showing some enhancement. You are not discovering what is hidden there. So software re-engineering is also out of the race now. What about reverse engineering? Engineering is making something. Reverse engineering is you have a product and you have to break it into parts and find what is inside it. This particular term is actually related to the one that is asked in the question. The process of analyzing a software system to identify its components, and their relationships without prior access to source code or documentation is reverse engineering. This is used to uncover difficult, unknown or hidden information. This is common in legacy systems, third-party software or security analysis. This helps understand undocumented features, hidden dependencies and system behavior. So whenever you have a third party software and you want to understand what the software is going to do, you have to do reverse engineering in order to understand what is hidden or what is the behavior of the system. So this will also help you understand about undocumented features. Certain features will not be present in the documentation part. It will not be explicitly mentioned. Those features can also be understood when you take up reverse engineering process. The answer for this question will be reverse engineering, and we mark option 3 as the right answer for this question. What about inverse engineering? This is not a formally recognized term in software development, so we will also rule out option 4. Next question. Which of the following is not a software characteristic? Now we will look about each option and then go for the answer. What is software does not wear out? Usually when you take some mechanical parts, there will be degrading over time. If you keep on using a particular motor, at one stage you have to apply grease or some kind of oil to make it work better. So that is called degrading. This will happen in hardware. Even if you take something like iron, it will be rusted after some time. You will have corrosion kind of issues in certain metals. All these things happen with physical objects and not with software. Unlike hardware, software does not degrade physically over time. It may become outdated. It means now nobody can be using it, or incompatible. Based on your operating system or your platform, it may not be compatible, but it does not wear out like mechanical parts, which is the hardware. So definitely this is true. Software does not wear out similar to hardware. So this is a software characteristic. What about second option? Software is flexible. Software can be modified, updated or customized to meet changing requirements. This adaptability is one of its core strengths. So definitely software is flexible. This is also true. Software is not manufactured. Of course, manufacture is making something. Software can be engineered. That's why software engineering becomes a formal term. In fact, software is developed but not manufactured. Manufactured means you are making it by some kind of hardware. This is similar to the first explanation that is given for does not wear out. Similar to mechanical parts, you cannot manufacture it. It is all about development. It is created through design, coding, testing, not assembled on a production line. Means you don't have spare parts and you bring it together to give it as a bike. Okay, so that's what we say as not manufactured, and it is also a software characteristic because you can develop but not manufacture. You can assemble lines of code and make it a big project. That comes under coding, and that is not about manufacturing. Manufacturing is happening in terms of physical aspect. So that cannot be taken as a characteristic of software. So they have given us not manufactured, which is right. What about the final option then? It must be the answer for this question. Software is not inherently correct. It means by default it is not right. Basically, when you develop a software, there are possibilities that it can contain bugs, logical errors or some kind of design flaws too. Even well-tested software will be failing under some unexpected condition is what they say. The correctness of the software depends on how well it's specified, designed, implemented and tested. The nature of the software is not to be correct. So software is always correct is not a software characteristic, and we mark option number 4 to be the right answer of this question. Next question. Arrange the following in the increasing order of coupling from lowest coupling to highest coupling. When you take software design topic, there are two terms, coupling and cohesion. When you take a particular module, within that module, how far the connection is going to be there is given by cohesion. Coupling happens between two modules. How much dependency is there is what coupling is about. Coupling is an indication of interconnection among modules in a software structure. In one of the reference books, I think it's the software engineering book that is written by Rajib Mal, we have classification of coupling and they have given the order from low to high. It is in increasing order. So based on this, first let's try to map it to the option. We have common coupling, it is A, stamp coupling, it is B, control coupling is C. We don't have something called external coupling, we'll just hold that. Then in E we have content coupling. Just look for the order B, C, A, E in any of the option. Here you have B but C doesn't follow. Here you have B, C doesn't follow. But here you have B, C follows. And after A we have E here. In two of the option we have A and E in successive position. But B and C are separate here. So we cannot consider option 2. The rest of the options don't have this particular order. Just based on what is given in this particular reference book diagram, I am trying to find the answer because there is no detail about external coupling in two of the reference books that I referred. Other books might have it. These books I have listed them as reference books in my blog. So based on them I am trying to do this. This will be the order. So now we will see about the types of coupling and understand what each option is about, and then we will understand how external coupling is going to sit between control and common. Only 3 is having the order of BC and AE. Based on that, external is going to sit somewhere here. So after understanding BC, AE, we will understand how external is sitting there. Two modules are data coupled. We are going to learn about this particular term now. If they communicate using an elementary data item that is passed as a parameter between the two. So this is data coupling. What about stamp? Two modules are stamp coupled if a data structure is passed as an argument, but the called module operates on only some of the individual components of the data structure. We can take structure in C as a data structure. So in structure you will have multiple data items and multiple data also. What they say is it may depend only on some of the individual components. Take a particular struct, you have int, you have character, you have float, etc. Now this particular stamp coupling will take place when the data structure is passed as an argument. But instead of operating on all these components, it will operate only on two components. In other terms, we can say if they communicate using a composite data item such as a record in Pascal or a structure in C. So when it is a single data item, it is data coupling. When it is a data structure or a composite data item, it is stamp coupling. What about control coupling? Two modules are control coupled if one passes an element of control to the other module. That is, one module explicitly controls the logic of the other module. When you are able to control the logic of other module, that is control coupling. Next is common coupling. When two modules share same global data items, that becomes common coupling. I hope this term will give you some clarity. What about content coupling? Two modules are content coupled if one directly references the contents of the other. What is referencing the content? If they share code, a jump from one module into the code of another module can occur. Sharing code and sharing data item and sharing data structure along with sharing global data items all are different. But when you are depending upon another module for something, coupling comes into existence. So low coupling means it happens at data level because only a data is going to be shared. But when you take content, you are sharing a particular code segment itself, which gives you high coupling. Let's see about external coupling now. External coupling involves dependency on external formats, protocols or hardware interfaces like relying on a specific file format or device driver. But when you take this to be logic and this to be global data item that are being shared by more than 2 or 3 modules, the risk here is very less is what they say. When you take from stamp to content, this is the mid position. They say it is more intrusive, means it is getting inside more than control. It is more than logic because you are touching a device driver here. For an example I am telling. So it is more than logic, but compared to global data item, this is less risky. So in that way we are placing external between control and command. So we are going with option number 3. BCDAE as the right answer. So this is going to global and this is going to sharing the code segment itself. So compared to A and E, external is just depending on a specific file format alone. So maybe you can take it like it is asking for a header file. So it stops with header file. But global data item will be more risky when it is going to be shared by 2 or more modules. Next question. Arrange the following types of testing in the order they are usually performed in the software development life cycle. Out of these 4 options, they have given either B will be starting or C will be starting. What is unit testing? You are testing something as a module. It is the basic level of testing you are going to start. What is system testing? You are going to test system for performance, reliability, etc. It's overall. Whenever you are going to perform any testing, when you take the software development life cycle, it will start from small or it will start from taking the whole system. You have to think it in that way, and then you have to go with unit testing as the first one in the order. Just based on the option, this is how you have to think, I am telling you. Now let's see about unit testing. This tests individual components or functions of the code. This is performed by developers to catch bugs early. So when I write a particular function, I run and I try to debug if there are some bugs. So this is B. Next, after unit testing, after testing everything individually, what you have to do? You have to combine all those components and test. That is integration testing. Ensures that modules or components work together correctly. They are working individually here and here they are working together. Because when you combine 2 or more modules, there are more possibilities of error when they interact with each other. This focuses on data flow and interface issues, and so integration testing comes next. They are asking in the order they are usually performed in the software development life cycle. When you write code, first you will test it. After that only you will map multiple files and go for integration testing. You have to think it in that order. After integration testing, now you have 2 more testing, system and acceptance testing. From the term acceptance, you have to understand that the software is tested as a whole from the end user side. That is acceptance. But system testing is the software is tested as a whole for performance issues. So before accepting something, you have to go for overall system testing. So system testing comes next. That is C. Validates the complete and integrated software system against the requirements, and this is performed by quality assurance teams. So here they have given it is performed by developers and here it is by QA teams. You need to know who is doing what. Finally, we have acceptance testing, which is option D. This confirms the system meets business needs and it's ready for delivery. This is often done by clients or end users. When it is a live website or something, we can term end users. When it is a specific product developed for a company or a business, that time you can use the term client. BACD. Option number 2 will be the right answer. Even if you don't have elaborate idea on all these testing, just with plain idea on how the software development cycle will go on. You write a code, you write a function. After that, first you test only the function, then you test it as a program, then you will check with various parameters whether the function is running in all condition or it is stopping somewhere in mid, that will be system testing. After that you are going to the end user and asking them to test by themselves. The beta version, the live version, that is acceptance. Just thinking in plain program format itself, you should be able to arrange these testing types in the order. Next question. Which of the following cohesions are better than the procedural cohesion? Functional, sequential, temporal, communicational, logical. So they are asking which are better. Cohesion is a measure of the functional strength of a module. This happens within a module and there are many types of cohesions, and of course Roger Pressman books have not discussed about it. Rajiv Mal and Somerville books have references about it. First I will take Rajiv Mal's diagram here. We have coincidental, logical, temporal, procedural, communicational, sequential and functional. Functional cohesion A is given here, sequential B is given here, temporal C is given here, communicational D is given here and logical E is given here. This is low cohesion and this is high cohesion. Cohesion means the functional strength. When they say which are better, it means you are moving towards high. So after procedural, whatever cohesion you have, that will be called as better. Which are worse if you ask, then this particular part will be taken. So here it is for the better. So better means you have to look after procedural. So after procedural we have D, B, A. So we will mark A, B, D. The order doesn't matter here. Only the cohesion names are to be considered. So A, B and D only. Option number 2 will be the right answer for this question. These three cohesions are better than procedural cohesion. Now we will look about all the cohesion. A module has coincidental cohesion if it performs multiple completely unrelated options. We say about logical cohesion when all the elements of the module perform similar operation such as error handling, data input, data output, etc. What about temporal? When it performs a series of operations related in time, we call it as temporal cohesion. A module has procedural cohesion if the set of functions of the module are executed one after the other. Though these functions may work towards entirely different purposes and operate on very different data, the execution goes one after the other. That is procedural cohesion. A module is said to have communicational cohesion if all functions of the module refer to or update that same data structure. It is said to possess sequential cohesion if different functions of the module execute in a sequence and the output from one function is input to the next in the sequence. You have to understand the difference between procedural and sequence. Both are actually saying it has to be executed one after the other. One after the other and in a sequence both mean the same. But here the functions work towards entirely different purpose and they operate on different data. But in sequential, the output of one function becomes the input to the next function in the sequence. So when you have A, B, C, three functions together, after A we go for B, after B we go for C. Here this will operate differently, this will operate for a different purpose and this will operate on a different data. This is procedural but it will go in this order. When you take D, E, F as sequential cohesion, all these three will work together in such a way that output of D becomes input to E, output of E becomes input to F. This will be called as sequential cohesion. These two cohesion may turn out to be a separate question, that's why I am explaining you separately. A module is said to possess functional cohesion if different functions of the module cooperate to complete a single task. When they have a single goal, at that time it is functional cohesion. We have another cohesion called informational cohesion which is not mentioned in this particular book. If it performs a number of operations each with its own entry point with independent code for each operation, all performed on the same data structure, that will be informational cohesion. Where does this informational cohesion stand? It stands above functional cohesion. This is taken from another reference book, Somerville's software engineering book. So we have coincidental, logical, temporal, procedural, communicational, functional and informational. So for learning purpose, I am listing even this particular order. Next question. Which of the following belongs to McCall's quality factors? McCall's software quality factors. We have three categories: product operation, product transition and product revision. Under operation we have correctness, reliability, usability, integrity, efficiency. So we have usability from here, integrity from here. What about the revision category? Maintainability, flexibility, testability. A is given here. In transition category we have portability, reusability, interoperability. We don't find functionality in McCall's software quality factors. Only A, B and C belong to McCall's quality factors. So we will go with option number 4, A, B and C only as the right answer. We will first see about these quality factors and then I will tell you where does functionality belong to. Let's take the operation category first. What is correctness? It is the extent to which a program is going to satisfy the specification, ultimately fulfilling the customer's objective. What about reliability? The extent to which a program can be expected to perform its intended function with required precision. With accuracy you can take. What about efficiency? The amount of computing resources and code required by a program to perform its function. The more resources it is going to save, that much efficient it is. Integrity is the extent to which access to software or data by unauthorized persons can be controlled. Usability is about the effort required to learn, operate, prepare input for and interpret output of a program. We'll go for the next two categories. Maintainability is the effort required to locate and fix an error in the program. Flexibility is the effort required to modify. Testability is the effort required to test a program whether it is actually performing the intended function or not. Portability is about the effort required to transfer the program from one particular environment to another or from one hardware to another hardware. Reusability is the extent to which a program or even parts of the program can be reused in other applications. Interoperability is the effort required to couple one system to another. You are creating some kind of dependency or interconnection between two is what they are saying about interoperability. Some questions can be explained in detail. Certain questions can be dealt only in this way. I can just give you a one-line statement about every term so that you can learn it on your own. Now we will understand functionality is a part of what. When you take Roger Pressman's reference book, you have McCall's software quality factors topic. Below that topic, you have ISO 9126 quality factors. And in this category, you have functionality as a quality factor. So this belongs to ISO quality factor and not McCall's quality factor. In ISO, you have reliability, usability, efficiency, maintainability and portability. But this is the only term that is present in ISO and not in McCall's. That's why this has become a question. If you take reliability, it is present here and it is present here. When you take usability, it is the same case. When you take efficiency, it is the same case. Maintainability is there and portability is also there. You can have a question like, which factors are common for McCall's and ISO? You should know at least what are the quality factors that involve in ISO as well as in McCall's category. Next question. Match list 1 with list 2. List 1 is about the software quality characteristic and list 2 is about the description. Based on the learning that we got from the previous question, now we are going to answer here. We will start with efficiency. Efficiency, I said it's about the resources. So here we have a statement, relationship between the level of performance of the software and the amount of resources used under stated condition. This will be efficiency. B will be mapping to 3. Then we'll go for portability. We know portability means when you are going to adapt it from a particular hardware or software environment to another. So D can be mapped to 1. Ability to transfer the software from one organization or hardware or software environment to another. It can be between organization or between two hardware or two software. That's what they say. This is portability. D will be mapping to 1. B3, D1 is available only in one option. When I say I have to locate error and then fix it, it is about making some kind of corrections. So maintainability can be mapped to fourth statement here. Effort needed to make modifications including corrections, improvements or adaptation of software to changes in environment requirements and functional specification. When you are going to identify or locate an error and then fix it, that comes under correction. So that is maintainability. C will be mapping to 4. And what about reliability? It's a capability of software to maintain its level of performance under stated conditions for a stated period of time. They said how far it is going to perform its intended function. So that can be equated to maintain the level of performance under stated condition for a stated period of time. A will be mapping to 2. A2 is here. Option number 2, A2, B3, C4, D1 will be the right answer. D has 1 only in one option. If you are sure about portability, you can complete this match even with no idea on reliability, efficiency and maintainability. Next question. Match list 1 with list 2. Now from the learning that we got from previous year question paper, we know what is cyclomatic complexity. We can map C to 1. Cyclomatic complexity measures independent paths in code. C1 is available in 3 of the options. It is quite difficult to narrow down now. So we will rule out 2 as of now. Now let's take boundary value analysis. When they say A is less than B, you have to check the limits of A and B to check whether this condition is working. Say for example, when they say the age for voter ID will be minimum 18 years, you can check less than or equal to 17, then 18, then greater than 18. This focuses on limit of input ranges. B will be mapping to 3. B3 is available in 2 options again. So 1 is already ruled out. And so we can even rule out 3 and 4 now. What about equivalence partitioning? The name itself says you are partitioning, which means divides input into valid invalid sets. A will be mapping to 2. A2 is available here. What about decision table testing, in which a number of combinations of actions are tested under varying set of conditions? D will be mapping to 4. Now I will give you example for A, B and D so that you will have better idea. For C, you have previous year question paper. So from that question paper solution videos, you will be able to understand cyclomatic complexity. Regarding A, B and D, I will just give you some examples. Before that, we will mark the answer. Option number 1, A2, B3, C1, D4 will be the right answer. So what is equivalence partitioning? It's dividing the input. A form accepts ages between 80 and 60. So it is generally a form, not this voter ID example. Okay. What is valid partition? If the particular age falls between 80 and 60, that is valid partition. When it is less than 18 and greater than 60, that becomes a part of invalid partition. So you are dividing the forms by 2. Whatever is between 18 and 16, it is in the valid range. When it is less than 18 and greater than 60, it becomes invalid range. So when you take voter ID, what is valid? 18 and above. So greater than or equal to 18. What is invalid? Less than 18. This is how we do for equivalence partitioning. What about boundary value analysis? Let's take the same example. A form accepts ages between 18 and 60. What are the different kinds of test cases involved in boundary value analysis? You have to check for below minimum. If it has to start from 80 and run till 60, What is this value before 18? It is 17. So you will be checking the below minimum value. The minimum value is 18. Below minimum is 17. For 17 you have to check the minimum value, 18 you have to check, the maximum value 60 you have to check, and just above the maximum 61 also you have to check. After that, the just above minimum and just below maximum. After 18 you have 19 and below 60 you have 59. Even 19 and 59 have to be checked. This is boundary value analysis. The boundary is between 18 and 16. The front and back of both the range. So 17, 19, 59, 61. All these four have to be checked along with 18 and 60. What about decision table testing? Let's take a discount system. If a customer is a member and if the customer buys greater than 1000 rupees, then we have to provide 10% discount. If the customer is not a member, then we need not provide discount. They said a number of combinations of actions are tested under varying set of conditions. So basically we have to take, if the person is a member and the purchase is greater than 1000, we go with 10% discount. If the person is a member and the purchase is below 1000 rupees, we are giving 0% discount. When the customer is not a member, irrespective of the purchase value, whether it is yes or no, it is 0% discount. Because they have told if they are not a member, then no discount. So combination of actions under varying set of condition is, here we have yes and here we have no. This is member. Under member we have yes, no, and under this not a member we have yes, no. This is for purchase. So when you are a member and when you purchase above 1000 rupees, then the discount is applied. Other than that, in no other scenario, the discount is applied. So this is decision table testing. So these three examples might have given you a good idea on what is equivalence partitioning, boundary value analysis and decision table testing. With this, we are completing Unit 6 questions. Let's solve Unit 7 data structures and algorithms questions. Consider the following in fixed expression, a plus b into d, the exponent operator, then we have a subtraction operation. The equivalent postfix expression of q is, a postfix expression is a notation in which every operator will follow all of its operands. Say for example, when you have a plus b, the operator will be following the operands together. This is how we will be changing infix to postfix. So let's take the expression as it is. We have left hand side operator, right hand side. So this is LHS operand, this is RHS operand and the operator. You have to take this completely to be an operand and this completely to be an operand. Overall, if you take this to be X and this to be Y, this will be changing as XY operator. So whatever you change within X and within Y, everything will be followed by this particular exponent operator in the final place. You have to keep that in mind. Now we will work with the inner expression in the left hand side part. In the left operand we have a plus b inside the bracket here. So this will be converted as ab plus. Now this ab plus will be with the multiplication operation. Now this is one operand and this is one operand. You have to bring the operands to one side and then the operator outside. So this will be AB plus left side operand, then the right side operand will be D, then the operator star will be followed. So this is left side operand for the exponent operator now. What about E minus F? E minus F can be taken as EF minus. So this will be the right side operand. Now this operand together will be taken and then the operator will come outside. So A, B plus D star, we have EF minus, then the operator. This will be the postfix expression of the given infix expression. Now we will see which option is right here. We have A, B plus, this is fine in all the 4 options. Then we have D star. D star is not available in 3, so we will rule out 3. After D star we have EF minus. EF minus is available only in this particular option. So we are going with option number 4 as the right answer. This is only one single operation. When you take the whole parenthesis to be the left side operand and the whole parenthesis to be right side operand. If this is going to be the case, the exponent operator should come out. So in order to bring this particular operator out, you have to maintain the left side separately and the right side separately. That's why I kept the brackets as it is while converting it to postfix. We need not keep the brackets, it is not mandatory, but just to make you understand why this exponent operator is coming in the last place, I have maintained this brackets. Next question, the tight asymptotic bound for the recurrence T of n is equal to 2 into T n by 4 plus square root of n is. This expression can also be written as T of n is equal to 2 into T n by 4 plus what is square roots, other way of representing in the form of power, n to the power 1 by 2. So I am changing this as n to the power 1 by 2. This can be written in this way also. Tight asymptotic bound is what they mean by this particular symbol. Now we will see the Master's theorem. So whenever I discuss Master's theorem related question, I will always give you 2 kinds of references, because with any reference you should be able to find the answer. All you need to understand is how to interpret particular T of n function based on the Master's theorem relation. Now we will take this particular theorem, A into f of n by b. So from this we can take A is equal to 2 and B is equal to 4. We have C into n power d. So the C can be taken as 1 and n power d means d will be taken as 1 by 2. So from this we can take the values A is equal to 2, B is equal to 4 and D is equal to 1 by 2. They are asking for the tight asymptotic bound, but here everything is in the form of big O. We have to find B power D. What is B power D? 4 power 1 by 2. What is 4 power 1 by 2? It is square root of 4. What is square root of 4? It is 2. B power D will be 2. This will be equivalent to this condition. So A is also 2, B power D is also 2. Now we have to bring it in the form of n power d log n. They have given in the form of big O, but just we will work only with this. What is n power d? N power d is n power 1 by 2. The log n will stay as it is. We will mention n power 1 by 2 as a root n and then this log n will follow. Root n into log n is found in option number 3. Even with this Master's theorem, you will be able to get the answer. But instead of big O, here tight asymptotic bound is mentioned. So now we will work with T of n. So here we have the format T of n is equal to A into T of n by b plus f of n. We have A is equal to 2 and B is equal to 4. No change. For f of n, they have mentioned as f of n is equal to n to the power 1 by 2, which is nothing but square root of n. You can take the keyword tight asymptotic bound, which is the second option. We have to first compute n power log a to the base b. So let's take log a to the base b. What is the value of a? It is 2. What is the value of b? It is 4. We know log of 4 to the base 2 is 2. How do we find this? 2 power 2 is equal to 4. So this value is taken here. Now we have to use the same format. 4 power what will give you 2 here? 4 power 1 by 2 will give you 2. So the answer for log 2 to the base 4 will be 1 by 2. Log a to the base b will be 1 by 2. So we can take f of n as n power 1 by 2. It is getting equated to the second one. So we will pick this t of n here. This is equal to the tight asymptotic bound symbol is given, the theta symbol. We have n power log a to the base b, then log n. What is log a to the base b? It is 1 by 2. So theta of n power 1 by 2 log n. This can be taken as theta of root n log n, which is perfectly matching in option number 3. Option 3 will be the right answer. We will rule out the other options. If you go by this way, or if you equate f of n to root n and then go by this way, the answer is the same. Wherever it's possible, I am trying to take answer from both the master's theorem and tell you what's the answer. Next question, the longest common subsequence of the given strings is. What is actually subsequence problem? This is a part of algorithms only. The longest common subsequence between two sequences, this is one sequence and this is one sequence. It is the longest sequence that appears in both in the same order, but not necessarily continuously. Contiguously or continuously. It means the order of the number should be same, but they need not be present continuously is what they say. Say for example, after 2 we have a 3 here. After 2 we have a 3 here. But in between we have a 4, that is not an issue. It need not present continuously. But it is present in the same order. After 2 we have a 3. This is how we have to pick. And the problem here is you have to pick the longest common subsequence. What we will do for this particular problem is we will take the options and we will check whether they are a subsequence of the given sequences. In case if more than one option is going to be the subsequence, we will pick the longest subsequence out of those options. Before getting into the working, where is this topic actually getting in algorithms, in dynamic programming? Brute force would mean checking all subsequences which is exponential in time. So we are bringing the dynamic approach here. This will help us store intermediate results and avoid redundant work. Say for example, when you work for 2, 3 and 2, 3 here, you know it is a subsequence. You can store this sequence here. But in brute force, you have to keep checking all subsequences from first. Brute force will go in all tree format. Hope you remember. Dynamic programming is where you can subdivide the problem and work with the small chunks. You can store the small chunks as intermediate results, and based on the results, instead of doing it again and again, the redundant work, you can apply those results and get the solution is what dynamic programming will do. Since we don't have much time in examination, I have to tell you how to deal this in examination rather than using dynamic programming approach. Maybe in some other question paper, if they ask you to solve in dynamic programming approach, at that time we will pick up that algorithm. Right now we will know this for learning purpose, and now we will get into the solving part. Let's take the sequence 1 2 3 2 4 1 2 2 4 3 1 2 1. So they have told 2 1 2 3 as the first option. Let's pick up 2 first. After 2 we have 1 and after 1 we have 2. Do we have 3 here? No. The sequence is ending with 2 1 2. Now we will check the same sequence here. We have 2 here. We have 1 here. After 1 we have 2 here. 2 1 2 is possible, but 3 is missing. So we can rule out option 1. I am just making direct check with the options instead of working through the problem. So this is the first option. What about the second option? We have 1 3 2 1 as the sequence. We have 1 3 2 is present here, 1. We need not worry about the continuity. We need to follow the same order alone. After 1 3 should be there, after 3 2 should be there, after 2 1 should be there. You cannot shuffle as 1 2 3 1 and all. So this is 1 3 2 1. This order is preserved here. So this one is having, we have to check for here. You don't have 1 here. The series is starting with 2 and 1 is starting only here. If you have to start with 1, you have to start only from here. So either start from 1, or if you take 3, 2, 1, only 3, 2, 1 is possible. The first one doesn't appear. So in either way, the second sequence doesn't have this particular subsequence. We are ruling out option 2. Now we will take option 3. We have 2, 3, 2, 1. We have 2, 3, 2, 1. So this one is here. We have 2, 3, 2, 1. So 3 is definitely a subsequence. We will hold 3 as the answer. Now we will go for the fourth option, because if the fourth option is also going to be a subsequence, then we have to choose the longest one. That's why I am not marking 3 directly. Now we will get into the fourth option. We need 2, 3, 1, 2, 1. This is 2, 3, 1, 2. The last one is not there. So we go for 2, 3, 1, 2 here. It is not supporting. So here we will mark no. And now we will go 2, 3, 1, 2, 1. 2, 3, 1, 2, 1 is present in the proper order as given in option 4. But it is not present in the first sequence. So option 4 also doesn't have the sequence. So the only option that has the subsequence of these two sequences will be option 3. Option number 3, 2, 3, 2, 1 will be the right answer. In case, say for example, if 3 is also going to have the subsequence and 4 is also going to have the subsequence, you have to pick the longest common subsequence as the right answer. Next question. Maintaining a graph in memory by means of its adjacency matrix is known as complete representation, linked representation, circular representation, sequential representation. Do we have any term like complete representation? We have never used, so we will rule out. Do we have something called circular representation? We have circular cues but not representation. So this is also not relevant to graph storage. We can rule out even 3. Now we will learn about linked representation and sequential representation. When a graph is stored using an adjacency matrix, it uses a 2D array, otherwise we call it as matrix, to represent connections between nodes. Say for example, when we say A, B, C, when there is from A to B, we will have 1. And if the edge is going to have a weight of 3, in the place of 1, we will be marking 3, which is the weight of A to B. When it is unidirectional graph, B to A will also have the same path. But when it is a directed graph, only path A to B will have. In case if B to A is going to have 1, B to A will have an entry of 1 when it is directed graph. So this is adjacency matrix. This method is actually sequential because it uses a fixed size index based structure like arrays. So how it will be stored is in the form of row column. So if you take this to be the array matrix ith row jth column is what they say. Ith row is A and jth column is B. So A to B will have the value of 3, which can be represented as matrix of A, B. The ith row and the jth column is equal to 3 as per the example that is given here. Each cell matrix I of j indicates whether there is an edge between vertex I and vertex j. So in this case they say it's about marking 0 or 1. 1 means there is an edge, 0 means there is no edge. The matrix can be like ABC, it will be 0, 1, 0. This is the way we will be representing AB edge. So this method is actually sequential when we use adjacency matrix because you will be storing it in the form of array only. Maintaining a graph in memory by means of adjacency matrix. When matrix is involved, it is known as sequential representation, which is option number 4. Option 4 will be the right answer. This is the adjacency matrix of the undirected graph. From A to B we have an edge. So A to B entry we have an edge. So since this is undirected, B to A will also have an edge. BC will have and CB will have. AD, BD. So from A to D, from B to D. Similarly from D to A and D to B. Then from C we have an edge to E. Then from E we are marking C. Between E and D we have, so D to E and E to D. So this is how we will be representing using adjacency matrix. This is sequential representation in the form of adjacency matrix. Now we will see about linked representation for learning purpose. This refers to adjacency list where each vertex points to a linked list of its neighbors. Say for example, from A we have an edge to B and D. So from A we will have a linked list to B that is pointing to D, and then we have a null pointer here stating that A has only two edges. B has edges to A, D, C. So this is A, D, C. C has edges for B and E. So it's B and E. D has for A, B and E, A, B, E. E has for C and D. So here they have given us D and C. So adjacency list is linked list representation and adjacency matrix is sequential representation, which is nothing but array format, that is 2D array. Next time when the question is going to be about adjacency list, you should know the answer is linked representation. We will rule out option 2 for this particular question. Next question, the correct sequence of constructing Huffman tree is. The Huffman tree concept is actually coming from the previous year question paper. So this time I thought we can have an idea about how Huffman tree is going to be constructed. Now let's see what's Huffman tree. It's a binary tree used for lossless data compression. Actually the usage is in Unit 9 data communication networks. This is based on greedy algorithm principles. Every time whatever you feel as the best option, you are choosing that and moving towards the goal. This is what you have to have in mind for greedy. Now what are the sequence of steps? First we have to create leaf nodes. Each character or symbol becomes a leaf node with its frequency. So a set of nodes will be given with a frequency, with a value. You have to create leaf nodes for them. Then go for building a priority queue. So leaf nodes is B, priority queue is C. What is building a priority queue? Inserting all leaf nodes into a minimum heap or priority queue based on frequency. Combine lowest frequency nodes. The purpose of inserting the leaf nodes into min heap or priority queue is to combine the lowest frequency nodes. This is option D. Repeatedly remove the two nodes with the lowest frequencies, combine them into a new node and reinsert. I will show you how this is done, but before that we will complete this question. Repeat until root formed. Until you make it to a single node, you have to keep repeating this procedure again and again. This is option A. Continue combining until only one node remains. This becomes the root of the Huffman tree. B, C, D, A is available in option number 3. Option 3 will be the right answer. So let's take an example. We have 6 nodes. This is a very popularly available example in so many articles, in so many websites and even in some books. So I am using the same example. A node with frequency 5, B with 9, C with 12, D with 13, E with 16 and F with 45. Initially what we have to do? We have to create leaf nodes. So let's take every node to be a leaf node as of now. We have to build a priority queue. So based on priority queue, we are arranging it as per the frequencies. I have just arranged it in order 5, 9, 12, 13, 16, 45. Now the actual procedure starts. We have to combine lowest frequency nodes. Now we will combine the lowest frequency nodes and then try to form the root little by little. So what are the first two nodes that can be combined? It's A and B. So this is A node with frequency 5 and B node with frequency 9. And this X is nothing but the null pointer. Since this is a leaf node, you don't have left child as well as right child. So I have mentioned it in this way. When you combine them, 5 plus 9 will give you 14. We have to repeatedly remove two nodes with the lowest frequencies, combine them into a new node. Now this node can be taken in this way. We have 14 left child and right child. When it is an intermediate node or an internal node, I just used oval shape. Now we have node 14. Still we have two more nodes that are lower than this 14. So we will bring C and D separately. Now we will combine these two lowest frequency nodes. What is 12 plus 13? It is 25. Now we have 14 as an internal node. We have done with C and D. This is 25. So whenever you place such nodes in binary tree, the left will be lesser value and the right will be greater value. So since 12 and 13 both are lower than 14, we are combining them together. Now just take the case of 16 and 14. Which one is lower? 14 is lower. So let's retain this in left side and we will introduce the right side node E here. So this is the leaf node E with frequency 16. What is 14 plus 16? This is the right side. We have 30. Now compared to the left side, right side is greater with the value 30. But just see, F is having 45 which is far higher than 25 and 30. So we will combine 25 and 30. 25 plus 30 will give you 55. This is left side and this is right side. Now we have a value of 55 in the internal node part. F is 45. So making 55 as the right side, we will introduce F in the left side. So F along with 45 frequency is given as the left node here. So now we have left as 45, right as 55. We have to repeat this until root is formed. We will now find the root of this particular tree. 45 plus 55 will give a value of 100 and this will be the root of the Huffman tree. This is how we will be constructing Huffman tree. Maybe when this diagram hits your mind, the retention capacity of this procedure will stay for a longer time. This is about constructing Huffman tree. They said it is used for lossless data compression. How are we going to use this Huffman tree? We will have binary paths 0 for left and 1 for right used to generate Huffman codes. So when it is left we use 0, when it is right we have 1. So 0, 1, 0, 1, 0, 1, 0, 1. How will we represent F here? The character F is represented by code 0. How do we get C? We have to travel 1, 0, 0. This will be the code for C. What about D? 1, 0, 1 will be for D. For A, we will have 1, 1, 0, 0. So 1, 1, 0, 0. For B, it is 1, 1, 0, 1. Then for E, we have 1, 1, 1. This is how we will be generating Huffman codes after constructing the Huffman tree. Next question. When developing a dynamic programming algorithm, the sequence of steps followed is: dynamic programming is a method used to solve problems by breaking them down into overlapping subproblems and solving each subproblem only once, storing the results for reuse. This is what I have been telling you in longest common subsequence problem. Now we will go for the steps. What is the first step? Characterize the structure of an optimal solution. C. This will be coming first. Let me mark it here for clarity. We have to understand how the problem can be broken into smaller parts. Identify the recursive relationship between the problem and its subproblems. So we have to first break the problem into subproblem. That is what they say, characterize the structure of an optimal solution. We have to understand what are the subproblems we need to solve. So this is the first step, C. Option 1 and 2 can be ruled out. The second step is recursively define the value of an optimal solution. Write a recurrence relation for this that expresses the solution in terms of smaller subproblems. B will be the next step. The third step will be compute the value of an optimal solution, typically in a bottom-up fashion. When you keep dividing it to chunks, you have to travel solving this in bottom-up fashion. That's what they say. Compute the value typically in a bottom-up fashion. Use a table or array to store result of subproblems because you need to reuse them. This will be the next step. The final step will be construct an optimal solution from computed information. We are computing here and storing it in a table, and we are using the computed information in the next step. A will be the final step. Once the table is filled, trace back through it to reconstruct the actual solution. From these 4 steps, compute the value and construct from computed information can be a clue. It means D step will be followed by A. DA is a clue here. The only option that has DA here will be option number 4. From this itself, we can rule out the other 3 options and conclude that option number 4 will be the right answer. This is also dynamic programming strategy. If we pick DA, we are picking the optimal solution based on DA subsequence. The same strategy you have to apply in examination hall, provided you are sure about DA sequence. Next question. Which of the following algorithms use greedy strategy? Just in the same video, we came across Huffman tree construction algorithm where we said it follows greedy strategy. So we definitely know C is in the answer. So any option that does not involve C can be taken out. In the examination, you might have not had the idea about Huffman tree. At least in this video, you would have crossed that question before coming to this question. So after getting a learning, try to apply that learning in the same video itself. So now we have to find whether it is A, B, C or only C and D. So what about greedy strategy? You have to choose what is best in that particular moment. Let's take Dijikra's algorithm. This algorithm finds the shortest path in a graph with non-negative weights. So how is the greedy strategy applied here? It always selects the node with the smallest tentative distance. Once a node's shortest path is determined, it's never revisited. If you take a graph and if it finds that this is going to be the smallest distance from that moment, that will be the best decision and the optimal decision for that particular node. So it will fix that that is the shortest path. It will never revisit is what they say. So the greedy strategy is applied in this way. So definitely A is there in the solution. What about Kruskal's algorithm? This algorithm is used to find the minimum spanning tree. How is the greedy strategy applied? It always picks the edge with the smallest weight that doesn't form a cycle. We are picking an edge with the smallest weight. At the same time, that edge should not form a cycle in the minimum spanning tree that we are constructing. So this will build the minimum spanning tree edge by edge, choosing the best local option. At that moment, whichever edge is small as well as whichever edge does not form a cycle will be picked up. So this is greedy strategy applied in Kruskal's algorithm. Definitely this is also in the answer. So we have option number 2, A, B and C only as the right answer. Now we will learn about Huffman coding. This is for lossless data compression. The greedy strategy here is it will combine the 2 least frequency symbols at each step. This minimizes the total weighted path length in the binary tree. So the greedy strategy applied here is combining the 2 least frequency symbols. When you went from A to F in Huffman tree construction, A, B had the least frequency. So you picked them. After combining them into an internal node, we picked the C and D which had 12 and 13. This is what they mean by greedy strategy. Now we will understand which strategy does Bellman-Ford algorithm use. Bellman-Ford algorithm is used to find the shortest path from a single source vertex to all other vertices. This is not using greedy approach. Then what does it use? It uses dynamic programming. It relaxes all edges repeatedly and can handle negative weights. Systematically improves estimates of shortest paths. Say for example, if we have A here, B, C, D here, then from here we have E and F. If you have A, B, F as a root, A, D, F as a root. If you have already calculated from A to B and if you have already calculated for A to D, you will use the already computed information along with this particular weight to find which is short for F. From A to F, AB plus BF, AD plus DF. which one is shorter, that will be applied here. So when you are going to use AB and AD value, it is already computed information which comes under the category of sub-problems. So this applies the concept of dynamic programming. I hope you are clear why D is not using greedy strategy. Next question. Which of the following trees are height balanced? Actually, from the options we definitely know AVL tree is height balanced tree. So we will see the options one by one. Let's start with binary search tree. Binary search tree does not guarantee balance. In the worst case, example, inserting the sorted data, it becomes a linked list with height n. So it is not height balanced by design is what they say. So definitely binary search tree will not be a part of the answer. Let's take AVL tree. As per our knowledge from the previous year question paper, definitely AVL tree is height balanced. So this is strictly height balanced. AVL trees maintain a balance factor of -1, 0 or +1 at every node. Rotations are performed during insertions and deletions to keep the tree balanced. This guarantees big O of log and height, which is ideal for fast lookups. Lookups means for search. So definitely B is in the answer. What about red-black tree? This is actually called loosely height balanced. So AVL is strict and this one is loose. Ensures that the longest path is no more than twice the shortest path. Uses coloring and rotations to maintain balance. So the balancing aspect is there. This also guarantees big O of log and height, though less strict than AVL. So even C is in the answer. What about B tree? B tree is a balanced multi-way search tree. It is used in databases and file systems. All leaf nodes are at the same depth, ensuring balance. Internal nodes can have multiple children, keeping height logarithmic even with massive data. This is also height balanced tree only. So D is also included. Since the options don't have B, C, D together, in the official answer key, they have declared two of the options as the answer. A is available in option 1 and 2, so they have removed this. Since we have B and C in option 4, it is considered as the answer. And since D is available along with C, even option 3 is considered as the answer. So option 3 and 4 are correct for this question, which says that B, C, D are right. A is alone wrong. Except binary search tree, all the other trees are height balanced trees. Next question, match list 1 with list 2. In list 1 we have circular queue, priority queue, double-ended queue, simple queue, and an application of the queue is given in list 2. So let's start seeing one by one. Circular queues are ideal for round-robin scheduling where processes are cycled through repeatedly. If you have went through Unit 5, System, Software and Operating System questions in round-robin scheduling, you would have seen the circular order of the processes. In the same June 2025 session question paper solution video I am telling. So here A will be mapping to CPU scheduling considering this round robin strategy. A is mapping to 2. A2 is available in 2 of the options. What about priority queue? Dijkstra's algorithm selects the node with the lowest cost making use of a priority queue. So already in one of the previous year question papers we learnt about this point. Dijkstra's algorithm uses priority queue. B will be mapping to 3. B3 is also available in 2 options. What about double-ended queue? When you have no idea about what its application is, just see list 2. You have something called palindrome. What is palindrome? You will have a string. Whatever comes from the first, it will be coming from the last 2. Here you can see this as an application of double-ended queue. Palindromes require checking characters from both the ends, which a DQ supports efficiently. C will be mapping to 4. If you are sure that DQs are for palindrome checking, without looking at other options, you can mark option number 2 as the right answer. Now let's see about simple queue. A print queue follows first in first out order, perfectly modeled by a simple queue. What is a queue system? First in first out. Whoever comes first will be getting out first. Even in print options, when you keep giving prints, whichever document is given print first, that will be printed first. So in that case, D will be mapping to 1. D1 is also available only in one option. Next question, match list 1 with list 2. List 1 has hash collision handling method and the strategy, that is how they are done, is given in list 2. Chaining, linear probing, quadratic probing and double hashing. Let's start with chaining. What is chaining? Actually, you will have a linked list attached to a particular slot. If the hash table is in this way, you will have a linked list attached like this. Each slot in the hash table holds a linked list of all elements that hash to it. A will be mapping to 3 linked list at index. A3 is available only in one option. Next is linear probing. If a collision occurs, check the next slot sequentially until an empty one is found. We have solved many questions in the previous year question paper using linear probing. You can map linear probing to check next slot. B will be mapping to 1. B1 is also available only in one option. Next we will go for quadratic probing. Probes will actually follow a quadratic pattern to reduce clustering. So here we will go with skip slots using quadratic step. So when you take this 2 square, 3 square and all, you may have to skip slots. So C will be mapping to 4. What about double hashing? From the name itself you can understand you are going to use 2 hash functions. A second hash function determines the step size for probing, minimizing clustering. So this is using second hash function. D will be mapping to 2. D2 is available only in one place. Option number 3, A3, B1, C4, D2 will be the right answer. With this we are completing Unit 7 questions. Let's discuss Unit 8 Theory of Computation and Compilers questions. Consider the following DFA that generates set of strings over the input alphabets A, B, C. Now identify that which of the following is the best description of the language for the above DFA. There are two approaches to this question. First approach is you have to trace the particular DFA and then find what is the string. The other approach is to test whether any of the 4 options are working for this DFA. The time saving process will be the second one. So first let's start with the first option. The language description will be L is equal to A star plus B star plus C star. This star denotes its clean closure, which means it can either have the occurrence of that particular alphabet or not. It means the occurrence of the alphabet can be 0 also. What is this plus symbol outside the bracket? This will state that at least one of the string is going to be present, which says that empty strings cannot be processed in this particular language. It does not support empty string. Let's take ABC. From the DFA we can understand that Q0 is the initial state based on the symbol arrow mark, and Q0 will be the final state too based on the double circle that it has. How shall we find that ABC is being accepted by this particular DFA or not? We have to start from Q0, go through ABC and check whether it is ending at Q0 again. So let's trace it. From Q0 we have A transition to Q1. So this is A. From Q1 for B we have Q2. So this is B. And from Q2 we have to go to Q3 for the input C. Is this string ending up in final state? No. ABC is not the only string that is being generated by option 1. It is just one of the strings. When one of the string is being rejected by the DFA, it means this language is not the language of the above DFA. We can rule out option 1. Now let's take option 2. Language is equal to A plus B plus C, clean closure. Then we have A, B, C with the plus symbol here, and then A plus B plus C, clean closure. This can have 0 occurrence, this can have 0 occurrence, but this must have at least one occurrence, which states that the minimum string that can be generated will be ABC. We have already found that ABC will be rejected by this particular DFA. So now we can rule out even option 2. This is the reason I took ABC for option 1 also. So let me give the transition for this ABC. From Q0 you are going to Q1, from Q1 you are going to Q2, and from Q2 you are going to Q3 for A, B and C input. Q3 is not a final state. So this string is rejected by the DFA given above. Now let's go to the third option. Language description is set of strings all starting with ABC but ending with C. Q0 to Q0 has C transition and Q5 to Q0 has C transition here. If a string has to end by C, the previous state should be Q0 or Q5. Then again when you have Q1 here, Q1 is also having Q0 transition with input C. So the C possibilities are only 3. The minimum string is ABC then C, because ABC we know it is not going to be accepted. But here they are saying it is starting with ABC and ending with just C. So far we have travelled till Q3 for ABC. From Q3 what is C transition? We are again standing in Q3. Q3 to Q3 is a self loop for C. This is also not a final state, which states that this string will also be rejected by the automata. We can take another string here, ABC, then we will have ABC, then a C again here. So ABC we have come here, we have A, we have B, we have C, then C. This string is getting accepted, but this string should also get accepted. When we say this is the language of DFA, all the strings should be accepted. When one string is accepted and one string is not accepted, that is not the language of the DFA. So taking A, B, C, C or only ABC into consideration, we can tell that third one is also not the right answer. Now let's check for last one. Set of strings all having even count of substring ABC. It means you can have ABC, ABC, then ABC, 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 ABC. These are all even counts. This is 2, this is count 4. What about including 0? When the count is 0, we can say empty string is also accepted. Since the initial state is given as the final state, this declares that empty string is also accepted by this particular DFA. If the start state of a DFA is also a final accepting state, then the DFA accepts the empty string, which states that including 0 is fine for now. Now let's check for double ABC count here. A, B, C, then again we will go for A, we will go for B, then we will go for C. So this is even count, this is getting fine. Now we will check for 4 times of ABC. So once we reach Q0 for 2 times of ABC, again we can go ABC and come back to Q0 again. So even count is accepted here along with 0 count is what they say. So this is the best description of the language for above DFA. Set of strings all having even count including 0 of substring A, B, C. Let's take B, ABC, ABC, B. So it starts with B, Q0 with input B will stay in Q0. You traverse for 2 times of ABC. From Q0 again if you have input B, it is staying in Q0, which is final. So substring ABC means you can have anything in the front and in the back. Whatever is occurring here, this particular ABC pattern should be in even count. So option number 4 will be the right answer for this particular question. Next question, consider the following DFA. Which of the following NFA is valid for the given DFA? The initial state will be Q0. What about the final states? We have 4 final states, Q2, Q3, Q4, Q5. One way to work with this problem is to set a set of strings from the given DFA. Check whether all the strings are getting processed by the NFA in the options. This is a very time consuming process. There is another way. We have to pick one such string that works for DFA but not for NFA, that is given in the option, or pick one string that is accepted by the NFA and not accepted by the DFA. It means if this automata accepts a string, it should be accepted by the NFA given below. If an NFA given in the option accepts a particular string, that string should not be rejected by this DFA. Both should accept the string is what I am trying to say. But you can either prove it in this way or this way. Both are right. We will work it out in both the ways for this particular problem. So first take the strings in DFA. Let's take the string AAB. In DFA, from Q0 to Q1 we have A. From Q1 to Q2 we have another A. From Q2 to Q3 we have B. Q3 is an accepting state, so this is a valid string in DFA. Now what we will do is, we check whether we are able to get it in 1, 2, 3 and 4. We will start with Q0. We have A. This A can be taken under self loop, another A and then B. It is ending up in final state, so it is accepting. What about option 2? We have A, B. This is also fine. Coming to option 3, here only one state is final state. The remaining states are not final state. So let's check A, B. It is not ending in a final state, which says that this particular NFA can be removed from the answer list. So we will remove this. Let's check for option 4. A, B is there. This is one way to process. We are taking DFA accepting string and checking with the NFAs given in the 4 option. Now we will work it the other way. We will take a string, and that string, if it is accepted by DFA, then that is the valid NFA. If that is not accepted by the DFA, we can just rule out the option. We will go for A, B, C, AC. Let's check whether it is first available. We have A, B, C, A, C. It is ending in a final state. Regarding option 2, we have A, B, C in loop here, then A, then C. This is also getting accepted in second NFA. Now check whether this string ABC, AC is accepting in DFA. We have A, then we have B, then we have C. We are still in Q3 state. So from Q0 to Q1 we have A, from Q1 to Q3 we have B, from Q3 we have self loop, which is C. After C we are processing A. It is moving to Q5. From Q5 we have to search for C transition, but in Q5 we don't have C transition. If there is no C transition, it means this string is not accepted in the DFA. Using this string, we are actually neglecting the options 1 and 2. 1 and 2 are accepting a string that is not accepted by the DFA. Now let's check for option 4. Here we have A, here we have B, here we have C. ABC is there. From Q2 we are having A transition. We are in Q3. From Q3 you don't have any C transition. From Q0 to Q1 we have A, Q1 to Q2 we have B, Q2 to Q2 we have C. For A, one way we went to Q3. From Q3 there is no transition. So this automata is not accepting. We will go the other way. A, B, C. From Q2 we are moving to Q0. From Q0 do we have any C transition? No. Option 4 is not accepting the string that is not being accepted by DFA. So DFA and option 4 are rejecting the same string, but that string is being accepted by 1 and 2. By taking this into consideration, we will even remove 1 and 2 from the answer list. So which automata is valid for the given DFA? Option number 4. We got a string from the DFA and then checked in NFA. One of the NFA failed. Now we got a string and checked in 2 of the NFAs. It worked, but it got rejected by the DFA. The same string got rejected by another NFA also. For all these 3 strings, the DFA and option 4 automata are working in the same way. They are accepting the same strings and they are rejecting the same strings. In that case, we conclude that the NFA in option 4 is valid for the given DFA. So the only challenge regarding this question in exam point of view is to find the right string. I hope you get the essence of focus during examination. Apart from the usual tension that you have in exam, if you have other stuff running in your mind, these questions will take a lot of time and eventually end up with the wrong answer. And there are complaints that sometimes the DFA is not clear, you have to scroll and then find it out. If that is the difficulty, that is not in our hands. If you don't have focus, you will not find this string or this string so easily. Since I had the answer key in my hand, I know DFA and option 4 will work the same way. But in examination, you don't know which of the option will work the same way. So you have to test every string in every option to check whether they are equal or not. Next question. Arrange the following parsers in increasing order of their power of handling grammars. That is from the least powerful parser to the most powerful parser. Out of these 5 options, one parser is top-down parsers while the others are bottom-up parsers. We will start with the least powerful one, LL of 0. 0 means there is no look ahead. It cannot handle left recursion or ambiguity, and this is top-down parser. So the least powerful will be LL of 0. 2 of the options are starting with LL of 0. So we will rule out the other 2. After LL of 0, we have LR of 0. Again there is no look ahead. Many grammars cause shift-reduce conflicts. So compared to LL, LR is better. But again LR has some problems. So the next order will be LR of 0. This is there in both the option. After LR of 0, we have SLR. This uses follow sets to reduce ambiguity and it is stronger than LR of 0. So the next order will be SLR and it is available in both the option. After SLR, we have LALR. Nearly as powerful as LR of 1. So both are almost equal in power, but it is working with smaller tables. In this case, we are considering LALR to be less powerful than LR with look ahead 1. So here LALR will be coming first. So we will rule out option 1 also. After LALR of 1, we have LR of 1 full look ahead. This handles widest class of grammars. So they are asking the power of handling grammars from least to most. So this is the most powerful parser and we are ending up with LR of 1. Option number 3 will be the right answer. The question might be in increasing order or decreasing order. Read the question properly and then answer. Next question. Which of the following grammars are only context free? A context free grammar is a formal grammar where every production is of the form A produces alpha, where A is a single non-terminal like capital S, capital A, capital B, and alpha is a string of terminals and or non-terminals including epsilon. So let's start with A grammar. This actually violates CFG rules. This has a terminal on the left hand side. That's why we are ruling out A grammar from the answer list. So we can remove option 1 and 4 which has A in the answer. What about B grammar? We have S derives capital A, B. This is fine. And A derives capital SA. This particular rule introduces indirect left recursion through S derives non-terminal A and terminal B. This will create a cyclic dependency between non-terminals S and A, which will lead to ambiguity in derivations. This grammar is actually allowing context sensitive behavior. The derivation of A depends on the context of S, which violates the independence required in context-free grammars. So we are even ruling out B. What about C? S derives AS, S derives A derives A. At any stage, check whether it will be ending with the terminal. Yes, it will end. So C is a context-free grammar. What about D? S derives capital A and terminal B. S derives terminal A and non-terminal A derives A. This is also fine. What about E? S derives SB and A derives A derives epsilon. Actually, A is not reachable from the start symbol. This is one problem. Another problem is the only production that is available here is S derives SB. Again and again it will be deriving in this way. This S will not eventually lead to a terminal. So we say this grammar is not context free. S non-terminal does not end with a terminal. It means they are not talking about this B terminal. Ultimately this non-terminal should end up with a terminal. Say for example here we have capital A and S. This S is somewhere ending with this particular terminal and this non-terminal is ending with a terminal finally. We have the possibility of getting terminals from S in both C and D. But here, how much ever derivations we go, it will still have capital S and B only. This capital S will never end with a terminal because there is no non-terminal that is being given in other production. This is one problem. The second problem is A production is not reachable from S. S never uses capital A in any of its productions. Since A is not reachable, it is effectively useless in the grammar. You are going to work only with S and B and there is no mention of capital A. What is the use of giving these two productions when it is not given in the start symbol? So keeping these 2 points in mind, we are saying E is also not there in the answer list, which is making us rule out option 3. Option number 2, C, D only will be the right answer. Only these two grammars are context-free grammars. Next question, match list 1 with list 2. I think this is a repeated question from previous year question paper. Let's first understand the symbols. Capital V is a set of non-terminal symbols. This summation notation is a set of terminal symbols. Lambda and beta that are used here, they are strings of terminals and or non-terminals. Now let's start with type 3 regular grammar. This is of the form A derives terminal non-terminal or A derives terminal, where capital A and B belong to non-terminal and small a belong to terminal. Non-terminal derives a non-terminal and a terminal or a terminal, which is equating it to this particular format. So A will be mapping to 4. A4 is available only in one option. If you are sure about regular grammar, you can complete this question. Next we will go to type 2 grammar, which is context free. A derives beta. Now just map this. Non-terminal derives a combination of terminal and non-terminal. Otherwise epsilon is what they say by this star symbol. This is actually available in option 1. So B will be mapping to 1 in list 2. This is B1. Then we have type 1 grammar, which is context sensitive. Alpha derives beta. Alpha belongs to union of non-terminal and terminal. Beta belongs to union of terminal and non-terminal. Here it is actually plus symbol and here it is star symbol. And alpha is less than or equal to beta is given here. For the context sensitive behavior, they have even given this particular condition. Now just find a similar expression here, lambda union beta derives lambda with terminal and non-terminal union with this particular closure symbol, and then beta, where lambda belongs to union of terminal and non-terminal and beta belongs to union of terminal and non-terminal. This particular part is actually expanded in this way, so we can map type 1 grammar C to 2 here. C2 is available here. What about type 0 grammar? It is unrestricted grammar. Alpha derives beta, where both are strings of terminals and non-terminals. Just take V union summation star derives V union summation the whole star. This is what is given exactly in option 3 of list 2. So D will be mapping to 3. Option number 3, A4, B1, C2, D3 will be the right answer. Next question. From here we are entering into the comprehension part. 5 questions are based on the given 3 address code sample. Consider the following 3 address code sample for solving the questions. Let's see the code first. T1 is equal to y plus 2, initial is equal to x divided by T1, limit is equal to 10. If I greater than j, go to 105. So if I is greater than j, we have to go to 105. If number is greater than b, go to 107. If this condition is true, we have to go to 107. From this we can understand, if I is greater than j, it has to check another condition, num is greater than b. What about this go to statement? It is the else part of this particular if. And what is this go to statement? The else part of this particular if. From 107 till go to 103. What is 103? It is getting back to the if condition again. This part is actually a loop. It means we are checking for 2 conditions. If so, we are executing from 107 to 110. After finishing 110, we are again going and checking the condition. When you are going for a repeat of executing the same set of statements, it is actually loop. Once the condition fails here, or if the condition fails here, you are getting out of the loop where you are having 2 statements, j is equal to I minus num and k is equal to j plus b. So understand, the loop continues only if I is greater than j. Inside the loop there is also a nested condition, num is greater than b. If that is also true, we are updating the values of num, b and I and then going for checking the condition again. If num is less than or equal to b, the inner nested loop will be getting out. After the loop, we are computing 2 values is what they are trying to tell us through this 3 address code sample. So in intermediate code generation of compiler design, you are having this particular comprehension. Now let's get on to the first question. Which of the following is the correct high level code for the given TAC in the passage? We have to check the 4 options and then see whether the logic is actually retained. Now let's go through option 1. The values are initialized. They have given I greater than j or num greater than b. It executes even if I is less than or equal to j, but when num is greater than b, it means when one of the condition is true, it is going to execute these 3 statements. But the logic is both the conditions should be true, only then you can enter the body of the loop. So here it is violating. This breaks the original loop logic, which requires I greater than j first, then num greater than b inside. So this is breaking the original loop logic. 1 is out of the race. Get into 2. While I greater than j or num greater than b. Here also this is the problem. The loop continues if either condition is true. But in our TAC sample, we have to have both the conditions to be true. So this is the mistake in 2 also. What about 3? If I greater than j, while num greater than b, num is equal to limit minus 1 and they have given these two statements in else part. Actually, this block is wrong. If I is greater than j, they could have given like while num greater than b, you have to put all these three statements inside the body of the loop and then get it out. This is not the else part. This is a part of the loop. So this logic is also not retained here. This reverses the logic. Updates I only if I is less than or equal to j. It means it is on the else part they are saying. The loop on num greater than b is inside I greater than j condition, but it does not update I, so the loop condition never changes. This if part here, it is changing the value of I. In the 3 address code sample they have given. But here, this is working only with num. If you have to update the value of I, it is available only in the else part. What does this mean? This loop condition will never change because we are not going to update I since it is present in the else part. So this is the reason we are ruling out even option 3. From this we know option 4 is right, but we will see how it is right. Here they have placed I greater than j, one condition is fine, and num greater than b along with and, it means both the conditions have to be true. Check for the body of the loop, num is equal to limit minus 1, b is equal to y plus 2, I is equal to I minus num. All these three are fine and these two statements are also fine. What about init value? Instead of saying x by t1, they have substituted the value of t1 here. It is nothing wrong. This is equivalent to x divided by t1 where t1 is equal to y plus 2. So from this we understand that it matches the TAC logic. Loop continues only when both these conditions are true. Inside the loop it updates all the three variables. After the loop we are computing j and k. So all the logic is preserved here. So we are going with option number 4 as the right answer. This is the correct high level code for the given TAC as per these 4 options. Next question. What are the various leading statements for the TAC given in the passage? Leaders are the starting points of basic blocks. We will get into basic blocks in the next question. As of now, we will just find the leaders. A statement is a leader if it is the first statement of the program, it is the target of a jump, it immediately follows a jump instruction. Now we will see step by step. Let's get into rule 1. So this is 1, 2 and 3. The first statement. This is the very first statement of the TAC code. So 100 is always a reader. So 100 is present in all the 4 options. What about rule 2? Targets of jumps. 103 is the target of go to 103. We have go to 105, go to 107 and go to 111. 103, 105, 107, 111. All these are targets of jumps. The targets of jumps are leader. This is rule 2. So 103, 105, 107, 111 is missing. So 1 is ruled out. We have 103, 105, 107, 111. It's fine. We have 103, 105, 107, 111. We have 103, 105, 107, 111. It's fine. So only one option is ruled out as of now. Now the third rule. Statements immediately after jumps. There are 2 if conditions. One in 103 and one in 105. So they are saying jump instruction. We can consider if here. The first if is present in 103. It immediately follows a jump instruction means this part is a leader. It means it is actually the else part of this particular if block. So 104 is a leader here. Then check the other if condition which is at 105. Here we have an if condition and this is like the else part. So we are including 106 also. They have not included 104, 106 here. So we can rule out 2. 104 is missing here. So we will rule out. What about the fourth option? 104 is there, 106 is there. 100, 103, 104, 105, 106, 107 and 111. These are the leaders for the given TSC sample. So we will go with option number 4 as the right answer. Consider only go to here and consider if here. Line 103 is a conditional jump. If I greater than j is false, the program continues to line 104. Similarly, line 105 is a conditional jump. If num is greater than b is going to be false, the execution continues to line 106. That is what I told. It is like the else part. That's why we are including 104 and 106. What is the purpose of identifying leaders? To break code into basic blocks, that is what we are going to do next. Perform local optimization, build control flow graphs, enable data flow analysis. So we will get on to the next question. Which of the following is the correct flow graph for the TSC given in the passage? To determine the correct flow graph, there are 3 steps. Identify the basic blocks using the leaders. So we already have the leaders here. Understand the control flow between those blocks. Match the control flow to the adjacency matrix. That is the flow graph options. Now we have to find the basic blocks. Just mark the leaders 100, 103, 104, 105, 106, 107 and then we have 111. 100 to 102. This is block 1. You have to now recollect the leader statement. Leaders are the starting points of basic blocks. Whenever you have a leader, that will be the starting point of the basic block. So this is one block. 103 is block 2. 104 is block 3. 105 is block 4. 106 is block 5. From 107 till 110 you don't have a leader. So this particular set of 4 statements will be block 6. Again we don't have a leader after 111. So this will be block 7. This is how we will be finding basic blocks from leaders. You just mark the leaders. Every leader will be the starting of a basic block. So if 103 is going to be a leader, the statement preceding it will belong to the previous block. Since we have 103, 4, 5, 6, 7 continuously to be leaders, we are just considering them as separate blocks. After 107 till 111 you don't have any leader. So the line before 111 will belong to the previous block. You have to find the leaders, you have to find the basic blocks. After these two are done, we are going to see the control flow between blocks. From B1, we are moving to B2. There is straight line flow. It means after completing block 1, we are moving to block 2. What about block 2? Block 2 we have if I greater than j. Don't see the line numbers, just see the blocks, otherwise you will get confused. This is block 2. If I greater than j is going to be true, where it will go to 105. What is 105? It is block 4. What happens if this particular condition is going to fail? If this is going to be false, it will go to 104, which is nothing but block 3. So it has two control flow here. B2 to B4 happens if I greater than j is true. B2 to B3 happens if this I greater than j becomes false. So these are all additional explanation that has been given for understanding. Now block 2 is done. After block 2, now we have to start with block 3. From block 3, we have a go to statement to 111. What is 111 actually? It is block 7. So from B3, we are moving to block 7. Don't go with the line numbers, just go with the block numbers. Next block will be block 4. Block 4 is 105. Again we have two options. If it is going to be true and if it's going to be false. If it is going to be true, we are going to 107. 107 is block 6. If it is false, we are moving to the next immediate block, that is block 5. So again there are two control flows. B4 to B6 happens when the condition is true. B4 to B5 happens when the condition is false. These are just explanations to say how this flow is happening. Now we will get into next block B5. From B5 where are we going? We are going to go to statement 111 code line. This is again B7. So B5 is going to B7. This is the next control flow. From B6 where are we going? This is B6 block. From B6 we have a go to statement called go to 103. So from B6 we are going to 103. 103 is which block? Block 2. So B6 is having the flow to B2. B6 means you have to take all together all the 4 statements. This is fine. This is having straight line execution. This is having straight line execution. From B6 actually you should move to B7. But here you have a jump. Go to 103. So from B6 the only option that you have is to move to block 2. What about the final block B7? From B7 there are no outgoing edges. It means this is with respect to the flow graph they are telling, but we are reaching the end of the code. So we are saying B7 to end. It is not going to any other block. So no other block is involved here. B1 is moving to B2. B2 is moving to two other blocks, B3 and B4. B3 is moving to B7. B4 is moving to B5 and B6 based on the conditions true or false status. B5 is moving to B7. B6 is moving to B2. B7 has no movement. It is just moving to the end. Now we will build the flow graph matrix. We have to number the blocks B1 to B7 row wise as well as column wise. So this is nothing but B1, B2, B3, B4, B5, B6, B7. This is the same thing here. So now let's take this particular control flow. I have presented in text form so that it will be clear for you. From B1 to B2 we have an edge, so we are marking 1. Now B2 is having two edges here, to B3 and B4. So from 2 for 3 and 4 we have 1 here. What about B3? It is moving to B7. So we are having 1 in 7th column here. What about B4? B4 is moving to B5 and B6. So we will have 1 in 5 and 6. B5 is moving to B7. So we are having 1. B6 is moving to B2. So we are having 1 under second block. B7 is going towards the end, so there is no entry except the ones fill all the places with zeros. This flow graph is available in option number 1. Option 1 will be the right answer. Now we will see what is wrong with the other 3 options. There are actually 7 blocks, but 2 and 4 are having only 6 blocks. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Seeing the number of blocks itself, we can cancel 2 and 4. What about 3? Instead of 3 and 4, they have given us 4 and 6 here, which is wrong. So the entries are totally wrong. B7 has no 1 entry, but here they have given. So we are ruling out 2, 3 and 4 and sticking to option 1. Understand the steps clearly. Find the leaders and then the basic blocks. This is the first step. After that you have to find the control flow. This is the second step. From there you have to get this particular flow. After that place it in the matrix. That is the third step. So basic blocks using leaders, control flow between blocks and matching it to the adjacency matrix. These are the 3 steps. If you find it difficult when you follow it initially, please go through once or twice to get clear understanding. Next question. What all blocks does block 3 and block 5 dominate in the flow graph for the TAC given in the passage? This question and the previous question lies in the block number. Some people will number the block from 0 to 6. If you are going to do it in that way, the previous question will not be problematic, but this question will be problematic. Some people have numbered the blocks from 0 to 6, and because of that they were not able to get proper answer for this question. So unless it is specified, you always go with the numbering 1 to 7. Regarding the previous question, if this is going to be from 0 to 6 and 0 to 6, still the flow graph will not have any change, because you are going to change these flows accordingly. That will not be a problem. But this question might turn out to be a problem. This is the block and the related statements, and this is the control flow graph or the summary that we have from the previous question. Now we have to find domination. What is this dominates? In a flow graph, block A dominates block B if every path from the entry block to block B must go through block A. Say for example, this is the entry point and this is going to be block B. From here to here, you must always travel through this part. This means that A dominates B. If there are other ways, say for example, you can go with C or you can go with D, then A does not dominate B because it has alternate routes. A block always dominates itself. So from this you can understand block 3 will definitely dominate 3, block 5 will definitely dominate the same block. It will dominate itself. If there is any way to reach another block without passing through it, then it does not dominate that block. As I told you, if it has C or D to B, even without A, if you are able to reach B, then A does not dominate B. Now we will find domination for all the blocks. Let's take block 1. This is going to be the entry block. Only when you start with this particular block, you will be able to enter other blocks. Only from B1, you will be able to move to other blocks. So it is dominating itself and the other blocks. What about B2? If B2 is going to be true, it will move to block 4. If block 4 is true, it can reach block 6. If it is false, it can reach block 5. If block 2's condition is going to be false, it will directly go to block 7. So you can reach all the paths from block 2. So this is dominating itself and the other blocks also. This is block 2's domination. What about block 3? From block 3, what is the only possibility you have? You are going only to block 7. Is there any other way that you can reach block 7? You can reach it from block 5 also. So the only block that B3 is going to dominate will be B3. B4, B5, B6, B7 can be reached without going through B3. So B3 dominates B3. So block 3 is dominating, only 3 is given only in one option. So we have clearly told it will not dominate 4, 5, 6, 7. So 4, 5, 6, 7 entries will be wrong. From this itself we can rule out the other 3 options. Let's take block 4. From block 4 you can move to block 6. This is possible. If it is false, you can move to block 5. So both the possibilities are there, and along with dominating itself, which is B4. So B4, B5, B6 is possible from B4. So B4 dominates 3 blocks. B5 and B6 are only reachable from B4, because from B4 only there are 2 branches to B5 and B6. Similarly, B3 is reachable only from B2. What about block 5? Block 5 is actually 106, which is again a go-to statement. Again, it need not go through block 5, it may go through block 3. You have to consider the possibilities. Since you have told block 5 to be reason for not telling B3 dominates B7, you cannot rule out this. There is a possibility from here itself you can go to B7 without entering block 5. When there is a possibility, it dominates only itself, so only B5 is getting dominated here. This is also being asked in the question. So block 5 will dominate only block 5. So in order to go to block 6, B4 is enough. So 6 will not be there. For 7, there is another possibility from B3. These three options can also be ruled out with block 5's answer. So option number 1, block 3 dominates 3 and block 5 dominates 5 will be the right answer. Now let's check block 6 and block 7. Block 6 does not dominate anything except itself, because from block 6 we are going to block 2. Is there any other way to reach block 2? Yes, from B1 also you can reach block 2. This is not the only way. So B6 will dominate only B6 here. What about block 7? It is reachable from B3 or B5. But from here it is just end of the segment. So it is dominating only B7. I have given you the domination for all the 7 blocks with explanation. For 3 and 5 alone you can take it for this question. For the rest of the blocks you can use it for your learning purpose. Next question and the final question of the comprehension. Which of the following is the optimized version for the given TSC? Usually in optimized version we will be eliminating dead code. There are lots of steps. But before getting into the steps, let's first see what is wrong with the options now. Here there are only 110 line of code, 1 line and here 110. But the reference in the optimized version is still 111, which states that option 1, 2 and 4 are wrong. Without even working out anything, you can say 3 options are wrong. What about option 3? T1 initial limit is fine. What about num is equal to 9? Actually it is coming inside the loop here. So num is equal to limit minus 1. Limit is 10 minus 1. Num value is 9. But it has to be placed inside the loop. But here it is placed outside the loop. This is one problem. And here they have given if I greater than j, go to 105. 105 is having this particular line. 106 is the right path here. They have renumbered everything, but they have retained the same go-to jumps. So this option is also wrong. From this, what you can understand is this question has been dropped in the official answer key. Now for learning purpose, we will just try to find the optimized version. Lines 107 to 110 is actually the loop's body content. You should not change it. The optimized version can be taken in this way. T1 is equal to y plus 2. Initial is equal to x by T1. Limit is equal to 10. Coming to this particular condition, here there is a repeat. If I is greater than j, else you are going. If num is greater than b, else you are going. Here you can find a logic. If num is less than b, we are changing it to a single statement. Instead of saying num greater than b, go to one position, else go to another position, we can change this as if num is less than or equal to b, go to the else position. Otherwise keep executing. So they have used the alternative logic here and here also. We are applying this logic in the optimized version. They say if I is greater than j, you have to go for the next condition. Otherwise, you have to go for this particular statement. Now what I have done here is, if I is less than or equal to j, go to 109 where we have j is equal to I minus num. Else it will move to the next statement automatically. So if true, it will go to 109. If false, it will go to the next statement. If false means the condition I greater than j will be equal to true and it goes to check the next condition. Now see, if num is less than or equal to b, go to 109. So when this condition becomes true, it will again go to 109 line. But when this becomes false, we can understand num greater than b will become true and it will enter the body of the loop. So the body of the loop will be num is equal to limit minus 1. Instead of having b is equal to y plus 2, we can reuse this particular variable t1 as they have done in some of the options here. So instead of b is equal to y plus 2, we are using b is equal to t1, I is equal to I minus num, go to 103. This part will be the body of the loop and it has not changed from the original logic. Only when both the condition become true, both the original condition will become false and get out of the loop. So till then the loop will be executing. Now in 109 we have this particular line and in 110 we have k is equal to j plus b. These lines are not changed. Actually here you can see j plus t1, here you can see I plus b. These are actually not wrong, but the body of the loop is not changed in the high level code. Just take the high level code. The three statements have not changed. The only change that I have done here is to the if condition here. So let me once again tell you, if number is greater than b, we are entering loop body. If number is less than or equal to b, we are getting to j is equal to I minus num. Similarly, when I is greater than j, we are entering to this particular part. Else, we are entering to j is equal to I minus num. Instead of having these many statements, we are just taking like when the condition becomes false here, when I is less than or equal to j, I am just asking it to go outside the loop. I am giving the failing condition here and then coming out of the loop directly. Till then, till I greater than j is going to be true, the body of the loop will be getting executed. Let's take I is equal to 10 and j is equal to 5 for example. So here I am going to check 10 greater than 5. If it is true, it will go to 105. It will check for the next condition. Take num to be 2 and b to be 1. 2 greater than 1. If it is true, it will go to 107. Just check the same logic here. 10 is less than or equal to 5. Is it true? No. If it is not true, it will not go to 109. It will go to the next statement. Now, 2 is less than or equal to 1? No. So, it will not go to 109. It will go to the next statement. In case if the condition fails, when I becomes 4 and j becomes 5 here, what happens? 4 is greater than 5 will be false. It will go to 111. It will come to this particular line. Now here 4 is less than or equal to 5 means it will directly get to 109, which is j is equal to I minus num. The logic is the same, but in optimized version I have just decreased the count of line by 1. That is the only difference done here. We have actually reduced 2 lines here. This is the optimized version for the given TAC. This is done based on the high level code that was given in the first question of the comprehension. But in general, when you want to find the optimized version, you have to find the basic block, build the control flow graph and identify the loop, branch and unreachable code. We have to perform local optimization. Local optimization should be done within each block. Optimize this part, this part, this part, this part separately. Within block, whatever you do will be local optimization. There you can do constant folding, common sub-expression elimination, copy propagation. This is for learning purpose. This is not for the question. Constant folding means limit is given a value of 10 and they have given num is equal to limit minus 1. So instead of having two line of codes here, num is equal to 10 minus 1 which is equal to 9. So we can change this as num is equal to 9 as they have given in one of the optimized version option. This is constant folding. What is common sub-expression elimination? So here instead of having y plus 2 and y plus 2, we are reusing it with t1. What about copy propagation? When they say b is equal to t1, k is equal to j plus b, instead of using this particular b, you can directly make it as j plus t1. This is copy propagation. Just to tell you what are the steps I am using the same code. This is not for the question. The next step is to apply global optimization. This has to be done across blocks. Local is within each block. In across blocks, what are the process? Dead code elimination, loop invariant code motion, strength reduction. What is dead code elimination? The variable initial is not at all used. So you can remove it. B is equal to y plus 2 is redundant. So instead of this, you can replace it either this way or the other way is to go for move computations outside loop. These two values are not going to be changed anyhow means this can be moved outside the loop. It can be calculated only once and it can be reused again and again. So strength reduction is replacing expensive operation with cheaper ones. It is not relevant to this particular code, but usually when there are lots of multiplications, you can make it with successive additions. The last step is simplify control flow. Makes the code easier to analyze and generate. We have to merge blocks with only jumps. Then flatten nested branches wherever possible. So these are the usual steps that we carry out. But regarding this question, this intermediate 3 address code is actually converted to high level code. So based on that only we can make some changes. So I have made changes only to the two conditions that is present here and a change to the b value inside the body of the loop. Other than that, nothing is done. I have given this optimized version based on the first comprehension question, high level code. This is not done in general. If you have to work it out in general, you have to go with constant folding, you have to go with dead code elimination. There are lots of process. But for this particular question, we cannot go so deep because this is just a sample. Initial might be used after 112. Limit might be used after 112 line. See, they have given num greater than b, I greater than j. Where did I come? Where did j come? Where did num come? Where did b come? We don't know. So this is just a sample code. With the sample code, we can do only this much is what I am trying to tell you. With this, we are completing Unit 8 questions. Let's solve Unit 9 Data Communication and Computer Networks questions. In a stop and wait system, the bandwidth of the line is 1 megabits per second and 1 bit takes 30 milliseconds to make a round trip. The bandwidth delay product is. Before getting on to the calculation, let's first understand the context of this question. In stop and wait system, the sender transmits one frame and waits for an acknowledgement before sending the next. So what is bandwidth here? The rate at which data can be transmitted. That is given as 1 megabits per second. And what about the round trip time? The time it takes for a signal to go to the receiver and then back. So this is 30 milliseconds that is taken from the question. So this round trip time and bandwidth parameters are a part of stop and wait system. In that they have asked about bandwidth delay product. What is it? It is the amount of data in bits that can be in flight on the network. It means the transmitted bits but they are not yet acknowledged. Only when you get an acknowledgement, it will be sending the next one. That is stop and wait for an acknowledgement. But here it is transmitted but not yet acknowledged means those bits are in flight. It means it is in movement. It has left the sender but still we don't know whether it reached the receiver or not because the sender has not received any acknowledgement. This is the bandwidth delay product. It is the amount of data that has to be mentioned in bits. That's why the answer is given in bits unit in all the 4 options. Bandwidth delay product can be calculated by multiplying the bandwidth value into round trip time. The given values are bandwidth and round trip time. 1 megabits per second. Since we want the answer in bits, megabits have to be converted to bits first. We know 10 to the power 3 will be 1 kb, then 10 to the power 6 will be 1 MB. 1 Mbps is 1 into 10 to the power 6 bits per second. What about the round trip time? They have given 30 milliseconds. 30 milliseconds can be written as 30 into 10 to the power minus 3 seconds. Now we have to find the bandwidth delay product. What is 10 to the power 6 into 10 to the power minus 3? This will be 10 to the power 6 minus 3, which is equal to 10 to the power 3. So this is what we get here. 1 into 30 will be multiplied and 30 will be retained here. So what is 30 into 10 to the power 3? 10 to the power 3 is nothing but 1000. So 30 into 1000 will give you 30,000 bits. So overall 30,000 bits will be the amount of data that can be in flight on the network. Option number 3, 30,000 bits will be the right answer. Let's take this bandwidth unit now. Bandwidth unit will be bits per second. And what about RTT's unit? It is seconds. So this second and this second will get cancelled and only bits will be retained. Always practice such questions along with the units, only then you will have clarity. If the answer is not stressing any unit, we may just go with the calculation as it is. But since the answer is stressing in bits, we have to make sure the final value should be in bits. Next question, they have given hexadecimal digits. CB84000D001C001C is the content of a UDP header in hexadecimal format. The source port number is, if you would have watched previous year question solution videos, you could have got an idea about IPv4 header. The user datagram packet format is this one. They are talking about UDP header. So we are getting into this particular diagram. This is the header format. We have source port number, destination port number, total length and checksum. When you take into bits, it is 8 into 8, 64 totally. Each hexadecimal digit represents 4 bits. It means 4 plus 4 plus 4 plus 4 will give a total value of 16. It means how many hexadecimal digits are involved to get the source port number? 4 hexadecimal digits are involved from this particular content. The source port number is the first 4 hexadecimal digits, which is CB84 to the base 16, because this is mentioned in hexadecimal format. In hexadecimal representation, 0 to 9 will be as it is. For 10 we have A, 11 we have B, 12 we have C, 13 we have D, 14 we have E and 15 we have F. So here C means it is 12 and B means it is 11. How will we convert this particular hexadecimal to decimal? We have to use 16 power. Say for example, you have to start from 16 power 0, then followed by 16 power 1, then 16 power 2, then 16 power 3. It goes on this way. First we will have 16 power 0, 16 power 1, 16 power 2 and 16 power 3. We will place 4 here, the next digit 8 here, then B here, then C here. Instead of C we will have 12, instead of B we will have 11. 8 into 16 power 1 will be 8 into 16. 4 into 16 power 0 will be 4 into 1. What about 16 power 3? That will give a value of 4096. 16 power 2 will be 256. 12 into 4096 will give a value of 49152. 11 into 256 will give 2816. 16 into 8 will give 128. 4 into 1 will give you 4. If you add all these 4 numbers, you will ultimately get 52,100. It is available in option number 1. So option 1 will be the right answer. Every hexadecimal digit will represent 4 bits, and whatever is given here 0, 16, 31 will be in the form of bits only. So if you have 4 bits for one hexadecimal digit, 4 hexadecimal digit will make up to 16 bits. Next question. The packet sent by a node to the source to inform it of congestion is called. Congestion control refers to techniques and mechanisms that can either prevent congestion before it happens or remove congestion after it has happened. So we are dividing this into two categories. Open loop techniques come under prevention and closed loop techniques come under removal. In open loop congestion control, we have the following policies: retransmission policy, window policy, acknowledgement policy, discarding policy, admission policy. This option belongs to open loop congestion control. And when you take open loop, it is about prevention. Here they say the packet sent by a node to the source to inform it of congestion means congestion has happened. When there is some preventive policy, the congestion should not happen. If that is the case, then there is no need to inform it to the source. So from this itself we can rule out option number 4. Next we will see closed loop congestion control. Under this we have back pressure, choke packet, implicit signaling and explicit signaling. Now let's see about the option. What is this explicit signaling? The node that experiences congestion can explicitly send a signal to the source or destination. Here there is a choice between source or destination, but the question is clearly stating it will be to the source. So definitely it is not explicit signaling. What about back pressure? A congested node stops receiving data from the immediate upstream node or nodes. If this is going to be the node that is congested, it will stop receiving data. What will happen? It will immediately create some back pressure where this node will be informing this node will inform this node, and finally this node will inform the source. Is it directly communicating to the source? No. So back pressure will not directly communicate to the source, which is asked in the question. So it is not back pressure also. What about choke packet? Choke packet is a packet sent by a node to the source to inform it of congestion. This is the exact statement that is asked in the question. Option number 3, choke packet will be the right answer. Here this is the congested node. This node is directly sending a packet to the source without involving other nodes in between as that of back pressure. So this is to give you the difference between choke packet and back pressure so that it will be helpful for you in some other question paper. What about this retransmission policy? We will see only about this because it is given in the option. If the sender feels that a sent packet is lost or corrupted, the packet needs to be retransmitted. Retransmitting the packet thinking that it is lost or corrupted. So regarding the other policies that is present here, implicit signaling, window, acknowledgement, discarding, admission, you can go through the reference book and understand them. For this video, I have just stopped with the options. Next question. Which of the following is not the characteristics of packet switching? We have two kinds of switching, packet switching and circuit switching. First, we will get into packet switching. This is the method to transmit data efficiently and flexibly. Data is divided into packets. Packets can travel independently. It can take its own route. Since it can take any route, there is no dedicated path. Since every packet is going to travel a different route, it is decided based on the router from where it has to travel. It means we have dynamic routing, no static routing. So this dynamic routing is also a characteristic, and because of this there will be efficient bandwidth usage. If the data packet is going to be of very small size, the remaining bandwidth will be wasted. Instead, when the data is divided into packets, all packets can travel in the same time, which will lead to efficient bandwidth usage. Now let's get into the option. Data is broken into packets. Yes, it is true. Each packet may take a different route. Yes, it is true. These 2 points are referred. It requires a dedicated path. No, it does not require. It supports dynamic routing is taken from this point. This is also true. So which is not the characteristic? Option number 3 requires a dedicated path will be the right answer, but it is not the characteristic of packet switching. Now which switching has dedicated path here? It is circuit switching. It's a method of communication where a dedicated physical path is established between the sender and receiver for the entire duration of the conversation. So there will be 3 stages. First, it will be setting up the circuit. The route will be set up, the data will be transferred, and after the data transfer is over, the circuit will be toned down. That's what is given as circuit establishment, the setup phase, data transfer phase, and circuit disconnect phase. That is the tear down phase. So from this question you can take idea about both packet switching as well as circuit switching. Circuit switching might help you in some other question paper. Next question, arrange the steps involved when a user enters a URL in a browser and accesses a website. Imagine you are just going to a browser and you are typing www.somewebsite.com. What happens before you see the website's home page? That's what they ask you. First, the URL will be entered in the browser. So C will happen first. The user types a web address into the browser. Next, you will enter www.example.com. This is the URL. But internally, what is this actually? It's an IP address. So what will happen next is DNS resolution will take place. The browser asks the DNS server to resolve the domain name into an IP address. Every website will be mapped to an IP address. So DNS resolution will be the next step, which is A. It will ask the DNS server for IP address and the IP address is obtained now. The DNS server responds with the IP address of the web server hosting the site. You have got the IP address now, which is D. After that, HTTP request sent will be B here. The browser sends HTTP or HTTPS. This is secured request to the server at that IP address asking for the web page. And once the request is sent, the web page gets displayed, which is E. The server responds with the requested content, which will contain HTML, CSS, JavaScript, some kinds of images, everything, and the browser renders the web page for the user. What is rendering? It is actually using all these technology, it is actually displaying the web page to the user. It is not displaying just text. It is displaying the text in the given format along with the styling option, along with some scripting and images or any other videos that it has. So the process of doing everything together and presenting it to the user is what we call as rendering the web page. What is the order here? C, A, D, B, E. Option number 4 will be the right answer. Next question. Arrange the process of virtualization in cloud environments. Forget about cloud environments. Just take your own system. Say for example, you are running Windows OS in your system. Most of us will run the same OS. Only few of us have tried Linux. In this Windows system, you will install something called hypervisor. If you want, you can take examples like VMware. After installing the hypervisor, you will have an image of the operating system that you want to run on Windows. Say for example, I have my Ubuntu OS. So after installing the hypervisor, what we will do is we will create virtual machines for this Ubuntu OS. Once you create a virtual machine, the machine will be allocated some RAM, some storage, everything will be allocated to the OS that is running on the hypervisor. So after the resources are allocated to this particular OS, the virtual machine will run separately. So this is happening in a single system. In cloud environments, the same process will happen. So let's start with the first step. Hypervisor is installed on the physical server. Why they are talking about the server here? Because we are in cloud environment. We are installing the hypervisor in one of the servers and not in our local machine. So hypervisor step is step A. The hypervisor like VMware, Hyper-V or KVM is installed to manage and create virtual machine. After that, the virtual machines are created. This is step B. The hypervisor creates multiple virtual machines, each acting like a separate computer. After the virtual machines are created, resources are allocated to virtual machines. When you create, you will be specifying all the resources. Internally, all these things will be assigned to each virtual machine. So this is step C. CPU, memory, storage, network resources are assigned to each virtual machine based on the requirements. After resources are allocated, virtual machines run isolated workloads. This is D. Each virtual machine operates independently, running its own operating system and application securely and in isolation. One virtual machine does not depend on the other virtual machine. So the order will be A, B, C, D, which is available in option number 2. Next question, which of the following are controlled access protocols? We have already seen about controlled access protocols in one of the question paper, which was about multiple access protocols. So let's see the multiple access protocols. It has 3 divisions: random access protocols, controlled access protocols and channelization protocols. Aloha, CSMA, CSMA CD, CSMA CA. Carrier sense multiple access is CSMA, CD is collision detection and CA is collision avoidance. In channelization we have FDMA, TDMA, CDMA, frequency division, multiple access, time division and code division. What about the control access protocols? We have reservation, polling and token passing. Reservation, polling, token passing. TDMA belongs to channelization, CSMA-CA belongs to random access. Option number 2, A, B and D only will be the right answer. Next question, which of the following are examples of data encoding schemes? When it is about encoding schemes, we have come across A, B and E. If you would have practiced previous year question papers, definitely this question wouldn't have taken much time for you. Line coding is the process of converting digital data to digital signals. Data in the form of text, numbers, images, audio, video are stored in computer memory as sequence of bits. Line coding converts a sequence of bits to digital signal. What is actually happening? Data encoding is happening. That's what they have asked in the question. We have these many categories here: unipolar, polar, bipolar, multi-level and multi-transition. Under unipolar we have NRZ and polar also we have NRZ and biphase, and here we have Manchester and differential Manchester encoding, and then bipolar AMI is specified as it is. So option A, B and E are right. Option number 4 will be the right answer. In 2 or 3 previous year question papers we had questions regarding these schemes, so it's better you take an idea about it. Next question, which of the following statements are true about encryption techniques? They have given about symmetric key cryptography, DES technique, two-fish symmetric block algorithm and RC4 stream cipher. So let's see one by one. In symmetric cryptography, the same key is used for both encryption and decryption. The key itself must be kept secret, but the functions are typically public. In the sense, the algorithms are public. Security relies on the secrecy of the key, not the key generation function. Let's see statement A. In symmetric key cryptography, the secrecy or protection of the key generating function must be of higher level than the decrypting function. Since the same key is used for encryption and decryption, you cannot say it is of higher level than decrypting function and all. So this statement is definitely wrong. Let's see about DES technique. The statement says the technique works by taking 64-bit chunk value and 56-bit key over a series of transformations. So let's see data encryption standard. DES operates on 64-bit blocks of data using a 56-bit key plus 8 parity bits that are not used in encryption. It performs 16 rounds of transformation on the data. This statement is perfectly right. What about two-fish symmetric block algorithm statement? It works on variable key length of up to 196 bits over a block of 128 bits. Let's check the statement. 2Fish operates on 128-bit blocks. This is right and supports key length of 128, 192 or 256 bits. They have given up to 196, but 192 is supported as well as 256 is also supported. So let's have a check here. What about D? RC4 is the most commonly used stream cipher that encrypts and decrypts a stream of bits or bytes instead of blocks. RC4 is a widely known stream cipher that processes data byte by byte. This is what is given as stream of bits or bytes. This is fine. It was used in protocols like SSL, TLS and WEP, though it's now considered insecure for many applications. We are not worried about whether it is used today or not. So definitely D is also right. As per the official answer key, they have marked option number 4 to be the right answer. But this part of the statement is right while this is not. So they have given C also as right. Taking this into account, we are marking C to be partially correct. But this is under question mark because the key length supported will be 128, 192 or 256. So variable key length is also right, but the value mentioned here is not right. So taking into consideration, we can mark B and D to be definitely true. A is definitely wrong, but C is partially right and partially wrong. Next question, match list 1 with list 2. So let's start with count to infinity problem. This is a classic routing problem in distance vector protocols. So distance vector routing algorithm will have this problem. A will be mapping to 2. A2 is actually available in 3 of the options. Routers continuously increase the cost to reach an unreachable destination due to outdated or incorrect information, causing a routing loop that delays network convergence. Sometimes the destination might be unreachable because of incorrect information or outdated information. So without that information, the routers will be trying to increase the cost to reach that particular destination. This is actually count to infinity. Infinity in the sense that is unreachable destination. Next we'll get into IEEE 802.16 and 802.15. IEEE 802.16 is the standard for WiMAX, which provides broadband wireless access over long distances. B will be mapping to 3. It is also available in 3 of the options. What about IEEE 802.15? This defines the standards for wireless personal area networks, including Bluetooth. C will be mapping to 4. C is mapping to 4 only in one of the option. Option number 2, A2, B3, C4, D1 will be the right answer. What about AODV protocol? Ad hoc on-demand distance vector is a routing protocol specifically designed for mobile ad hoc networks called as MANETs. D will be mapping to 1 as specified in this option. Next question, match list 1 with list 2. So this is from network security, digital signature, hash function, AES and RSA. So let's start with digital signature. Digital signatures use cryptographic techniques to verify the sender and ensure that data has not been altered. Verifying the sender is called as authenticity and ensuring that the data has not been modified is integrity. A will be mapping to 2. A2 is available in 2 options. What about hash function? Hash functions like SHA-256 take input of any size and produce a fixed length output used for integrity checks. Here the input can be of any size, but the output is of fixed length. This can be equated to produces a fixed size digest. Whenever you have output in such cases, it will be called as digest only. So B will be mapping to 3. B3 is also available in 2 options. What about AES and RSA? AES, Advanced Encryption Standard, uses the same key for both encryption and decryption. When we use same key, it comes under symmetric encryption algorithm. C will be mapping to 4. C4 is available only in one option. What about RSA? RSA uses a public-private key pair. So there are two keys involved here. RSA uses a public-private key pair for encryption and decryption. It is widely used for secure key exchange and digital signatures. So RSA comes under asymmetric encryption algorithm. D will be mapping to 1. D1 is also available only in one option. Option number 2 will be the right answer. So with this we are completing Unit 9 questions. Let's solve Unit 10 Artificial Intelligence questions. Which of the following is not a valid property over two fuzzy relations R and S which must be obeyed for performing lambda cut defuzzification? Actually, this question paper contains questions on fuzzy sets, genetic algorithms. Earlier previous year question papers, maybe for 2 or 3 sessions, we had lot of questions on artificial neural networks. I think in one question paper there were lots of genetic algorithm questions. After that for 2-3 sessions they gave vacation for it, and again genetic algorithm gets more focus here. Maybe the one who sets the question paper based on their own taste it is happening, I think. So let's get into the details now. Lambda cut defuzzification. What is it? In fuzzy logic, a fuzzy relation R maps pairs of elements from sets X and Y to a membership value that is lying in the range between 0 and 1. So in fuzzy sets, we have degree of membership. The values are between 0 and 1. In set it is either present or not. In fuzzy set it is how far it is a member. So the degree of membership is in decimal point between 0 and 1. Lambda cut of a fuzzy relation is a crisp set that includes all elements whose membership degree is at least lambda. Just for example I am telling you, just for understanding I am telling you. You have value like 0.3, 0.5, 0.7 and the lambda value is going to be 0.45. If it has at least lambda means only these two values will be taken under lambda cut, that is 0.45 cut, because it is having at least 0.45 as degree of membership. Now they are asking about which is not a valid property. Basically we have to know what is fuzzy set. Then we have to know what is defuzzification. In that we have to understand what is lambda cut defuzzification. How in fuzzy set suddenly fuzzy relation came. All these things will be running in your mind if you literally have no idea on fuzzy sets. Even if you have idea on fuzzy sets, you will forget about fuzzy sets when you find all this lambda cut and all. That too when you see these many symbols in the options, even if you are very much thorough with this particular concept, you will not be able to answer the question. This is a panic creating question, I would say. I cannot start from scratch and take you to the property, so we'll just see the options. The first option, union, is given here. The lambda cut of the union of two fuzzy relations equals to the union of their individual lambda cuts. These are the individual lambda cuts. This is the union of two fuzzy relation. Two relations are taken under union and it is given the lambda cut here. But here the relations have lambda cut individually and then they are combined in union. This union property is true, so we can mark option 1 to be true. I am just giving you the description of this particular symbol that is present in the option. Let's get into the intersection option now. The lambda cut of the intersection, this one, equals the intersection of the lambda cuts, this one. This is also true. Next we will get into the fourth property. This is called monotonicity of lambda cuts property. As lambda decreases, the lambda cut includes more elements, so higher lambda cuts are subsets of lower ones. See, now we are going to decrease this value to 0.3. This will include all the three values. What happens here? When I decrease the lambda value here, the lambda cut will include more elements. Earlier it had only 2 elements, now it is having 3 elements. So higher lambda cuts, that is the one with 0.5 and 0.97 here, which is 0.45 value for lambda, are subsets of lower one, means the lower value had 3 elements 0.3, 0.5 and 0.7. Is this the higher value one subset of this one? Yes, it is a subset. This is the monotonicity property of lambda cuts. For any lambda that is less than or equal to a beta value, where beta lies between 0 and 1, it is true that the relation with the beta value, take this to be 0.3, the lambda value, and this to be 0.45. Now you can understand the statement from the example. The relation with beta value 0.45 has only 2 elements. That is a subset of the relation with the lambda cut value, which is 0.3, which has 3 elements now. So this is a subset of this one. This particular higher value is a subset of the lower ones, which is given here. So this property is also true. From this we can say option number 3 will be the right answer, because rest of the 3 options are right. Now we will see what is the problem with 3. Even at lambda is equal to 1, the lambda cuts of a fuzzy relation and its complements are not equal. They are disjoint. This particular property is true. They are not equal. They are disjoint. This is true. They have given exception as lambda is equal to 1. This is actually wrong and this is right. It means they say even when lambda is equal to 1, this particular property is holding true. But in the statement they have given except, which is wrong. How will you find complement of a particular fuzzy set? When you have a value called 0.3, the complement will be 1 minus 0.3, which will give you 0.7. Can this be equal at any point? No. Whatever is present here will not be present here. That is the case. If you take this to be double complement, say for example, instead of this symbol, if we have this to be double complement, this one is not equal to this one is true. Except for this condition is what we can say false. In case if this is going to be relation complement not equal to the complement of the relation, fuzzy relation is given in this way and this is a set relation. You can take it in this way. Set values will be either in or not. Say for example, if an element is present in complement, it will not be present. It is just 0 and 1. But here the case is degree of membership. So when we have 0.3, the complement will have 0.7. So this value will not be equal to this value is totally true, irrespective of any lambda value is what we can understand. So somehow we know 1, 2 and 4 are correct. So based on that we say 3 is wrong as per the notation that is given in this particular question paper. Next question. Which of the following is not a parent selection technique used in genetic algorithm implementations? So let's see the parent selection techniques first. We have already discussed about genetic algorithm phases, the selection technique related problems and all. So I am not getting into the usual genetic algorithm explanation. I am directly getting into the parent selection technique here. We have roulette wheel selection. Here the probability of selection is proportional to fitness. Next we have stochastic universal sampling. This is a more stable version of roulette wheel with multiple selection points. Have you seen about roulette wheel? You will be rotating a wheel and it will be going and pointing a particular person. So that one is roulette wheel. Next we have tournament selection. It randomly selects a group and picks the best among them. Tournament is available in option 2. So it's a parent selection technique. Next we have rank selection. Individuals are ranked by fitness. Selection probability depends on rank. So rank selection is definitely a technique. Next we have Boltzmann selection. This uses a simulated annealing principles to balance exploration and exploitation. So this is also definitely a technique. Next we have truncation selection. This selects top percentage of individuals based on fitness. And we have elitism technique automatically carries forward the best individuals to the next generation. So what is not a technique here? Option 1, radial will be the right answer, but it is not a parent selection technique. I managed to collect the parent selection techniques alone. I did not get into some reference books. It was some web references only. Next question, given that eta refers to learning rate, this symbol is mathematically called as eta. And xi refers to the ith input to the neuron. Which of the following most suitably describes the weight updation rule of a coherent self-organizing map called as SOM, where J refers to the jth neuron in the lattice. So there are two indices I and J. I refers to the ith input and J refers to the jth neuron in the lattice. If you have seen about SOMs in unit outline videos, you could have seen the lattice formation, how they are organized, but that is about general self-organizing maps. Now we'll just get into a learning and then mark the answer. A coherent self-organizing map is an unsupervised neural network model that transforms high-dimensional input data into a low-dimensional, usually two-dimensional grid of neurons. So transforming high dimensional to 2D is what we call as self-organizing map. What are the terms used here? We have something called weight vectors. They represent the memory or prototype of each neuron. When an input vector is presented, the network identifies the best matching unit called BMU, the neuron whose weight vector is closest to the input. Then we update the weights of the best matching unit and its neighbors to make them more similar to the input. When you are converting from high dimensional to 2D, you should make them more or less similar. So for that purpose only we are updating the weight. The weight updation rule is given by new weight of the jth neuron will be equal to 1 minus eta into the old weight of the jth neuron plus eta into xi, the ith input of the neuron. So let's see the terms here. Eta will be the learning rate. It controls how much the weights adjust towards the input. When the eta value is small, we can say slow learning and more stability. When the eta value is large, it goes for a faster adaptation where we can have the risk of instability. So just check which option is actually equivalent to the given weight updation rule. We have 1 minus eta in 2 of the places, so the remaining 2 options can be taken down. And here we have eta into xi and here it is just xi. So we will also rule out option 3. Option number 1 will be the right answer. So when you see the diagram, you can understand how wij is coming. We would have worked in unit outline video. So if you don't understand Tamil, you can just look at the PDF that is available in my blog. That PDF is actually free for online viewing. So anybody can go and view it. Consider the following table defining the sample inputs and corresponding target values for a perceptron model. What shall be the value of the updated weights? After applying all the samples S1 to S4 in the order S1, S2, S3, S4 to this model. Given that the initial weights W1 is equal to 0, W2 is equal to 0. So there are two sets here, X1 and X2. X1 will be for W1, X2 will be for W2. Learning rate is equal to 0.1 and no bias is involved in the perceptron. The activation function for this perceptron is given below. Y observed is equal to 1 if Y in is greater than 0. Y observed is equal to 0 if Y in is less than 0. First we'll understand what is a perceptron. It's a type of artificial neuron designed for binary classification. It decides whether an input belongs to one of the two categories, just like spam versus not spam. So one will be given the value of 0 and the other will be given the value of 1. Weights are updated only when there is an error. When there is no error, the weight will be carried over. But when there is an error, we have to go for weight updation. How will we get the new weight? The new weight is given by the old weight plus learning rate into target minus output into the input value. What is this target minus output? It is the error. Error is equal to target minus output. So how can we write this? Is new weight is equal to old weight plus learning rate is given by 0.1 into the error into x, the input, x1 or x2 based on that. When you are calculating for w1, you have to use x1. When you are calculating for w2, you have to use x2. That is the thing. So error is equal to target minus output. Now we will understand what is target and what is output. Target is the correct label for the input. It will say whether it is 0 or 1. What is output? It is what the perceptron predicts after applying the activation function. What is actually this neural network model? We are actually giving training to the data. When we give training, we will give this is the actual output. But output is the predicted output. This is like actual and this is like predicted. So when the predicted output and actual output are going to be same, there is no error and you need not update the weight. But when there is a difference between the actual output, the target value and the predicted output, which is the output value, then you have to go for weight updation process. So this is the concept of this particular question. Now we will get into the working. Let's take the sample. How will we calculate y in? This is usually done by y is equal to w1 x1 plus w2 into x2. Output is based on y observed. So we will start working and you will understand how to do this. Let's start with S1 now. S1 means let's take this particular value. X1 is equal to 0, x2 is equal to 0 and we have target is equal to 0. So the actual value is 0 here and we have weights as w1 is equal to 0 and w2 is equal to 0 for this particular sample. Now we have to find y in. w1 is 0, x1 is also 0 plus w2 is 0, x2 is also 0. What is 0 into 0? 0. 0 plus 0 into 0 is again 0, which will give you 0. This is the output value. Whatever you get here will be output value. Let me name it this way. What is the error here? Error is equal to target is 0. The output is this particular column's value, which is 0, which is equal to 0. Weights are updated only when there is error. Since the error is given as 0, we will take it as no error. So, no change in the weights. So, here also we will have W1 is equal to 0 and W2 is equal to 0. This value will be used for the next sample. Now, let's take S2. What are the values of X1, X2 and target? X1 is equal to 0, X2 is equal to 1 and target is equal to 1. You have to remember that W1 is equal to 0 and W2 is also equal to 0. Yin is equal to, what is W1? It is 0. What is X1? 0. Plus W2 is 0. X2 is 1. 0 into 0 is 0. Plus 0 into 1 is again 0. What is the output value here? It is 0. Now we have to calculate error. What is target? It is given as 1. We are picking the value from this tabular column. So we have 1 minus the output is given as 0. We have error value as 1. When there is an error, the weight has to be updated. How will we update the weight? Let's take W1. W1 is equal to W1's old weight, which is 0 plus the learning rate is 0.1 into error is 1 into the x1 value is taken to be 0. So 0 plus anything into 0 is 0. 0 plus 0 will give you 0. Here we have W1 is equal to 0. What about W2? W2's old value will be 0 plus the learning rate is 0.1 into error is 1. What about x2 value? We have 1. So this will be into 1. 1 into 1 is 1. 1 into 0.1 is 0.1. So here it is 0 plus 0.1, which will give you 0.1. Now we have W2 is equal to 0.1. These are the updated weights. Now we'll go for the next sample S3. Take this row now. X1 is equal to 1, X2 is equal to 0, target is equal to 1. Now we have different value for W2, so we have to apply this in S3 here. Yin is equal to W1 into X1, 0 into 1 plus W2 into S2, 0.1 into 0. 0 plus 0, which is equal to 0. Now error will be target is 1, output is 0, which is equal to 1. So there is error again. We have to update the weights. W1 new value will be W1's old value, which is 0, plus learning rate is 0.1 into error is 1 into what is X1 value? It is 1. 1 into 1 is 1, 1 into 0.1 is 0.1. So 0 plus 0.1 will be 0.1. Now W1's weight is also 0.1. What about W2? The earlier weight will be 0.1 from here. Learning rate is 0.1 into what is error? It is 1. What about X2 value? It is 0. So anything into 0 will give you 0. This will be 0.1 plus 0, which is equal to 0.1. So here W2 value is also taken as 0.1. So let's update the value. In S2, W1 is 0, W2 is 0.1. Now after computing S3, W1 is 0.1 and W2 is 0.1 again. Both the values are 0.1 now. With this value, now we are working for S4. If you are not clear with what I am writing, you can take a piece of paper and work it on your own. All the values are given in the screen. The formulas are given here very clearly. Let's take S4 row now. All the values are 1 here. X1 is equal to 1, X2 is equal to 1, target is also equal to 1. How will we calculate Yin now? W1 into X1. So it is 0.1 into X1 plus W2 into X2, 0.1 into 1. So this is 0.1 plus 0.1, which will give a value of 0.2. Here you have to look this particular activation function. Earlier we had 0 for Yin value. Since we had 0, we just marked it as 0. Now 0.2 is actually greater than 0. Since 0.2 is greater than 0, now the output will have a value of 1. That is, Y observed will have a value of 1. Since Yin is greater than 0, the output value will be 1. Now take the error. The target is given as 1. Output is also given as 1. And now error is 1 minus 1, which is equal to 0. What is 0 error? There is no error. If there is no error, there is no change in the weight. It means W1 value is retained as 0.1. W2 value is retained as 0.1. So we are having the same set of values. What is the question? What shall be the value of updated weights after applying all the samples in the order S1, S2, S3, S4 to this model? So what is the final set of weights we have got in W1 and W2? W1 is equal to 0.1, W2 is equal to 0.1. It is available in option number 1. Option number 1 will be the right answer. Always remember, when you get 0, you can stay in 0 itself. But when you have a value greater than 0, 0.2 is greater than 0. So you have to take Y observed value as 1. So instead of Y observed, I am just treating this as output value. So based on Yin value only, we are deciding the output value. So if you have not understood about this output value in the first 3 rows, at least in this row you would have understood. Next question. Consider the following steps used by a knowledge-based designer to represent a world. A knowledge-based designer builds structured representations of information about a specific domain. Already we had a similar question in the previous year question paper. The first step is to choose a task domain. Decide what world or area the knowledge base will represent. So we are starting with C. We can rule out 3 and 4. After selecting the task domain, we have to select atoms to represent propositions. Identify the basic building blocks, facts, variables, predicates relevant to the domain. After C, we are going with A. So let me mark here. The next step is to axiomatize the domain. We have to define rules, truth values and logical relationships that govern the domain. This is D. It is available in option 1 and not in 2. So we will rule out even option 2. The final step here is ask questions about intended interpretation. Refine and validate the representation by checking how the system interprets propositions. In fact, if you take the previous year question paper where I would have compared this to propositional logic, take a domain of integers, then select some variables for proposition, then define rules or logical relationship for the proposition, then ask questions about the proposition is whether they are true or not. This is how I would have compared it to knowledge base and then given you examples on propositional logic. So even if you don't have idea about knowledge base, just use propositional logic knowledge and then answer this question. So we will go with option number 1, CADB as the right answer. Next question, consider the following steps involved in the application of genetic algorithm for a problem. So it's about application of genetic algorithm. The first step will be calculating fitness of each member of the population. Here we will be evaluating how good each candidate solution is using a fitness function. So C will be coming first. We can rule out 1 and 4. The next step will be selecting a pair of parents from the population. Choose individuals based on fitness to reproduce. Example, the parent selection techniques like tournament selection and roulette wheel selection can be used. So we have already seen about the parent selection techniques in the same question paper here. So the next step will be A. C followed by A is in both the option. Then we have apply crossover with probability PC to form offsprings. Combine genetic material from parents to create new individuals. This is the next step. So here we are calculating fitness. Then we are getting into selection. Now we are in crossover. What is the remaining step as per the cycle? It is mutation. The final step will be apply mutation at each locus with probability PM. Introduce small random changes to maintain diversity and avoid local optima. This will be B. CADB is available in option 2. The same order as the previous question but given in different option. We will rule out even 3. Option number 2. CADB will be the right answer. So what is the sequence of steps here? This is the phase of genetic algorithm. So in genetic algorithm, we will be having fitness calculation, selection of individuals as parents. Then we will get into crossover operation to produce offsprings. Then we will go for mutation operation. So if you have the genetic algorithm in your mind, you will be able to answer this question even though they have given application of genetic algorithm for a problem. Next question. Consider the following statements regarding agent systems. Let's start with A. Agent system comprises of an agent and an environment on which it acts. The basic definition actually has this particular statement, so definitely A is true. The only option that has A true is option number 1. If you are sure about this statement without looking the other options, you can go with option number 1. A, B only will be the right answer. Now we will see what is right about B. The controller part of an agent receives, percepts from its body and sends commands to the environment. Percepts means the inputs received by an agent from its environment at a given moment. So receives percepts can be taken as receives inputs. How does it receive input? Using the sensors. It gathers percepts from the environment using the sensors. The controller will be processing the percepts and decide actions. The actuators actually execute the actions in the environment. So this is getting the input, this is deciding what to do, and this will be doing what it has to do. So B is also right. What about C? Agents act in the world through actuators which are non-noisy and always reliable. This is not true. In real world systems, actuators can be noisy. Their actions may not always produce perfectly predictable results due to uncertainty, mechanical limitations, or environmental interference. It is not always reliable. So both these aspects are false. So C is definitely wrong. Let's get into D. The actuators of an agent, the one that executes actions, convert stimuli into percepts. This is wrong. Only with the percepts you are actually deciding the action. Then how will the actuators convert stimuli to percepts? Sensors convert stimuli to percepts. This is the work of sensors. D is definitely wrong. Actuators perform actions based on decisions made by the agents. So if you know these 3 points, you can say D is false and B is true. Converting the stimuli into percepts. So these percepts become the input, and based on the input, the controller will decide the action, and that action will be executed by the actuators. Actuators are action performers. Next question. Consider the following statements regarding strips representation of a planning problem. This strips representation has a lot of details in unit outline videos. So if you want, you can refer the unit outline PDF that is available in my blog. Let's start with A. Strips is a feature-centric representation. It is wrong. Strips is an action-centric representation focusing on how actions transform the state of the world. So this particular part is wrong. A is definitely wrong. So 2 options can be ruled out here. The second one, the features describing state of the world are divided into primitive and derived. This is true. Strips distinguishes between primitive features which are directly affected by actions and derived features which are inferred from primitive ones using logical rules. So definitely B is right. What about C? The strips representation of the action comprises of precondition and effect. This is also true. Each action in strips is defined by preconditions and effects. What are preconditions? What must be true for the action to occur? The condition before the action is occurring. Effect means what changes in the world after the action. What has been added and what has been deleted. That part is given by effect. So if you have action here, we have precondition here and effect here. You can take it in this way. Statement C is also right. Now we have to check whether B is right or not. Strips can directly define conditional effects. No. Strips does not support conditional effects directly. It assumes that effects are unconditional. If the action is executed, all its effects will occur. Action is defined by precondition and effects. What changes are possible after the action is given? So they say it is about conditional effects, but here they say the effects are unconditional. Taking this particular term as wrong, we can say D statement is wrong. From this we can say A and D are wrong, so B and C are correct. Option 4 is also ruled out. Option number 2, B, C only will be the right answer. Next question, match list 1 with list 2. Operations on fuzzy sets are given in list 1 and the descriptions are given in list 2. We have intersection, bounded sum, bounded difference and algebraic sum. When you take fuzzy set operations for union, you will be calculating the maximum of membership, and for intersection you will be calculating the minimum of membership. Which of the options in list 2 is talking about minimum of degree of membership? It is option 4. A will be mapping to 4. Even if you have no idea about bounded sum, bounded difference, algebraic sum, you can answer this question only with A4 because A4 is available only in one option. The intersection of two fuzzy sets A and B is a fuzzy set where the membership of each element is the minimum of its memberships in A and B. Now we will learn about the other terms. The algebraic sum of two fuzzy sets combines their memberships while adjusting for overlap. It will combine both the membership while adjusting for overlap is this particular difference of the product. So algebraic sum D will be mapping to 1. D1 is available here. What about bounded sum and bounded difference? The bounded sum adds the memberships of two fuzzy sets but caps the result at 1. The value of fuzzy logic should not go below 0 and greater than 1. So when you go for sum, that is plus operation, the value may exceed 1, but they say the value can be minimum of 1 or the sum. So if the value exceeds 1, this minimum of 1 comma the value will cap the result at 1 is what they say. Say for example, if the membership has 0.5 and 0.6, it will result in 1.1. So 1 and 1.1's minimum value will be equal to 1. B will be mapping to 3. What about bounded difference? The bounded difference subtracts the membership of one fuzzy set from another but does not allow negative values. Sometimes 0.1 minus 0.2 can be the case. So they are using maximum of 0 and a negative value. So if this is going to be the case, 0 comma minus 0.1, when you take the maximum value, automatically you will stick to 0. When maximum function is taken for 0 and a negative value, 0 will be the result. When you take minimum for 1 and a value greater than 1, it will result in 1. So this is for difference and this is for sum. C will be mapping to 2. C2 is available here. Option number 3. A4, B3, C2, D1 will be the right answer. Next question. Match list 1 with list 2. Genetic algorithm termination criteria is given in list 1 and the descriptions are given in list 2. You can remind yourself about the genetic algorithm cycle and then find the termination criteria that will check whether to continue the algorithm or stop with it. So here these are the terms that involve termination criteria. These criteria help decide when to stop the algorithm based on the fitness of individuals in the population. So we will start with best individual that is given in option B. Best individual ensures that at least one solution is excellent, which can be enough for convergence in some problems. Faster search convergence guaranteeing at least one best solution. The key term is here. B will be mapping to 4. So B4 is available only in option 1. From here itself we can conclude option number 1 will be the right answer. Now we will get into worst individual. If even the worst meets the standard, the whole population is acceptable. This can be equated to guarantees that the entire population to be of a minimum standard. So even if you take the worst individual, they would have met the particular standard. So worst individual A will be mapping to statement 3 in list 2. A3 is available only in first option. Next we will see about median fitness. It reflects the central tendency. If the median meets a threshold, at least half the population is performing well. At least half of the individual will be better than or equal to the convergence value. D will be mapping to 1. D1 is here. Now we will get into sum of fitness. Sum of fitness gives an overall measure of population quality, ensuring most individuals are within a desired range. Guarantees that virtually all individuals in the population will be within a particular fitness range. So this desired range and fitness range will be the key term for sum of fitness. C will be mapping to 2. C2 is again available only in one option here. Option 1 A3, B4, C2 and D1 will be the right answer for this question. With this, we are completing Unit 10 questions.